January 2020 in order to comply with FAA regulations. Between 2007 and 2009, one of our UAVs, known as Icana, flew over thick smoke and haze to record hotspots and the progression of wildfires in California. Data from the aircraft sensors was downlinked and overlaid on Google Earth maps, then transmitted in near real time to the Interagency Fire Center, where it was made available to fire incident commanders to assist them in allocating their firefighting resources. The effects were dramatic enhancements for the fire crews. Armstrong also operates two early model Global Hawks, another type of UAV. These aircraft can fly long distances, remain airborne for up to 32 hours, and can carry large payloads of instruments into areas such as hurricanes that are too dangerous for scientists to fly in. NASA has long been involved in Earth science research, and the Armstrong Flight Research Center operates a variety of aircraft to support this directive, including two ER-2s, a DC-8, and a C-20, as well as the large UAVs. These aircraft are equipped with instruments that researchers use to obtain measurements of environmental phenomena, such as the thickness of ice sheets, precipitation, and air quality. Measurements and readings are often combined with global satellite observations and ground sampling to better understand these environmental conditions. In the 1990s and early 2000s, Armstrong tested hybrid propulsion technology in the hopes of making aviation greener. Other NASA aeronautical research has improved fuel efficiency, lowered noise levels, and reduced harmful emissions. But much more can be done in these areas. That's why NASA implemented the Environmentally Responsible Aviation Project to explore and document the feasibility, benefits, and technical risks that will further reduce the impact of aviation on the environment. The goal is to reduce aircraft fuel consumption, emissions, and noise simultaneously, a much more difficult challenge than working to reduce them individually. As part of this project, NASA Armstrong performed ground tests with its DC-8, measuring emissions and fuel performance of biofuels. Results indicated as much as a 50% reduction in emissions at takeoff thrust, a difference which could significantly improve the air quality around airports. And we are currently working on an adaptive compliant trailing edge flight experiment that will demonstrate a single, non-rigid wing flap that can be flexed in different ways. This leads to more efficient control methods when airborne. Flying from 2007 to 2013 at Armstrong, the X-48 subscale hybrid wing body was another program in NASA's environmentally responsible aviation portfolio. NASA, Boeing Phantom Works, Cranfield Aerospace of the UK, and the Air Force Research Laboratory partnered to study the structural, aerodynamic, and operational advantages of the hybrid model, sometimes called a blended wing body. The concept is a cross between a conventional aircraft and a flying wing. The design has the potential to yield up to 30% better fuel economy than traditional aircraft due to its unique shape. The Stratospheric Observatory for Infrared Astronomy, known as SOFIA, is a partnership between NASA and the German Aerospace Center DLR. The flying observatory consists of a highly modified 747 SP former airliner carrying a 17 metric ton German-built infrared telescope. Missions are flown at altitudes between 39,000 and 45,000 feet, putting the telescope above 99% of the Earth's water vapor. Being able to reposition the telescope anywhere on Earth is a unique capability. Not long ago, for example, it enabled astronomers to chase Pluto's shadow as it moved across the Earth, and SOFIA was able to study the dwarf planet for a much longer period of time than a stationary observatory. The aircraft, flown out of Armstrong's Palmdale hangar, is making infrared astronomy missions available to the international science community. Armstrong Flight Research Center flies modified high-performance aircraft as testbeds for a variety of flight research experiments. In the 90s, we used F-18s to test and demonstrate thrust vectoring, which is a standard feature on today's F-22. We used F-15s for a series of experiments on intelligent flight control systems, a variation of which appears on the F-35. This system makes it possible to recover from what otherwise would be catastrophic failure of equipment, systems, or even portions of the aircraft itself.
Pull up, pull up. Altitude.
Long involved in aviation safety, NASA Armstrong, working with the U.S. Air Force, has been developing automatic collision avoidance technologies for over 20 years. The most recent version of automatic collision avoidance technology, or ACAT, flew on an Air Force F-16D. This integrated hardware and software system is designed to detect and avoid ground collisions.
Flight path marker, please.
In an effort to introduce this development into general aviation, researchers at Armstrong have been using a small UAV, Droid, to demonstrate the ability to implement it using common cell phone technology, which provides for low cost and high accessibility.
30.
From its very inception, NASA Armstrong has explored supersonic flight. Today, the goal in this field is to enable supersonic transportation over land. Because planes traveling at supersonic speeds cause sonic booms, which are potentially disruptive to people and structures on the ground, our researchers are working to minimize the boom's impact at ground level. We conduct tests of future supersonic wings and aerodynamic designs, as well as research into the effects of sonic booms on structures and people in pursuit of our goal to one day achieve quiet or low-level sonic booms. Armstrong continues to apply flight research and test techniques to new launch systems, harboring innovative ideas that are now under study and will rapidly be brought to flight. NASA Armstrong also manages the agency's Flight Opportunities Program, created to provide opportunities for space technologies to be demonstrated and validated in relevant environments. In 2011, 7 companies were selected to integrate and fly a variety of technology payloads at reduced costs, a central goal of the program. These payloads, flown on reusable commercial vehicles near the boundary of space, are helping to pave the way for future space exploration. NASA has shifted its approach to space exploration. The agency is partnering with a variety of private companies to develop cost-effective crew and cargo transportation to low Earth orbit, known as LEO. Sierra Nevada Corporation's Dream Chaser space system, which has already done flight testing here at Armstrong, is one example of this. With increased reliance on private industry for LEO transportation, NASA will be able to focus on deep space exploration, taking us into outer space farther than we have ever been before. So, as you can see, there's a lot more to NASA than space exploration. NASA works every day to solve the challenges that still exist in our nation's air transportation system. With green aviation, the agency is helping create safer, cleaner, and more effective travel for everyone through fuel-efficient flight planning and the reduction of aircraft fuel consumption, emissions, and noise. Here at NASA's Armstrong Flight Research Center, we are conducting an unprecedented array of science missions that will seek new knowledge and understanding of Earth, the solar system, and the universe. At Armstrong, we are pioneers, taking the first step in proving new flight technologies, which have practical implications here on our planet, and improve our ability to explore beyond. As far back as the 1960s, NASA Armstrong pioneered the use of a ground control station from which to fly unmanned aerial vehicles, known as UAVs. Becoming increasingly common today, these aircraft are used by the center to develop technology that allows them to see one another and automatically take evasive action to avoid collisions. Known as Automatic Dependent Surveillance Broadcast, or ADS-B, This tracking technology is something that all aircraft operating in U.S. airspace must adopt by January 2020 in order to comply with FAA regulations. Between 2007 and 2009, one of our UAVs, known as Icana, flew over thick smoke and haze to record hotspots and the progression of wildfires in California. Data from the aircraft sensors was downlinked and overlaid on Google Earth maps, then transmitted in near real time to the Interagency Fire Center, where it was made available to fire incident commanders to assist them in allocating their firefighting resources. The effects were dramatic enhancements for the fire crews. Armstrong also operates two early model Global Hawks, another type of UAV. These aircraft can fly long distances, remain airborne for up to 32 hours, and can carry large payloads of instruments into areas such as hurricanes that are too dangerous for scientists to fly in. NASA has long been involved in Earth science research, and the Armstrong Flight Research Center operates a variety of aircraft to support this directive, including two ER-2s, a DC-8, and a C-20, as well as the large UAVs. These aircraft are equipped with instruments that researchers use to obtain measurements of environmental phenomena, such as the thickness of ice sheets, precipitation, and air quality. Measurements and readings are often combined with global satellite observations and ground sampling to better understand these environmental conditions. In the 1990s and early 2000s, Armstrong tested hybrid propulsion technology in the hopes of making aviation greener. Other NASA aeronautical research has improved fuel efficiency, lowered noise levels, and reduced harmful emissions. But much more can be done in these areas. That's why NASA implemented the Environmentally Responsible Aviation Project to explore and document the feasibility, benefits, and technical risks that will further reduce the impact of aviation on the environment. The goal is to reduce aircraft fuel consumption, emissions, and noise simultaneously, a much more difficult challenge than working to reduce them individually. As part of this project, NASA Armstrong performed ground tests with its DC-8, measuring emissions and fuel performance of biofuels. Results indicated as much as a 50% reduction in emissions at takeoff thrust, a difference which could significantly improve the air quality around airports. And we are currently working on an adaptive compliant trailing edge flight experiment that will demonstrate a single, non-rigid wing flap that can be flexed in different ways. This leads to more efficient control methods when airborne. Flying from 2007 to 2013 at Armstrong, the X-48 subscale hybrid wing body was another program in NASA's environmentally responsible aviation portfolio. NASA, Boeing Phantom Works, Cranfield Aerospace of the UK, and the Air Force Research Laboratory partnered to study the structural, aerodynamic, and operational advantages of the hybrid model, sometimes called a blended wing body. The concept is a cross between a conventional aircraft and a flying wing. The design has the potential to yield up to 30% better fuel economy than traditional aircraft due to its unique shape. The Stratospheric Observatory for Infrared Astronomy, known as SOFIA, is a partnership between NASA and the German Aerospace Center DLR. The flying observatory consists of a highly modified 747 SP former airliner carrying a 17 metric ton German-built infrared telescope. Missions are flown at altitudes between 39,000 and 45,000 feet, putting the telescope above 99% of the Earth's water vapor. Being able to reposition the telescope anywhere on Earth is a unique capability. Not long ago, for example, it enabled astronomers to chase Pluto's shadow as it moved across the Earth, and SOFIA was able to study the dwarf planet for a much longer period of time than a stationary observatory. The aircraft, flown out of Armstrong's Palmdale hangar, is making infrared astronomy missions available to the international science community. Armstrong Flight Research Center flies modified high-performance aircraft as testbeds for a variety of flight research experiments. In the 90s, we used F-18s to test and demonstrate thrust vectoring, which is a standard feature on today's F-22. We used F-15s for a series of experiments on intelligent flight control systems, a variation of which appears on the F-35. This system makes it possible to recover from what otherwise would be catastrophic failure of equipment, systems, or even portions of the aircraft itself.
Pull up, pull up. Altitude.
Long involved in aviation safety, NASA Armstrong, working with the U.S. Air Force, has been developing automatic collision avoidance technologies for over 20 years. The most recent version of automatic collision avoidance technology, or ACAT, flew on an Air Force F-16D. This integrated hardware and software system is designed to detect and avoid ground collisions.
Flight path marker, please.
In an effort to introduce this development into general aviation, researchers at Armstrong have been using a small UAV, Droid, to demonstrate the ability to implement it using common cell phone technology, which provides for low cost and high accessibility.
30.
From its very inception, NASA Armstrong has explored supersonic flight. Today, the goal in this field is to enable supersonic transportation over land. Because planes traveling at supersonic speeds cause sonic booms, which are potentially disruptive to people and structures on the ground, our researchers are working to minimize the boom's impact at ground level. We conduct tests of future supersonic wings and aerodynamic designs, as well as research into the effects of sonic booms on structures and people in pursuit of our goal to one day achieve quiet or low-level sonic booms. Armstrong continues to apply flight research and test techniques to new launch systems, harboring innovative ideas that are now under study and will rapidly be brought to flight. NASA Armstrong also manages the agency's Flight Opportunities Program, created to provide opportunities for space technologies to be demonstrated and validated in relevant environments. In 2011, 7 companies were selected to integrate and fly a variety of technology payloads at reduced costs, a central goal of the program. These payloads, flown on reusable commercial vehicles near the boundary of space, are helping to pave the way for future space exploration. NASA has shifted its approach to space exploration. The agency is partnering with a variety of private companies to develop cost-effective crew and cargo transportation to low Earth orbit, known as LEO. Sierra Nevada Corporation's Dream Chaser space system, which has already done flight testing here at Armstrong, is one example of this. With increased reliance on private industry for LEO transportation, NASA will be able to focus on deep space exploration, taking us into outer space farther than we have ever been before. So, as you can see, there's a lot more to NASA than space exploration. NASA works every day to solve the challenges that still exist in our nation's air transportation system. With green aviation, the agency is helping create safer, cleaner, and more effective travel for everyone through fuel-efficient flight planning and the reduction of aircraft fuel consumption, emissions, and noise. Here at NASA's Armstrong Flight Research Center, we are conducting an unprecedented array of science missions that will seek new knowledge and understanding of Earth, the solar system, and the universe. At Armstrong, we are pioneers, taking the first step in proving new flight technologies, which have practical implications here on our planet, and improve our ability to explore beyond.
Humanity has always been interested in exploration. If we really want to go to the moon, we have got to figure out a way to keep our propellants cold long enough. My name is Monica Guzik, and I have the coolest job at NASA because I work with cryogenics. Cryogenics is the study of things at very low temperatures. We've got electrical connectors we can plug into. So we want to store things like oxygen or hydrogen, but if you store them as a gas, the only way to get a whole bunch of molecules in there is to raise the pressure really high. So instead, if we make them really, really cold, they turn into a liquid, so they're way more efficient to store. So this is going to be a liquid oxygen test. I always knew I wanted to be an engineer since I was a little girl. My dad was an engineer, and I just thought engineering was so cool. We were going to put insulation over this. Ended up getting a summer internship here at NASA Glenn Research Center in Cleveland, and just really sort of fell in love with NASA. Cleveland is the rock and roll capital of the world. I really enjoy rock and roll music, so I try to go to a lot of concerts. When we improve cryogenic technologies for space applications, it always has a trickle-down effect to the Earth. Now we're rolling into the Artemis generation, and we're still doing that.
STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Chris Gunn.
Hey, STEM fans, welcome to this week's episode of STEM Stars. It's a chance where we get a moment or time to reflect and see what's going on at NASA and chat with STEM professionals from all across the agency. I'm so excited to welcome our guest today. But before we get started, my name's Jen Hudgens, and I'm coming to you from the Kennedy Space Center in Florida. It's a little bit rainy today, but we're going to keep that rain away. We're going to talk about something exciting, the James Webb Space Telescope. So our guest today is Chris Gunn. He is a photographer with the program and with NASA. So I'm really excited to find out what you actually do as a photographer when you work for NASA. And I want to share with you what our agenda is going to be for today. So we're going to chat with Chris. We're going to meet him, find out what his background is, his education, find out how he got started as a photographer at NASA. You'll have a chance to ask all the questions that you have in the chat box. And we're going to learn more about what your mission will be at the end of today's episode, and then what's going to be on next at NASA STEM Stars. So if you have any questions along the way in today's chat, drop them in the box and we'll get those to Chris as soon as possible. So welcome, Chris. How are you doing today?
I'm doing great. Glad to be here.
So you work out at the Goddard Space Flight Center in Maryland. So hopefully your weather is a little bit better than ours today.
It's really,
do you mind
really nice.
sharing? Oh, good. I'm glad to hear that. I wish it was nice here. Ugh, it's thundering and lightning and storming outside. So tell us a little bit about yourself and what are you interested in outside of your job at NASA as a photographer?
Well, I'm Chris Gunn. I do work at NASA's Goddard Space Flight Center as a photographer. I really enjoy cycling on my off time and working on cars. My interests outside of work tend to revolve around science and science communication, just learning more and more about science of all types, especially space exploration and photographic art.
Can you talk a little bit about science communications? What does that entail?
Science communications, I guess, is what really got me involved in science to begin with. When I was a kid, I loved reading. And I loved reading books that made science digestible for me, that I could understand. And I think science communications revolves around having scientists and engineers, anybody in any science field, boil it down so that the average person can understand the science, right? So to interest everyone from young and old. So that's science. And I'm involved. Go ahead.
Yeah, I was going to say, so it's kind of storytelling in whatever medium that you decide.
Exactly. So I'm involved in science communications because I create wonderful illustrations of the James Webb Space Telescope. That's the current project that I'm working on.
So Yeah, I was going to say, is there a degree for science communications, or tell me about your path through school?
So I have a very interesting path through school. I started off in college wanting to be a lawyer. So I went to Morehouse College and I studied political science. After school, I actually started working at a law firm as a clerk and a librarian. And I found it not very interesting, to be honest. It was a wonderful organization, a wonderful law firm. And I happened to meet one of the lawyers there who was a film professor at a local university here in Washington, D.C. And I told him of my interest in photography, and I actually had a portfolio. And he took a look at it and he said, "What are you doing here? Why don't you pursue your passion?" So I actually went back to school at the University of District of Columbia here in Washington, and I studied photography. So my degree is in photography, and I opened a studio right after that and started producing photographs for magazines and newspapers and universities and that sort of thing. And about 10 years into that career, I found out that they were offering a job at NASA Goddard Space Flight Center. And I applied for it and I took it.
So the job was actually in photography for NASA.
The job was in photography for NASA, and they were looking for someone that could produce portraits, group photographs, photographs of day-to-day life at NASA. And then I worked there for about 10 years, and then someone asked me to join the last Hubble servicing mission, where I actually photographed the work that was behind SM-4, which was the last Hubble servicing mission, the mission to service the Hubble Space Telescope.
So are you telling
Oh,
me that you can work at NASA and not be an engineer or an astrophysicist?
well, yes. I mean, you can be a writer, you can be a photographer, you can support the missions in all types of ways. And communications is very important at NASA. I mean, everything that we do is communicated to the world. And part of that communication is writing, imagery, that's illustrations, that's photographs. In fact, if you think about one of NASA's most famous missions, the Apollo missions, the Apollo mission to the moon, we wouldn't know anything about it if there weren't photographs, right? So photography is
Exactly.
part of NASA's mission. That's how I view it.
So we had a student ask a question actually. Do you have a favorite photograph or testing milestone that you enjoyed photographing the most?
Well, I've been working on the James Webb Space Telescope for the last 10 years, and I could probably count to 4 or 5 images that are some of my favorites to date. And I'm actually going to show you some of those later. Well, in fact, here are some of them. Here are some of my favorites actually. So
Okay.
the first image, if we're reading from left to right, is actually what the telescope will look like when it sits on top of a rocket. Okay, so that is the final configuration of the telescope, and this photo was made just before it was taken into testing most recently. So if you were to say a favorite photograph, that's definitely one of my favorite shots right now. The next image, the middle image, is a photograph of some work being done on the telescope on the optical portion of the telescope. So what you're seeing there is not the entire observatory, but the optical portion of the telescope, which includes the 4 instruments that make up the telescope. And that last photograph on the end is actually a testing milestone. And that was when the telescope secondary mirror was deployed. This telescope has a secondary mirror and a primary mirror. The secondary mirror was deployed, and that's the first time and only time that that mirror will be deployed here on Earth. So these are 3 of my favorite photographs right now.
You definitely make that telescope look gorgeous. I can see that the reflective surfaces of those lenses are so beautiful.
Well, the telescope is beautiful, and part of my job is to create images that are both technically accurate, and when these images get pushed out to the public for the public to see, I do want them to be striking, and I want people to look at them and then learn more about the telescope.
So before we get ahead of ourselves, Chris, I know you brought a video with you today that kind of tells a little bit about the James Webb Space Telescope, and it's a time-lapse video. So when students watch it, they'll see the satellite open and close, I believe, in the video. So can we take a look at that video, and then we'll explore some more of your photographs of the
Let's
project
take a look at the
itself.
video. Sounds
Okay,
great.
thanks. Wow. So that telescope looks ginormous. So
It's
can you
huge.
relate in size for the students about how big the telescope is in comparison to Hubble, maybe?
Well, the telescope itself is made of two components. And what you saw there in the beginning of the video of the time lapse was the optical portion, the mirrors and the instruments actually coming over, right, and being joined with the sun shield and the spacecraft itself, the spacecraft bus. Then you saw the sun shield actually deploy, so open up. And that sun shield is about the size of a tennis court, okay? The mirror itself is 6.5 meters, which makes this telescope about 100 times more powerful than the Hubble telescope itself.
Okay, so just a couple more questions, if you don't mind, from our students. They're flying in here. So, a personal question: are you a media personnel for NASA? I guess they're asking if you work for the Public Affairs Office, or are you directly connected with the Webb telescope?
So both. My job is two-pronged. I'm both a technical photographer as well as an Office of Communications photographer. So some of my photography is used purely for engineering purposes, and other photography goes out to the public through the Office of Communications.
Perfect. So there's another question about photography. Is there a specific way of photographing the satellites, or is it just normal photography? Do you use special cameras that we don't normally see? Or I guess that's the question they're asking.
I use normal cameras, but one of the things that I aim for in my photography is to have distortion. You see is basically what the telescope looks like. So I try to avoid really hard angles or skew sort of thing. So I look straight at the telescope, and I want to create the most perfect pictures I can. Like this one behind
Okay.
me, if you can see it.
Oh, yeah. Is there a particular camera you like using? A student has asked that. So what camera do you use? I'm sure you have several, but you might have a favorite.
So I use 35 millimeter digital cameras. I also use medium format digital cameras, which makes it so that I can blow the pictures up really big.
Okay, so some of the other questions have to do with the Webb telescope in general. So why don't we take a look at some of the other photographs that you brought with you today, and maybe we might get to answer some of those questions during our discussion. So what are we looking at here?
So here you're looking at test and also locations as to where the telescope itself was tested. So that first test is showing you how they might clean some of the mirrors at some point. This technique has actually never been used to clean the mirrors, but it's a really interesting shot. They're blowing carbon dioxide snow onto a mirror, very similar to the mirrors on the telescope, and they're cleaning the surface with that. They've never used that technique on the telescope itself. The other photograph, the center photograph, is one of the locations that the telescope is tested in, and I just thought it was an amazing location. I get to photograph in really incredible spaces. This particular space is used to test the telescope, the communications of the telescope, to see how the telescope will do in space. They shoot radio waves at it, if you will, to see how the communications will be. And then that last photograph with the pink wall, that is the room where the telescope was actually, the mirrors were assembled. So that is the clean room, and that wall there are all the filters in the clean room, right? So that's how they keep the clean room so clean. Next slide. Okay. These are two great photographs. That first one there on the left is the videographers on the team, as well as myself, had an evening with the telescope, if you will, after some testing, after some successful testing, and we were able to turn the lights down and create really, really nice lighting so that you can see how beautiful that mirror is. And that image on the right is a shot of the telescope at NASA Johnson Space Center. That's inside of a test chamber. The primary mirror is deployed, the secondary mirror is deployed, and it was a 90-day test where they actually took this telescope down to the temperatures that it will see in space. to make sure that everything was going to work. And I made this photograph right after the test was completed.
The students want to know, is there going to be a webcam on the telescope where they can see it working in space?
Unfortunately not. I would love for there to be one. In fact, I would love to go and photograph it myself, but no, there won't be a webcam on it.
Well, I know like for the Perseverance rover, there was a webcam that you could tune in and see what the engineers were doing. And I don't know the answer to this question myself. Is there something like that where we can peek in and see the work that's occurring with the telescope here on Earth?
So there was for years when the telescope was here at the NASA Goddard Space Flight Center. Now the telescope is in California at Northrop Grumman for the final testing and assembly. And there are no cameras in that facility. And that's one of the reasons that I go out periodically to make photographs so that you can see the progress.
Oh, gotcha. So you are truly our storyteller. Thank you. Thanks for sharing the story.
My pleasure.
What's the purpose of the Webb telescope? Is it going to take the place of Hubble, or what is its job going to be?
Well, as you know, the Hubble telescope is still in space in low Earth orbit, and it's doing just fine. It's still creating great science. The James Webb Space Telescope is the successor to Hubble, but it works in a completely different range in terms of light. So it works in the infrared range. And what that's going to do is allow us to see further into space and back in time, if you will. So we'll be able to see some of the first light from some of the first galaxies that Hubble was not able to see.
Amazing. That's so amazing. I can't wait to get that into space. Are you going to be at the launch, or where are you going to be during the launch of the Webb telescope?
I plan on being in French Guiana for the launch. It's launching from French Guiana in South America on Halloween 2021.
All right. That'll be a good trip, and I'm sure you'll be very proud to see that finally lift off. All right. I know you brought some more photos because that's what you do. So let's look at some more of your pictures that you brought of the telescope. What are we looking at here?
On the left there, that is the solar array, which is going to, or that's 4 of the 5 panels of the solar array that's going to provide power for the telescope during the mission. That really interesting picture in the center there is the telescope when it was here at Goddard Space Flight Center during a nighttime contamination control peak at the telescope. They turn all the lights off and they look at the telescope, every inch of the telescope with lights, with flashlights. So this particular image is a time exposure. The camera shutter was open for about 2 minutes, and that's why all the people are blurry and the light seems really eerie. The image there, the last image with the 5 guys in the white suits against the white background, they're actually closing the doors to the telescope's transportation container. And that's one of my favorite pictures. It just shows that a lot of people are doing a lot of different things in the project, and it's really interesting.
Love it. I think there's another slide of some more images of Webb.
Yep.
Yeah. Well, oh, there we go.
So this is an illustration, I think, of the many faces of Webb, if you will. So I'm actually going to start from right to left describing these. So that image on the right with the 2 gentlemen standing in front of the huge primary mirror was done just before a big optical test that they were going to do. And that is the entire 6.5 meter mirror, primary mirror of the telescope in its full glory. And that gives you an idea of the size of that mirror compared to those 2 guys on the floor there. The image in the center shows how the telescope is folded for launch, right? So one of the wings is folded back. So you have, we call those wings, and then there's a center section. So you have the 6.5 meter mirror with one of the wings with the 3 mirrors on the side folded back as they're doing another test there. And that final image there on the left is actually the image of the telescope folded for launch with the sun shields partially folded. So that gives you an idea of the different parts of the telescope. as well as how it relates to the size of those technicians down there at the bottom.
The students are asking, are the mirrors made of actual gold?
The mirrors have a layer of gold on them. So the mirrors themselves are made out of beryllium. They chose beryllium because it's very stable at the temperatures that the telescope is going to see. But the mirrors have a layer of gold. In fact, if hopefully I get this fact right, but all the gold on the mirrors, all the gold on all 18 of the mirrors is about the same, I guess, weight as a golf ball. So it's not that much gold, but it is actual gold on the top of the mirrors. Yes.
What's the benefits of using gold?
Gold happens to reflect infrared light better than just about anything else. So it's used for its optical properties. Yeah.
Very good. The students are asking, and maybe we can show the next slide because it kind of shows what your life is like at NASA. Are you going to be assigned to a new project once Webb launches?
I hope to work as a photographer on the Nancy Grace Roman telescope. That is it's a wide field infrared telescope, and it is slated to begin construction now, actually, at the Goddard Space Flight Center. Yeah, so that's what I wear when I not the shot of me with the hair flying, but the shot of me with the camera in my hands. I actually wear a clean suit whenever I go into the clean room, just like the technicians. I have to wear the clean suit. I have to wear the mask, the gloves, the booties, everything. And my cameras have to be clean before I actually go into a clean room. Now that shot of me on the right there is me during a zero-G flight. We were a really brief project, but that project flew in a zero-G camera, and one of the guys was nice enough to take this picture of me, and it was a lot of fun.
Oh, I bet that was a lot of fun. So that's an airplane that you can take a flight, and it does parabola flights, and you occasionally gain weightlessness, just like an astronaut. So I can imagine that felt amazing.
Yes, it was a really amazing feeling.
Yeah, don't forget about putting those questions in the chat box. You guys are doing a great job so far. We've gotten some really good questions for Chris. So let's see, I can ask you some more while we've got a pause here. What orbit will the James Webb Telescope attain?
The James Webb Space Telescope is not going to orbit Earth. It's actually going to orbit the sun, just like we do. It's going out 1 million miles from Earth, and it's going out so far so that the radiation, the heat, the light from Earth will not affect the telescope itself. So that particular orbit is called L2, the Lagrange point 2, or L2.
Someone's addressing your wearing the bunny suit there. So why is such great levels of cleanliness needed for making and transportation of the telescope? So why the bunny suit? Are you protecting yourself? Or are you protecting the telescope?
We're protecting the telescope. We don't want any dust, any hair, any fibers from our clothes to actually interfere with the operation of the telescope when it's in space.
Very good. Why is the telescope so long?
So long. So big?
So I think when it deploys, you see that long bit that comes out in front of the big mirror. So yeah, why is it so long?
So the largest part of the telescope is the sun shield. And it is what it sounds like. It's a shield from the sun. So just like you might have an umbrella to shade you on sunny days, we need to keep the telescope cool and in the shade. So that sun shield blocks the telescope's instruments from the sun, because this telescope needs to operate really, really cold.
Very good. Okay. So will there ever be a possibility to repair the telescope if there is an issue?
Well, I think that we won't have any issues. I think that's the hope. And I'll never say never, because I'm not an engineer and I've always been amazed, but there are no plans to repair this telescope.
Okay. Oh, goodness. Do you know how much money this telescope costs? That's a big question.
I've heard it's a lot.
So I've heard a lot too. Let's look at some. You did bring some larger pictures that I want to share with the students before we run out of time. So there's one of someone, it looks like they're being reflected in the mirror. Can you explain this photo to us?
So the mirrors were made in the United States by a company, and that company sent the mirrors to us basically one by one. So this was actually the first mirror to arrive at the Goddard Space Flight Center, and they're inspecting it. They're looking it over inch by inch to see if there are any imperfections, if there's any contamination, because that's what we need to do in order to make sure that this telescope is perfect. So this was the first mirror to arrive.
Perfect. Let's look at the next one that you brought. Is Webb the only project you've worked on for NASA while we're waiting for the next photo?
I worked on Hubble.
Oh, Hubble.
On the last
Okay.
Hubble surface.
I had a student asked if you had taken a picture of Orion for the Artemis program, so you haven't had a chance to go and do that yet.
No, I haven't. So
Okay,
so
this is my favorite picture.
It's one of my favorites too. This is an engineer. His name's Ed, and Ed is at the bottom of a chamber called the Space Environment Simulator. So the environment that he's in is designed to get really, really cold. But believe it or not, there are certain parts of the telescope which need to be kept really warm. And they use special heaters on those parts. And this blanket was also designed to keep some of those parts a little warmer than their super cold parts. So he's getting that blanket in place. It's called a thermal blanket. And I just had to make this photograph because it just looks really neat.
I've actually seen those thermal blankets used in like emergency preparedness kits. Are those similar to what you're using there at NASA?
It's very similar. Very similar.
Yeah.
Yes.
It's like a tinfoil blanket. Interesting.
Right. It's lightweight.
And I think we have
but,
one. Yeah.
Go ahead. No.
I think we had one more photo that you wanted to share with us before we get to the students' mission for the day.
Okay. So this is another peek inside of the inner operations. So each one of those mirrors came in its own special container. It's a container sealed environment. So the environment inside of the container is sealed, and so no contamination can get in. And I just thought it was neat how these guys had to push the mirrors around the Space Flight Center there, and I wanted you to see this shot.
So do you think Webb is going to compete for Hubble as far as the legacy of the two telescopes go, or do you think Webb is going to be a completely different story than what you told with Hubble?
I think that Webb will continue the story, and I definitely don't think that it will compete, but it will augment, it will add to the story, and it'll give us more insights into our universe. So I think we need both of them.
I agree. I agree. So in the last few minutes of our episode today, Chris, do you have any final advice or tips for our middle and high school students that may be watching?
Well, if you look at my story, I've come full circle. I had an interest in science and engineering. In fact, that's what got me into photography to begin with. And I didn't necessarily pursue my pure interest when I first went to college. I actually recommend that you look at what your interests are, look at what your passions are, and take a long look at the schools and what they might offer you, and follow your heart.
I love it. Follow your heart. That's a good way to end. So we're going to challenge students today to an activity. They've got their own mission. And what they can do is actually create their own bookmark about the life cycle of a star. There's going to be a lot of work that Webb's going to be collecting and a lot of data that we're going to learn thanks to the Webb telescope. So students can begin their journey of knowledge about the life cycle of a star by creating their own bookmark. And you can print the bookmark and the activity and the supplies that you'll need at the link, and we'll put that in our chat box for you. And be sure to share your work with us on social media. And I just want to use this last few seconds to thank Chris for joining us today. I hope you had as much fun as I did. And I want to encourage the students to follow your heart, and we'll see you next time.
Thanks for having me.
Hi, everybody. I'm Bill Nelson, and it's the National Intern Day. Thank you for all your hard work as a NASA intern. And this summer, we are lucky to have 2,000 interns helping to advance NASA goals and missions in every state in the United States and Puerto Rico. And I can't wait until we have all the NASA interns back at our centers in person. But the virtual internships have enabled NASA and other agencies to make opportunities available to more students that otherwise would not have been there. And it ensures for us to continue to get the best of the best. NASA is working to solve some of the biggest challenges facing our country: climate change, American leadership in space, to name two. And the way we're going to do it is by working together, bringing people together, listening instead of just talking. And we'll do it by making sure that our NASA family is made up of folks with diverse backgrounds and fresh perspectives. And so thank you for all your hard work and your innovative ideas. You're the future of our country. And we hope to equip you with the tools and the knowledge to begin your careers. So many of our leaders at NASA got their start as interns. An example, the STEM education lead, Mike Kincaid, our head of human spaceflight, Kathy Leaders. And I can't wait to see what the future holds for you. And I look forward to your continued success. Thank you for being a NASA intern.
Hi, everyone, and happy National Intern Day. I'm NASA Deputy Administrator Pam Melroy, and I want to give you a warm welcome and a thank you to all the interns working across the country to help advance NASA's goals. NASA takes on the hardest technology problems to accomplish the boldest and most inspiring missions, pushing the limits of what we know to be possible. That's why we're so appreciative that you're here and contributing. For NASA to be successful, we need a diverse and incredibly dedicated workforce to put their heads together to solve the most difficult problems facing our nation. You'll meet many amazing people in the course of your internship who will help you learn and grow. I'm reminded of the inspiration I drew from my heroes and mentors to ultimately pursue a career to become an astronaut. Some of those early internship opportunities in my career were my most formative, and I hope that we can provide an experience that is as impactful for you all here at NASA and across the federal government. While NASA and the federal government is committed to providing opportunities for students to gain valuable experience, your contributions have been invaluable as well, to get your insight, to get new ideas, and to foster relationships you'll carry for the rest of your lives. Your generation, the Artemis generation, gives me hope for the future, knowing one day this will be in your hands, and perhaps one of you will be the first person to set foot on Mars. The journey starts here. I know it can be overwhelming sometimes, but I encourage you to persevere and to seize future opportunities, not just to further your own career, but also to create a better world for the generations to come. So thank you, and I can't wait to see all that you will accomplish.
Hello, everyone. I'm Mike Kincaid. I'm the Associate Administrator for NASA's Office of STEM Engagement. But 34 years ago, I was an intern just like you, just starting at the Johnson Space Center. And in those 34 years since I started as an intern, wow, we have done some amazing things as an agency, whether that's landing rovers on Mars or spending 20 years of continuous human presence on board the International Space Station. It's exciting. Imagine 34 years from now, it's the year 2055, and perhaps you'll be standing on the surface of the Martian planet talking to interns just like you across the country. You know, behind every NASA mission, there's people making it possible, including interns like you. Here's a few words from some of our past and present former NASA interns.
Hello, my name is Katia Chesaretta.
I'm Lisa Stewart.
My name is David McBride.
Hi, my name is Sarah Adenomi.
I'm Yana Sharon Benvivat.
Hi, I'm Mike Kincaid.
Hola, I'm Dr. Jade Salona Cruz.
I'm NASA astronaut Jessica Watkins.
I'm Brad Neal.
Hi everyone, my name is Paris Garrett and I am a current 2021 computer vision intern at NASA Langley Research Center located in Hampton, Virginia.
I interned at NASA headquarters,
Ames Dryden Flight Research Facility.
I was a 4-time NASA intern at a few different NASA centers.
I interned at Johnson Space Center and the Goddard Space Flight Research Center.
Ames Research Center.
NASA Jet Propulsion Lab.
For the Dryden Flight Research Center in 1982.
I had the privilege of participating in NASA internships both as an undergraduate student as well as a graduate student.
Today, I'm a support scientist at the NASA Earth Science Data System Program.
The senior technical advisor for airworthiness and flight safety.
I'm the executive officer in NASA's Office of STEM Engagement at NASA headquarters.
Today, I am the Center Director for the Armstrong Flight Research Center.
I am currently working at NASA's Goddard Space Flight Center in project management and in cybersecurity.
I'm the Associate Administrator for the Office of STEM Engagement.
Today, I am still a Pathways intern with Johnson Space Center, where I am working on developing the ascent abort model for CST-100.
Something I took away from my internship is that people really wanted to help me learn. They wanted to help me understand what was going on at the agency, and they were great at answering questions.
Learning the interpersonal skills that it takes to work in an office environment.
First off, NASA is a really exciting place to work. There are lots of opportunities and lots of different projects and work to be done.
We're working on real things. That was one of the coolest things to me as a student.
Learning to be tenacious, like ridiculously tenacious.
This euphoric feeling and rush of adrenaline that comes from being able to combine my skills and my passions to do things that I didn't think I was capable of.
And to see that the big things that NASA accomplishes really are a collection of small things from many, many contributors, and that me as an intern and a young engineer could make a big difference working as part of that team.
I would say that my NASA internships were really what laid the groundwork, laid the foundation for me to continue to explore in STEM and pursue this career.
So my advice to any of you that are thinking about applying for a NASA internship is, first and foremost, apply.
Go for it.
Do it. Just do it.
My biggest advice is just do it.
Just do it. Go for it.
Nothing is impossible, it is only a challenge. So don't be afraid to apply and believe in yourself.
You give it all and you pursue it, you will be where you want to be. So always believe in yourself.
Thanks for all you do. We're so excited to celebrate National Intern Day with you, and we look forward to hearing from you guys as you ask questions and we hear from our International Space Station astronauts. Our astronauts are standing by, and the downlink will start soon.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. We are ready for the event.
Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
Houston ACR, this is Station. We hear you loud and clear.
Please stand by for opening remarks.
Hello, welcome to today's event featuring interns across the United States federal agencies and astronauts aboard the International Space Station in observance of National Intern Day. My name is Laura Paulino and I am a NASA intern. Artemis Generation. As the architects of the future, it takes all of us to explore the extraordinary. We're counting on you to innovate, inspire, and serve for the betterment of humankind. To spark your interest, here's what interns from federal agencies have to ask.
Hi, my name is Alyssa Huey and I'm from USGS. My question is, one of the USGS mission areas is natural hazards. Given your unique perspective on the Earth from the space station, have you observed any natural hazards during Expedition 65, such as forest fires, volcanic eruptions, coastal changes, drought, etc.?
Thanks for that fantastic question. Yes, we get the opportunity to see a lot of things from space that everybody else doesn't get the vantage point we have. I have seen, in fact, just this last Friday, I was surprised to see how many fires were over Montana. I've also seen on this flight volcanic eruption in Central America, and I got a picture of Mount Kilimanjaro recently over a very much longer-term situation, and it didn't have as much snow on the top of it as I expected to see.
Hi, my name is Clara Chang and I'm from NOAA. My question is, since you work closely with people from all over the world, what advice do you have to transcend obstacles and differences in training, language, and culture as you conduct research?
That's a great question. You know, Mark's from the U.S., I'm from Japan. We got Thomas Pesquet from France, and we got Oleg and Pyotr from Russia. So even on board, we're from 4 different countries. And on the ground, we have so many people working for the space station program from many, many different countries. And it's kind of rewarding for me to get to know these people and get to know all the cultures. And I think it's great to respect each other's ideas and thoughts and work together towards a common goal. And that makes things happen. And it's amazing to be in that team.
Hi, my name is Kelvin, and I'm from the Army Educational Outreach Program. My question is, what have you learned about cooperation and culture while being on the International Space Station, where you're living in a microcosm of the diverse world?
What I've learned is that you've got to be able to talk about issues as they come up. You don't want to let anything this works in all relationships. If there's something that's bothering you, you need to find a way, whatever way works best for you and the other people you're dealing with, to communicate that in a way that doesn't put them on the defensive, and where you're able to communicate that before you are really angry about it, where it's just a minor issue. So don't let things build up.
Hi, my name is Matthew Stang, and I'm from NASA. As we celebrate all interns tomorrow on National Intern Day, what impact do you see interns having across the federal agency? Thank you.
You know, we've been with the agency for a long time. I won't say how many years, but so we know, how like NASA or JAXA, the Japanese Space Agency, works and how to promote and work in this program. But you interns, all the interns are fairly new. You have new ideas, new thoughts, and different perspective. So we really appreciate those new ideas and new perspective, because you can see things differently, and we might be taking things for granted. And you might say, why are we doing it this way? And that would make us think, maybe we should rethink, and that would make things improve. So please bring it on.
Hi, my name is Hayden Morgan from AFRL. My question is, people often look up to astronauts as role models as they demonstrate the magnificent achievements we can obtain. As an astronaut, who do you look up to as a role model?
Quite honestly, the person I look up to the most as a role model is my dad. I regret to say I don't think I've been as good a dad as my dad was to me. He is one of the most kind, level-headed people. He's very, very other-centered. I just can't say enough positive about the guy. I think the strongest reaction I would get out of him if he felt really angry was he would blink his eyes really quickly, and then you knew that he was puzzled by that strange behavior. That was about as bad as it got.
Hi, my name is Anthony Pedraza. I attended Texas Tech University, and I am an intern with the Forest Service. My question is, what type of role does NASA see itself in for the preservation of our planet, and how do the resources in space factor in that thought process? Thank you. Thank you.
You know, up on International Space Station and also all the satellites, Earth observation satellites, we're at a very unique location, position, altitude at this vantage point to see what's going on Earth. And then also going over, you know, in a certain interval and looking through the changes. So all that data combined, I think we can see the changes over the years. And researchers and people like you can help us protect the environment and think about how to do that, and what we're seeing should provide that information for you.
Hi, my name is Austin Tran and I'm from the U.S. Naval Research Laboratory. My question is, how do you determine when you go to sleep in space, and do you take shifts with other astronauts?
So I'm happy to say, unlike what the Navy has to do sometimes, is we don't have to hot bunk up here. I have my own bed. No one else gets to use it. But we did have to define a time period that is determined to be nighttime for us, because we could pick any time. And what we've chosen is Greenwich Mean Time. So we typically, after our latest evening meeting, we will sometimes turn the lights to a dimmer color to help our bodies recognize that it's getting closer to the evening. And then we just go to bed around 9:30 or 10, Greenwich Mean Time.
Hi, my name is Mei Feng, and I'm from NOAA. My question is, when I conduct research on the water, weather is the ruling factor as to the success of my day. In space, what weather elements are most dangerous to an astronaut conducting a spacewalk?
That's a very good question. So we don't have, you know, storms like on the ground. We don't have, you know, lightning, but we do have radiation. And when the solar wind is strong, we can detect that. And so we plan ahead so that we try to avoid that as much as possible. Now, sometimes you do have to go out the door, but we try to time it just right so the radiation hit is less than what the maximum would be.
Hi, my name is Carrie, and I'm from the USGS Office of Youth and Education and Science. And my question is, humans will walk on the surface of Mars within my lifetime. What engineering and geoscience skills do you think will be most important for them to understand?
I think that one of the biggest challenges of being on the surface of Mars is that we're going to stay on the surface of Mars for long periods of time, just because of the nature of orbital mechanics and literally getting the planets to align again. So you've got to be really good at maintaining your habitat. That's going to be a primary.
Station, this is Houston ACR. We're back with you on the other side of an LOS. Repeating the end of Carrie's question, humans will walk on the surface of Mars within my lifetime. What engineering and geoscience skills do you think will be the most important for them to understand?
I think that being on the surface of Mars, because of orbital mechanics and the vast distances involved, we will be putting people on that surface for a long period of time. So the primary skills are going to be understanding how to maintain the environmental control and life support system, how to maintain the habitat. And unlike that up here, where we're maintaining a habitat in space, on the surface of Mars, because you're dealing with, you're going to have to make sure you can keep things clean on the way back. So I think those are going to be very important skills to have on Mars.
name is Rasha, and I'm from NASA. And my question is, out of all the experiments being done on this mission, which results are you most curious and most looking forward to?
Wow. During our daily work, I guess we do maybe participate in maybe 2 to 5 science experiments a day. And so we have a lot. But one thing that I got interested was having water bear up here. And apparently, they stay here for a couple of generations before they go back. So the researchers can take a look at them when they go back. So that's something that I'm looking forward to seeing the results on.
Hi, I'm David Gonzalez, and I'm currently working on methods to provide better thermal support to divers in cold waters at NSWC, Panama City. I've read that astronaut suits require both heating and cooling garments. And my question is, how does an astronaut maintain thermal regulation during a spacewalk in dynamic temperatures? Thank you.
So our spacesuits do such a fantastic job of insulating us from the outside environment that what we really have to do is reject the heat that our bodies generate, because the body heat will not translate through that spacesuit. So we've got a liquid cooling and ventilation garment that allows fluid water to travel through the hosing around our body, and then it will pass by an ice pack. Now, me personally, on a spacewalk, I have too many other things to worry about, so I basically sweat in the sunshine and I'm a little chilly in the cold. But I do have the ability to adjust that if I wanted to. It just takes effort, and I'd rather focus on the other things that are occupying my attention.
Hi, my name is Kai Stargel, and I'm from the Air Force Research Laboratory. And my question is, as an astronaut on the space station, part of your job is often as a research scientist. Do you get paired with science projects that align with your background, or are you expected to adapt and learn to maintain new science projects?
Oh, that's a great question. Mark's from the Army, and my background is engineering. So science is something alien to me. But we have great training on the ground. So the instructors and also the researchers will tell us about the experiment and tell us the technique and teach us well. So up here, we will do whatever is on our schedule, and we'll try to help out as many researchers as possible.
Hi, my name is Teresa Keith, and I'm from NOAA. My question is, the global community and U.S. agencies are uniting under the United Nations Ocean Decade by working on the science we need for the ocean we want. How does your work in space help us learn more about our blue planet?
One of the significant things I think about being up in space is the emotional aspect of getting a better understanding of how thin our atmosphere is and how precious this amazing place we live on is. But we have lots of sensors. We've got hyperspectral imagery, multispectral imagery, we've got LiDAR, and all of those things provide us different ways to observe the Earth and gain a better understanding of it.
Hi, my name is Araceli Morales Santos, and I am a resource assistant intern at the U.S. Forest Service. And my question is, I'm fascinated by space and space exploration, so much so that I can spend hours watching PBS NOVA episodes about black holes, dark matter, and gravity. What is a particular show, a movie, or a memorable experience that propelled you to a career with NASA?
So for me, when I was a kid, I really liked science fiction movies like Star Trek, Star Wars, and then my dad took me down to Kennedy Space Center. We saw rockets and went down to a Smithsonian Museum. So looking at the real stuff and the science fiction combined, it made me interested to actually go to space, and that's how it started for me.
Hello, I'm
I'm Priya Abiram from the Army Educational Outreach Program. My question is, what is the new set of right stuff or character traits that an aspiring astronaut must have in order to reach Mars and beyond? Thank you.
Well, one of the key things about leaving the rest of humanity behind is that you have to get along with the humans that you're traveling with. So I would say the key thing, the right stuff, is really interpersonal skills. You've got to always do your best, but put more effort into making the team of people around you performing their best than you always being better than everybody else. So it's all about the team.
Hi, I'm Ronald Morero, and I'm from NASA. As you observe the Earth on the space station, what weather patterns and landforms are most fascinating to you?
Well, Earth is fascinating. You know, we have a big window called the cupola looking down at Earth, and we have a better quality window as well, looking straight down. And a lot of us, we just spend time in there whenever we have a chance. But for me, the most fascinating thing is actually clouds, because it is, it has different forms, different shapes, and during the sunset, sunrise time, you can see the shadow, just a very, very long shadow, and it's just fascinating to me. And I take a lot of pictures of it, but I can't remember where I took it from.
Hi, my name is Amrita Sahu, and I'm from the U.S. Naval Research Laboratory. My question is, as an astronaut, you probably encounter unforeseen challenges on a regular basis. What advice do you have for aspiring scientists on how to approach a problem that is seemingly unsolvable?
So take my advice with a grain of salt. I am not an expert, but here's my advice for what it's worth. Go ahead and work really, really hard on that problem, and then step away from it and do something fun. Associate with other people that have a wide variety of viewpoints and different approaches to things, and then you'll really get the creativity going, and you might be surprised when a good idea on how to solve that problem you've been working so hard on comes to you.
Hi, my name is Claire Fox, and I'm from the DoD's NSWC Crane Division. My question is, what has been your favorite memory since becoming an astronaut?
That is a tough question, because every single day you have, a lot of laughs, even here and even on the ground. So that's a very tough question. I think maybe it's tomorrow.
Well done.
My name is Katie, and I'm an intern for the National Oceanic and Atmospheric Association. While working for the Center for Satellite Application and Research, I've been learning about several different satellites in our atmosphere and in space. My question is, how are you able to avoid satellites and prevent collisions with space junk on the space station?
I would answer this question in 3 parts. One, you got to be able to keep track of where things are, and we do have that ability. And then, but it's limited in size. And then you've got to have the ability to move to a new orbit if that new orbit is a better place to be. And then the third thing is you've got to recognize that you can't see everything, so you've got to have a space station that can protect itself. So we've got multi-layers of alloy that help protect us and reduce the impact of an impact on the space station by spreading out that energy. And so far, so good. We haven't had anything hit us that has caused us to start to depressurize.
We want to extend a huge thank you to our speakers and astronauts for being part of today's program. To all the interns watching, thank you for your meaningful contributions you make every day to the federal agencies that you serve. Happy National Intern Day!
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you to all participants.
hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather.
Our planet is a living example of a delicate balance. A complex system that is constantly changing, constantly evolving, constantly adapting. How do these changes affect life on Earth? How does everyday life affect our planet? We have a great capability to absorb, interpret, and comprehend, and an urge to understand the world we live in. This is what defines us as human beings, what makes us who we are. With our technological advancements, we are now capable of exploring new worlds, new frontiers. We're searching for answers that may lie in front of us. Better yet, above us. The field phase of the experiment is about to begin. All the planning, sleepless nights, meetings, and hard work the team has invested in the mission are at stake. My name is Yasna Pittman, and I'm one of the many scientists working on the airborne tropical tropopause experiment.
Very natural for humans to want to understand how the world around us works.
Why the atmosphere does what it does, it's like solving a puzzle. You just want to understand how it works.
We're trying to understand how we're affecting, how humans are affecting the atmosphere.
Understanding how the stratosphere changes very much reflects how our climate is changing.
I think that the work that is done in atmospheric science is very important, but it's also a lot of fun. It's like the best job possible.
Well, NASA has been doing airborne science investigations for quite some time. Some of the earliest investigations we were doing was related to the early days of the Antarctic ozone hole.
In 2009, we started a new kind of program. It's called the Earth Venture Program. It's got 3 parts, and the first of those parts is what we call suborbital science. This is science done not using or not including a new satellite.
With some of these newer missions, we have let the community come up with their own ideas, their own way of implementing the mission, what their own science requirements are, and they bring their measurements to the table.
And ATREX had very good science, was very relevant to the kinds of questions we wanted answered, and its budget was reasonable and appropriate.
ATREX is an airborne campaign to try to understand how stratospheric water vapor affects climate.
It causes perhaps
maybe 15 to 20% of the warming that we've had in the past 15 or 20 years.
So it turns out that small changes in the humidity in the stratosphere are very important for climate and important for surface temperature. They're actually comparable to the importance of greenhouse gases that everybody knows about.
So for example, we know that if you go back 30 years, carbon dioxide was less, quite a bit less 30 years ago. Methane was less quite a few 30 years ago. Nitrous oxide was less 30 years ago. So we know these gases are increasing with time.
Gases that affect the chemistry of the stratosphere, which is where the ozone layer exists that protects us from ultraviolet radiation.
So understanding the rate at which this stuff gets into the stratosphere and how it changes is extremely important to looking at the climate of the stratosphere and how the stratosphere climate affects the lower atmosphere.
So we really need to understand what controls the humidity of the stratosphere and actually be able to predict that in the future in order to improve the accuracy of our predictions of future climate change. And it turns out the most important place to go sample to understand that is the tropical upper troposphere, the top of the troposphere in the tropics. It's called the tropopause, which is actually a very high altitude, which is why we need a high altitude aircraft to study it.
So the tropical tropopause is at about 55,000 feet in the tropics. So if you go down to the equator, you have to go up quite high, above 50,000 feet. And the tropical tropopause is really important to the global atmosphere because most of the gases that get into the stratosphere, all the air that's circulating upward into the stratosphere goes through this tropical tropopause region.
So that's basically a gateway to the stratosphere. The general circulation transports air upward in the tropics, goes into the stratosphere, and then is spread throughout the stratosphere and comes down at the higher latitudes in the polar region.
And this is what ATREX is focused on, to look at that motion of air into the stratosphere and how the water is removed from that air as it rises upward.
We know a lot about it, but there are some puzzles about the details of how the clouds are formed and under what conditions they form. So that's probably the most important thing that we hope to gain from ATREX.
ATREX will address a number of really important issues. It'll give us a better understanding of exchange between the troposphere and the stratosphere and how that impacts atmospheric composition, how that affects the chemistry that goes on in the upper atmosphere, and in the longer term, how that will affect the climate.
And that will help us to understand as we go forward trying to figure out what to do about climate change to better predict it and make better decisions.
How does the interaction between the upper troposphere and the lower stratosphere affect us down below? How are we going to find out? We have the questions. Now we'll be searching for the answers. Hawks' sense of hearing is excellent, and their eyesight the best in the entire animal world. Not only can they see greater distances than humans, but their visual acuity is 8 times that of ours. Yet we need to look even further, higher, deeper into the sky.
We live in the lowest layer of the atmosphere, which is the troposphere. The stratosphere is the next layer above us, so it's basically above altitudes of somewhere between 30 and 50,000 feet.
There are processes that take place in the stratosphere that have very direct impact on us.
So it's extremely important to understand the detailed process of water turning into clouds, those particles in clouds settling out. How does that detailed process occur, and then how will it change in the future?
What's been our big problem is getting the airplanes to the right place where they can make the measurements for long enough periods of time to do the observations.
So it turns out the Global Hawk is a perfect tool for sampling this part of the atmosphere. It's a high-altitude aircraft. It flies considerably higher than normal commercial aircraft, but it's also got this extremely long range.
So our bird here can climb to a cruise altitude of 65,000 feet and fly for up to 30 hours.
So we can basically, for example, we could fly from here to Australia in one flight.
So the basic geometry of the airplane, it has a wingspan of 116 feet, which is equivalent to the wingspan of a Boeing 737 transport aircraft, a length of about 65 feet, weighs about 27,000 pounds, fully fueled at takeoff.
In comparison, in the past, people have used manned high-altitude aircraft, like the ER-2 or the WB-57. However, those have very short range.
Now that we have the Global Hawks, they have a much longer flight duration. They can get to these key areas to appropriately attack the science questions that we've been thinking about for a very long time now.
Basically, for this program, we searched out the best instrumentation, the best expertise in making these measurements, and invited them to be part of the program for the proposal for the ATREX mission.
Once the major science campaign, the project mission scientist, selects the instrument teams, that's really when our work gets started. We will then visit them and begin coordinating all the mechanical and electrical interfaces we need to do to get them mounted on the airplane.
You have to determine everything from the size of the instrument, so you know how much space it's going to occupy or needs to occupy in the aircraft, how much the instrument weighs, so you can be sure that what you design mechanically for installing the instrument on the aircraft is of sufficient strength to be able to hold the instrument in the aircraft.
In some cases, you'll see probes sticking out of the airplane, so all that has to go through aerodynamic analysis, etc. Structural mounts inside have to be properly stress analyzed, so we make sure all that happens. So we coordinate with all the proper technical fields to get ready for the instrument to arrive here.
From the time we first start communicating with the instruments teams until we're ready to actually start performing science with all the instruments on the aircraft, it takes about 1.5 years of really hard work, close coordination, and a lot of good communication between everybody.
We're using state-of-the-art instruments, or cutting-edge instruments, to measure things like water vapor, clouds, and temperature, and a whole bunch of trace gases.
We have a very sophisticated instrument called the Cloud Physics LiDAR. It's a laser, shoots out the bottom of the nose of the plane, and as the laser goes down, some of the light gets scattered back, and there's a telescope that collects that light. And because you know how long it takes the light to go down and then come back up, you can tell what kind of cloud structure there is below the plane. So if we see very thin clouds, this laser can detect those very thin clouds. We have a meteorological system on board the plane that measures winds, temperatures, and pressure. And it's the best meteorological instrument in the world for measuring these. Imagine how hard it is to measure from a plane that is going a few hundred miles per hour. So it's a really hard measurement to make, and they do it. We have water vapor measurements, 2 water vapor measurements on board the plane. Water vapor is important to look at how air that's going into the stratosphere gets freeze-dried, so you have to have a really high-quality water vapor measurement, and we have 2 instruments to do that. We measure ozone on board this plane. Ozone, as I mentioned, the ozone layer screens ultraviolet radiation, so we have to know what the ozone looks like. There's actually very little ozone in the lower atmosphere, and there's a lot as you get into the stratosphere. So we use ozone actually to tell us the difference between stratospheric air and tropospheric air. We have another instrument that actually sucks little gas samples, has little cans, so it'll suck in a little air, and then you bring those cans back, take them to a lab, and you could literally measure 100 different gases from these little gas sample cans. And that's really important because you can look at all sorts of natural and human-produced gases to look at things like ozone depletion and climate change.
So all of these will tell us how air is transported through the tropical tropopause region and how it's dried to the very dry conditions of the stratosphere.
ATREX is sort of a pathfinder in terms of investigating some of these processes. And when I say pathfinder, it's utilizing a brand new tool, and that is the Global Hawk.
This is a hybrid. It's like a satellite that you control from a control room, like a mission control, but it has nobody in it, like a satellite. So it's really a new and revolutionary way of doing science.
With the science that we do at NASA, we need to combine the satellite data with aircraft data, with modeling data, and even some measurements from the ground all together to answer the science questions the right way.
In 50 years, we'll look back on this plane, and it'll be very common. It'll be used all over the world. I really believe that planes like the Global Hawk are going to change atmospheric science in a very profound way, and for the betterment of everybody who lives here on the Earth.
Everything is ready. We should be airborne soon.
A new era of exploration is beginning. NASA is building on its experience in low Earth orbit and preparing to go farther, setting up a base camp in orbit around the Moon, known as the Gateway, exploring the surface of the Moon like never before, and preparing to one day go to Mars. To accomplish all this, NASA will need a new spacesuit for its astronauts, one that's more flexible, versatile, and durable than any made before. Engineers are now hard at work designing, building, and testing the new suit, making sure it's up to the task for future exploration. Some of the greatest moments in exploration have taken place with a human in a spacesuit. Whether it was a first journey outside the spacecraft or traversing mountainous moonscapes, the spacesuit made it possible. The act of sending a suited human outside the spacecraft is called EVA.
What is an EVA? EVA is an acronym that stands for extravehicular activity, which is what most people know as a spacewalk. It's whenever we take astronauts and we let them go outside to do useful work in the vacuum of space.
The spacesuits currently in use for NASA EVAs were designed in the 1970s for space shuttle missions. They have been upgraded over the years for work on the International Space Station and have served NASA well.
In the past 20 years, there are a handful of types of spacewalks that we've done. We've done planned spacewalks for maintenance, As hardware breaks, we can do contingency spacewalks. As technology improves, we can upgrade hardware. Or like with the Hubble Space Telescope, we're actually repairing very sensitive scientific experiments in order to enable science.
Those EVAs took place in microgravity, where astronauts float and need to use their hands to move from place to place. But moonwalkers, working in 1/6 Earth's gravity, will need spacesuits that let them use their hands and feet, walking to destinations and bending and reaching as they explore. For this new type of work, NASA has been testing prototype planetary suits, culminating in a new suit design, the XEMU.
The XEMU is Exploration Extravehicular Activity Mobility Unit. So it's an exploration spacesuit. So it's a spacesuit that you're going to use as we move forward on Gateway missions and on the lunar missions with Artemis. And then we're using all that to test the suits you would want to use to go to Mars in. So eventually you're going to have to be very independent and very confident in your hardware when you go and do a mission that far away from Earth.
One of the most obvious changes in the new spacesuit is the way astronauts get in and out of it. Donning the current suit is a multi-step process of wriggling into the upper torso and then getting help attaching a pair of space pants. The new generation spacesuit features a hatchback, where astronauts simply slide in and out of the one-piece body of the suit. Another big feature of the suit is the way the astronauts are able to move while wearing it. Apollo astronauts learned they had to hop to get around on the moon. The suit design sometimes made it difficult for the astronauts to work.
Up. Okay. We see that one went all the way in. Not quite. Like that.
Engineers learned valuable lessons from those Apollo suits. The improved design for the next generation spacesuit will allow astronauts to walk on the moon, not hop. Additionally, astronauts will experience an improved range of motion.
The new suits, the planetary walking suits we're working on now, we really hope to provide improved mobility and comfort along with reduced injury potential. And really, like I said, provide the best tool to the crew member that we can provide. Then we want to be able to provide them the ability to kneel down and pick up a rock, like they're going to want to do in their geology science that they're working on. We want this to be a very reliable and durable suit so they can use it day after day in a dusty environment and not have to do a lot of maintenance with it while they're needing to do their mission. So there's a lot of those kinds of aspects that go into improving the suit that we're going to provide for the lunar missions.
Improved mobility is not the only feature engineers have been working on. The astronauts will also be carrying a special backpack known as the PLIS.
So the PLIS is the Portable Life Support System. It's the backpack on the spacesuit, and it has all of the interesting parts to keep the crew member alive while they're on their spacewalk. So it has oxygen stored as pressurized gas for breathing, pressure regulators that regulate the oxygen pressure inside the spacesuit, and then a ventilation loop and a water loop that we call the thermal loop that provide trace contaminant and carbon dioxide removal from the breathing environment, and also cooling for the crew member and the suit onboard avionics and electronic systems.
While the PLIS has been on previous spacesuits, this improved version will offer new technology, greater control of its systems for the astronaut, and longer life for each EVA, allowing more exploration.
The PLIS labs are awesome, super fun places, and we physically assemble the parts to build the life support system, and then we test it. It's our opportunity to find things and fix things before we get it on orbit. We love what we do. We really want to see the system fly and be useful and help a person explore the moon in a more capable manner than they were able to do during Apollo. So it's a great job.
So I want you to perform some isolated joint movement to understand how the suit moves and then be out.
Testing for the new spacesuit continues underwater in the Neutral Buoyancy Lab. Here, the weightless environment of space can be simulated to put the suit through its paces.
So being able to test the suit in the pool and microgravity environments allows us to iterate on our design and make it better and get feedback from astronauts and from other instructors and trainers.
Could you reach all the way across and do the cross switches with your opposite arm?
Oh yeah, it's really easy to get all the switches with my opposite arm. I would rate this as excellent.
Come on.
I know, I guess gonna get lower and flatter.
Yeah.
Hold on. Oh my
You
God.
did it! Very good.
So if this could happen in real life, this is a spectacular translation. Rex and I are very lucky. It is like a, brand new spacecraft.
Even has the new smell and everything.
It does. New car smell.
Spacesuits are also tested in the Active Response Gravity Offload System, or ARGOS.
Yeah, so the Argos electronically is able to tune an astronaut exactly to whatever gravity it is that we're practicing that day, whether that's microgravity, lunar gravity, or Martian gravity. The other nice thing about Argos is you're able to get the instructors and the engineers right next to the astronauts as they're working, helping the astronaut figure out a problem as they work through the development of that test for the suit or for a piece of hardware and get that real-time feedback.
Spacesuit hardware is not the only thing being tested on Earth. NASA is looking at human performance as an important factor in designing EVAs and spacesuits.
So related to a spacesuit, a lot of times people think about the actual engineering, the hardware, the different pieces, but I want to look at the EVA scenario from the human really inside the suit and make sure that their performance, both physically, cognitively, is going well. So we want to look at things like physical exertion, cognitive workload, injury risk, and really just trying to make sure that they're not impaired by the EVA system any more than they have to be.
The NASA team uses virtual reality technology, motion capture, and other tools to study what it takes for a human to conduct an EVA.
And what we're able to do is bring actual, no-kidding data to the table that really removes the opinions. That's probably our primary benefit for how we kind of enhance the EVA community is we take a look at this not from a hardware, not from an operations standpoint first. We look first at the human and then kind of say, what do they need to be able to do to be ready for the job?
All the work on the spacesuit here on Earth is building up to the ultimate test, to fly it in space.
So we're actually building a flight unit of that XEMU, and we're going to launch it to the International Space Station. And we will do an EVA with a current spacesuit, an EMU that we use today, and the XEMU with it. We'll go out in pairs and we'll have the astronauts working together, one in the old suit and one in the new suit, and we'll test its functionality in a microgravity or a low gravity environment out in the vacuum of space. That will help us test a lot of its systems.
The EVA on the space station will set the stage for the future, when the suit will need to perform a variety of missions beyond low Earth orbit.
Yeah, so a great example is NASA's Gateway. So even though it is in lunar orbit, it's still a microgravity platform, so astronauts would still be floating in space. And so we can use a lot of the lessons we learned from the International Space Station to do spacewalks on the Gateway. It's actually really advantageous to use one spacesuit both at Gateway and on the lunar surface. So the exploration spacesuit can do both of those things.
For EVAs on the moon, the new spacesuit will give astronauts unprecedented abilities as they explore the lunar surface.
Really, this is the first time we're trying to bring a suit that's optimized for human performance and optimized for lunar exploration so that you can actually bend down, interact with the ground, so that you're going to have the visibility that you need, the mobility that you need to accomplish these tasks.
This new suit will allow us the flexibility to really do exploration. Get down on the surface and send geologists to the surface and really let them act like geologists in a spacesuit. This is the first time in history that a suit like that will have been created, and it's really exciting to be part of that. To do what NASA was meant to do, and that is to do exploration. And this suit will really help enable the agency go do exploration.
Well, everyone in my generation wasn't alive the first time we went to the moon, and we want to do it again, and we want to do it better. We want to go do more science, we want to stay longer, we want to get more out of it, and we have the technology to do it now. So we're really excited about it.
With its new technology, new design, greater mobility, and greater versatility in how it can be used, NASA's new spacewalking suit is truly tailored for the next generation of space explorers.
Did you know that if you were born after 2000, during your entire life there has been someone living in space? That's thanks to the International Space Station, which celebrated its 20th anniversary of continuous human habitation in 2020. You've probably heard a lot about the incredible science that happens on board the station, but the outside is actually prime real estate for all kinds of experiments and technology development too.
The International Space Station is a great platform to demonstrate service and technology because it provides power, data, there's robotics in space.
With Tech on Deck, we'll be talking about some key experiments that have taken place outside in the harsh environment of space, which will help us advance human exploration.
Nexus is NASA's Exploration and In-Space Services Project Division at the Goddard Space Flight Center. The goal of the division is to usher in a new era of more sustainable, affordable, and resilient spaceflight, both near the Earth, around the Moon, and deep into the solar system. Many members of the Nexus team started off with the Hubble telescope servicing missions. We've taken that technology, applied that to robotic servicing.
From robotic refueling missions that will help spacecraft live longer and journey farther to autonomous navigation systems, NASA's Exploration and In-Space Services Division has taken advantage of the wonderful opportunity station offers to test new technologies. As we look to exploring our solar system and beyond, and establishing a sustained human presence in space beyond low Earth orbit, many of these technologies will play a key role.
We use the robots in Space Station to demonstrate the technologies needed to enable satellite servicing in the future. We've also used the robots on Space Station to do some of the more repetitive tasks or the dangerous tasks that astronauts shouldn't be doing, like going outside the space station to try to look for ammonia leaks. Robots are very good at moving fine, delicate positions, moving back and forth, doing those sorts of tasks that would be challenging for humans to do.
In order to live in space, astronauts will first need to reach their far-out destinations like Mars. This will require refueling and replenishment of oxygen supplies, things the robotic refueling missions worked to demonstrate on station. They will also need to be able to construct, maintain, and repair their habitats, as well as adapt to unforeseen circumstances.
Because we're in space in low Earth orbit, we have lighting conditions that are representative of objects in space, and so allows us to launch tools and modules into orbit, put them on the space station, and then use those robotic technologies and all the infrastructure that comes with the space station to mature those technologies in a way that's much, much less expensive than if we try to launch our own satellite and demonstrate those for the first time, not using the space station.
For these endeavors, Nexus's work with astronaut tools, satellite servicing, and on-orbit assembly and manufacturing will do the trick.
We develop the technologies that are needed to advance exploration in ways you can service satellites in the future, build satellites and build structures on orbit, refuel satellites on the way to other planets, repair those satellites much like we do on that side of space station. Both humans and robots are used to maintain habitats in space. We're developing technologies that can be used by NASA and others to make those a reality.
The International Space Station is the perfect testing ground for technologies that will be used to propel humans farther than we've ever gone before. The station is helping us build the necessary foundation to make it possible. Outside of the International Space Station, space can be a lonely place. Most satellites are designed to live their lives alone, and we've yet to find life outside of Earth. This means that when we launch a spacecraft or satellite, for the most part it's on its own, and has a limited lifespan based on when critical items like fuel run out, or something breaks. You wouldn't throw away your car if it ran out of gas, and thanks to the advent of modern-day robotics, software, and computing power, we will soon be able to apply that logic to satellites. We are on the cusp of breaking the one-and-done paradigm that exists for most satellites. An important step in that direction is NASA's Robotic Refueling Mission, or RRM, demonstration on the International Space Station. Because refueling a satellite that was not designed to be refueled has never been done before, practice is key. With that in mind, the first two phases of RRM took place on station from 2011 to 2017, and tested the tools, technologies, and techniques to refuel and repair satellites in orbit.
RM and RM Phase 2 were designed to demonstrate end-to-end refueling of a spacecraft, as well as the first steps of cryogenic refueling or replenishment. We wanted to use the robot on the International Space Station to be able to demonstrate the technologies and techniques to do this refueling, so we built innovative tools to bridge the gap between the robot and the payload interfaces.
Consisting of a module or box affixed to the outside of station and robotic tools, the demonstrations use station's Dexter robot to operate tools and test servicing tasks such as cutting and peeling back protective thermal blankets, unscrewing caps, turning valves, transferring fluid, inspection, and intermediary steps leading up to refueling.
Once we were all done, we were able to transfer fuel end-to-end through a spacecraft fill and drain valve that wasn't designed to be robotically refueled.
The RRM demonstration helped test and prove technologies that will make refueling satellites not designed to be refueled possible, something that will be further demonstrated by NASA's On-Orbit Servicing, Assembly, and Manufacturing 1 mission. But it also helped to lay the groundwork for designing future satellites in a way to make them more easily serviceable.
These missions were important because we needed to demonstrate in orbit that this technology was ready. There were a lot of people that felt that at the time of RRM that the technology was so far in the future that they didn't feel what we were talking about was possible. So we needed to demonstrate in orbit this technology so that we could start changing the paradigm and incorporate these technologies into the future spacecraft designs and missions.
RRM Phase 1 and 2 were all about preparing an interface for refueling, which in many ways is half the battle. To robotically refuel a satellite, you need to perform a series of highly dexterous tasks to even access the valve. The next step is to actually perform refueling tasks, which is what the next phase, RRM-3, has been demonstrating on station over a series of operations since 2018. RRM is a critical piece of the sustainable spaceflight puzzle that helps us with the ability to robotically refuel, repair, and maintain satellites in both near and distant orbits, well beyond the reach of where humans can go today. For generations, Mars has beckoned. Now, the red planet is within our reach. But how do we get there? The key is in the details and in the technology. First and foremost, you need fuel. This is not only true for getting to Mars, but for any form of deep space exploration. Being able to replenish fuel on a long-duration journey means massive amounts aren't needed up front, freeing up space for other important things. Enter Robotic Refueling Mission 3, or RRM-3 for short. This demonstration launched to the International Space Station in December of 2018 and has helped us develop tools and techniques needed to replenish cryogenic fluid in space. Transferring cryogenic fluids has never been done before in space. These super cold fluids can be used as propellants, coolants, or for life support systems. Being able to replenish these fluids that run out, otherwise known as consumables, is an important part of the sustainable exploration roadmap. Not just for Mars, but for NASA's Artemis program, which will land the first woman and the next man on the moon. Since refueling cryogenic fluids in space has never been done before, RRM-3 tested the technologies and techniques needed to make that possible. First, we sent the RRM-3 payload and its 3 main tools to Space Station, where astronauts assembled the parts.
When I was living aboard the International Space Station in the spring of 2019, I was fortunate enough to take part in the very small part in the Robotic Refueling Mission 3. And my job was to unload the components of the actual RRM-3 from one of our visiting vehicles, and we take it into our Japanese experimental module, the GEM, where we have an airlock. And right inside of the airlock, we unpacked all of the boxes, much like you would a piece of furniture that you had to assemble yourself at home. So unpacked all of the pieces, we did a checkout, we worked with the ground, we got everything assembled, and then we placed it into the Japanese airlock. And from there, we were able to put it outside of the International Space Station. So my involvement in RRM-3 was the physical final assembly of the actual components.
RRM-3 was delivered to the space station by a SpaceX Dragon on the company's 16th Commercial Resupply Services mission and installed on the outside of station by the Canadian robot Dexter. Dexter then picked up the tools from the JEM airlock and installed them onto the RRM-3 payload. The ground operations team was now ready to begin operating the 3 tools to test how they would work in space. For the first set of operations, conducted in August 2019, Dexter used one of the RRM-3 tools to prepare the RRM-3 module's interface for transferring cryogenic fuel. The second set of operations was then conducted in October 2020. For these, Dexter used one of the remaining 2 tools to insert an 11-foot-long hose in an open port and the other snake-like camera inspection tools simultaneously to verify the hose's position in the inside of RRM-3's tubing. This marked the first time that Dexter had tools in both arms working the same tasks simultaneously. The RRM-3 demonstration added experience and information to NASA's knowledge base on the storage and transferring cryogenic fluids in space. It is currently still on station, where it will conduct one final set of operations in mid-2022. For getting to the Moon, Mars, and beyond, cryogenic fluids will be used as propellants and to maintain life support systems for astronauts. The Mars atmosphere is made up of carbon dioxide, which could be converted to liquid oxygen, a type of cryogenic fluid that could be used both as propellant and for breathing. Astronauts may be able to fuel rockets or replenish their oxygen supplies using compounds found in the Martian atmosphere. A tool on the Mars Perseverance rover called Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, is set to demonstrate the first ever conversion of Martian carbon dioxide to oxygen, which is another important piece of the puzzle. In order to make a sustained human presence in space a reality, humans and robots will have to work together using technologies like those developed by RRM-3 and MOXIE.
A lot of people ask about, whose job is exploring outer space? Is it robots or is it humans? And I believe that it requires teamwork between robots and humans, and that our exploration is not complete or even possible without both. So robots can go farther, they're less expensive, and they can go for longer periods of time. They don't require as much maintenance. You don't have to feed and care for a robot, much like you do if you send me back to space. So like the Mars rovers, the Galileo that explored Jupiter and its moons, the Hubble and the soon-to-be James Webb Space Telescope, they are doing missions in locations that humans, to this point, don't have the capability to go. There's also something very important about humans wanting to know what it's like to be there. It's not enough for humans to take a picture of Mount Everest or Antarctica and say, oh, okay, that's what it looks like. The human condition is we are born to explore. We're born to say, what if? What's just beyond what we know? And what is it like to be there? And so the human side of space exploration, first of all, it's orders of magnitude closer to Earth. We have not been able to send humans nearly as far as we've been able to send robotic probes. But they're 2 very different missions, and they serve a different type of curiosity.
Mars and deep space are calling human explorers, and RRM-3 is a step toward helping NASA answer that call. Though it sounds complex, the idea is simple. Having the ability to refuel will allow NASA to embark on longer journeys to explore the depths of our solar system. Did you know there's a 3-eyed raven currently perched on the International Space Station? Not an actual bird, but rather a technology payload that is helping NASA develop a relative navigation system, or autopilot, for spacecraft. Launched to station in 2017 aboard a SpaceX Dragon on the company's 10th Commercial Resupply Services mission for NASA, and installed on the outside of ISS by station's Dexter robot, Raven is equipped with 3 distinct camera vision systems: visible, infrared, and LiDAR. Combined with NASA-developed software algorithms, this rotating module of technology keeps a weather eye on arriving spacecraft. Raven's head, containing its 3 eyes, or cameras, is always on the swivel, which is made possible by its integral gimbal.
Raven is an on-orbit test bed that was built to mature technologies related to relative navigation sensors and algorithms. Raven was launched to the International Space Station aboard a SpaceX Dragon capsule in February 2017, and it's been operational on the space station since that time. So using 3 different sensors on Raven that are on a movable gimbal platform, Raven can track the incoming visiting vehicle to station all the way from very, very far away, all the way up to where they dock with the space station. So basically, at any given time, Raven can tell you where the incoming visiting vehicle is in space relative to the space station and what attitude or pointing direction it is.
Raven sends the data it collects from tracking and observing incoming spacecraft to its processor or brain, called SpaceCube. This information then tells Raven how it needs to move to continue to track the spacecraft and gauge relative distance and positioning. NASA engineers have taken what they've learned from multiple Raven observations over the years to adjust and fine-tune the relative navigation system as needed, so it's ready for the upcoming on-orbit servicing, assembly, and manufacturing 1 mission, which will robotically refuel a satellite, among other things.
Raven is a sensor system that can image an object, process those images on board in real time with advanced algorithms, and calculate the pose of the object relative to itself.
These factors come together to create something like spacecraft autopilot. Much like a self-driving car can maintain cruise control based on the speed of the vehicle it follows, 2 free-flying spacecraft will be able to dock with one another using this technology. Though this operation is similar to the autonomous docking of visiting spacecraft to station, Raven's unique application is necessary for docking 2 satellites with the challenges of each moving and rotating in every direction during the rendezvous and docking phase.
Using that information to then guide the first spacecraft to autonomously rendezvous with and dock with the second spacecraft. So that means finding it in space, aligning with it appropriately, and then bringing the 2 vehicles together without smashing them into and destroying each of them, all without human intervention.
This capability is the kind of thing you need for docking with spacecraft that were not originally designed to be docked with and serviced, which happens to be a vast majority of them. That's why Raven's time on station is critical for the future of on-orbit servicing, assembly, and manufacturing, or OSAM. The OSAM-1 mission will use Raven's relative navigation capability to autonomously, meaning no humans involved, rendezvous and dock with the satellite, and then telerobotically refuel it. This will be the first time in history a spacecraft not originally designed to be serviced will be refueled as a means to extend its operational life. Raven is also important for future exploration missions.
Raven's technologies can be applied to future NASA missions because if humans want to make a footprint in the solar system beyond low Earth orbit, which is where the International Space Station is located, we're going to have to rely on some form of autonomous docking technologies in the future. Whether it be an unmanned cargo vehicle meeting up in orbit around the moon, refueling tankers located in geosynchronous Earth orbit, or a return vehicle arriving on Mars in advance of a crewed landing, all of these feats will require the technology we're developing with Raven.
Using its 3 eyes, Raven is looking to the moon, Mars, and beyond.
Relying on highly robust autonomous systems becomes more crucial the further you move away from Earth as the communications time increases drastically. Once you move past low Earth orbit, it becomes very impossible for humans on Earth to do these highly complex maneuvers in real time. It's more efficient to allow computers to perform these sequences autonomously without human intervention.
Although Raven has successfully concluded its main mission objectives, it remains on station. Meanwhile, its team on the ground is using what they've learned to develop more never-before-seen technologies that will enable future space exploration.
Before I started digging in that other bag, here you go. No problem.
If you need to fix something in space that wasn't designed to be fixed, it's going to take all the experience you can get. With that in mind, when the International Space Station's Alpha Magnetic Spectrometer, or AMS, needed repairs, NASA's Johnson Space Center and Goddard Space Flight Center used their joint expertise to make it happen. At Goddard, that expertise resides in NASA's Exploration and In-Space Services Division, or NEXUS, which evolved from the office that was responsible for the Hubble Space Telescope servicing missions. Key to these missions was the development of specialized tools. While you've probably heard of Hubble, you may not be as familiar with AMS, so let's start there. Designed for a 3-year mission of sifting through cosmic ray particles, AMS has been looking for signs of dark matter from its position on station since 2011. Hundreds of researchers have used the data collected to investigate the source of the mysterious substance to help us better understand the origins of the universe. To continue this important data collection, AMS needed an upgrade due to general wear and tear from the harsh environment of space, specifically a new cooling system. A repair could extend its life beyond what was originally planned. Sounds easy enough, right? In fact, due to the instrument's complexity and the fact that it was not designed to be repaired, even gaining access to the system to replace it was difficult. AMS's design did not incorporate the kinds of interfaces that make spacewalks easier, or have the ability to be serviced with traditional multi-purpose tools. And so, over the course of 4 years, NASA got to work designing and developing some of the most complex spacewalks since the Hubble servicing missions in the 90s and early 2000s to fix AMS.
The AMS tools themselves were unique. They were built specifically for this task, a task that was never intended to be performed on a spacewalk. And so that required a lot of thinking about how we were going to get inside so that we could access the tubes that we needed to cut into and then install the new thermal control system, but also how to put handling aids on it so that we had a place to attach our tethers, to attach our foot restraints, to have handholds, have a place to attach equipment that we needed out there.
NASA developed 20 specialized tools to make the job possible, and on November 15, 2019, astronauts Andrew Morgan and Luca Parmitano got to work. On this first spacewalk, astronauts needed to get access. By design, 5 of the tools could be seen floating off into space, attached to the debris shield that was removed to give the astronauts access to the heart of AMS.
The debris shield handling aid was one of the first tools that Luca installed on the EVA, and this gave us a handhold to install on the debris shield to work from, but also a handle for me to hold on to ultimately when we jettisoned it overboard to the aft side of the ISS, which was a lot of fun to do.
The astronauts continued with 3 more spacewalks over the next 2 months, using all of the specially designed tools. One such tool was the Tube Cutting Guide, which was a direct result of multiple practice sessions at Johnson Space Center facilities like the Neutral Buoyancy Lab. While practicing, astronauts communicated the need for a way to identify and verify the correct tubes to cut, since they all look the same to the astronauts' eyes within the spacesuit.
After we had removed the debris shield and the VSB cover, now we have the tubes exposed, and we actually had to cut into those tubes in order to pull out the correct ones to connect with the new thermal control system, the new pump. In order to do that, we had to be very sure of the tubes that we were cutting. These ingenious tube cutting guides installed over the top of the tubes and made sure that we knew and we were communicating correctly with the ground team to make sure that we were cutting the correct tube at the right time.
In January 2020, Luca Parmitano and Drew Morgan completed the 4th and final spacewalk to repair AMS. Because of their work and the ingenuity of tool designers and engineers, the instrument is now back in commission and able to continue to collect data about the origins of our universe for years to come.
People from Goddard and JSC spend a lot of time developing these tools with their knowledge and the support of astronauts like Chris Cassidy. And we are very thankful that we were privileged to use those tools and to put them to very successful use. Thank you very much.
virtual exhibit hall while we were on break. Every year at the ISS R&D conference, the STEM panel is an attendee favorite. Space has always inspired student interest in STEM, and the ISS is an incredible platform to facilitate student scientific inquiry and experimentation, providing an authentic connection to space for students, especially young girls and students from diverse backgrounds. Which is why I am so excited to hear our next panel of outstanding ladies to discuss the future of STEM education. Here to lead that conversation is Emily Calandrelli. Emily is the host and co-executive producer of the hit Netflix series, Emily's Wonder Lab. Each episode features Emily and a group of kid scientists as they learn about STEAM through experiments and fun activities. Emily is also an executive producer and Emmy-nominated host of Fox's Exploration Outer Space and was a correspondent on Netflix's Bill Nye Saves the World. Emily, who was named to Adweek's 11 Celebrities and Influencers Raising the Bar for Creativity in 2017, is also an accomplished writer and speaker on the topics of space exploration, scientific literacy, and equality. Her chapter book series, The Ada Lace Adventures, centers around an 8-year-old girl with a knack for science, math, and solving mysteries with technology. The third book in the series, Ada Lace, Take Me to Your Leader, was part of the initiative from NASA and CASIS, Storytime from Space, where the book was launched into space and read by an astronaut aboard the ISS to an audience of kids. Emily frequently gives talks about the importance of science literacy, the benefits of space exploration, and the challenges for women in STEM careers. Her first two TEDx talks, I Don't Do Math and Space Exploration is the Worst, have garnered over 1 million views on YouTube. Emily attended West Virginia University, where she received a Bachelor of Science degree in Mechanical Engineering and Aerospace Engineering, and MIT, where she received 2 Masters of Science degrees, one in Aeronautics and Astronautics, and the other in Technology and Policy. Go ahead, Emily. All right. It's my honor to bring Emily aboard to moderate this dynamic panel. Do your thing, Emily.
Thank you so much, Jennifer. I'm so excited to be with you all here today. We have a really wonderful panel of experts that are going to tell some pretty incredible stories. So the way that this is going to work, we're each going to introduce ourselves for 3 to 5 minutes. And then after that, we're going to take some questions for the panel. I have some questions for all the panel members, and then we're going to take questions from the audience. So as you listen to these stories, think of what questions you'd like to ask our experts. So I'm going to go ahead and tell you a little bit about me. Jennifer did a very good job. That was a pretty wonderful, thorough introduction. But my name is Emily Calandrelli. You may know me on the internet as the Space Gal across social media on Instagram and Twitter and Facebook, and most recently, TikTok. My background, as Jennifer mentioned, is in science and engineering, but today I'm a science TV show host. And that all started with my show, Exploration Outer Space, which airs Saturday mornings on Fox and also on Amazon Prime. And as the host and executive producer of that show, I work to cover stories about rockets and spaceships and rovers on Mars and searching for aliens and all the good stuff like that. We work to show that the space industry is more exciting than it's ever been before, but we also showcase some really human stories, like the woman who is one of the only deaf female pilots in the world who dreams of becoming the first deaf astronaut, or the team at MIT's Media Lab, who's working to make space data, specifically satellite data, more accessible to people here on Earth. They're using satellite imagery to help a community in Africa fight an invasive species, or the blind woman at NASA who's working to make all of the research at NASA more accessible to the general public, more accessible to more people, or the story of the 11 deaf men, the Gallaudet 11, who helped NASA get to the moon in the 1960s. That story helped our show win our very first Emmy this year. That was just announced a few weeks ago, so we're really proud about that. But beyond Exploration Outer Space, I have a series of children's books. The Ada Lace Adventures, as Jennifer mentioned, is a 5-book series about a 3rd grader who loves science and mystery and adventure. She solves mysteries with tech and gadgets that she builds herself. One reviewer on Amazon said that it's like a nerdy version of Nancy Drew, which I love. The 3rd book in the series went to space through the incredible Storytime from Space program, where they select children's books to be launched to the ISS and be read aloud by an astronaut. And so now there's a video of astronaut Anne McClain reading my book, like the words that I wrote in space, for all children all over the world. It's viewable on storytimefromspace.com for free. It's just a very, very cool program and a dream come true for me. I have 2 new books coming out next year. One that I wrote after my daughter was born called Reach for the Stars, and another one that I haven't announced yet, but it's a science experiment book inspired by Emily's Wonder Lab. You all are the first to hear about that one, actually. And so I'm excited about that. But beyond the books, my latest and greatest adventure was Emily's Wonder Lab, my own Netflix show. And that one was many years in the works, because ever since I started in this career, I've been pitching science shows to major science networks without much success. And the feedback I got was fairly disappointing, because if you think of these large science networks, and I won't name any names, but you can imagine which science networks I'm referring to, the audience that watches these networks is predominantly male. And so the feedback that I would get, because of course the science shows that I was pitching myself as the host of those shows, they would say, we don't know if our predominantly male audience will relate well to a solo female host. And in one particular meeting, they asked me, do you have a boyfriend or something that can co-host the show with you? Which, you know, is disappointing feedback to get. So you can imagine my surprise when I get the call from Netflix and they say, not only do they want my show, Emily's Wonder Lab, but they're totally fine with me filming this 9 months pregnant, because I was wildly pregnant at the time when I was pitching this. And so now there is a 9-month pregnant lady hosting a science show in 190 countries in 38 different languages on the largest streaming platform in the world. And I don't think I knew the impact that that would have, because I'd hosted science shows before, but this was different. This was a different type of representation to a different type of audience, and I received thousands and thousands of messages from families all over the world thanking me for the show, which was not necessarily the response I thought. That I was excited that people loved the show, but they weren't saying that they were just fans of the show. They were thanking me for the show because their daughters now all of a sudden want to become scientists when they grow up. Here in the States, dozens of girls all over the country dressed up as me for Halloween because they wanted to be a scientist. Some of them even added a pillow in their stomach so that they could be pregnant to look like a scientist. And so anyways, it's just a story of how powerful representation can be. And I know we're going to hear a lot more stories about representation and the power of it on this panel. So thank you so much for having me. And I'm really looking forward to hearing the stories of the other panelists. Next up, we are going to hear from NASA astronaut, Dr. Serena Anand-Chancellor. Serena, go ahead. Oh, Serena, I think you're muted.
My fault, everyone. See, the astronaut's the one with the technical difficulty here after all the instructions, and I failed to unmute myself. We'll start again. Good morning and good afternoon to everybody out there. I'm so happy to be with you all. Thank you so much, Emily, for the introduction and really for telling your story. I love hearing stories from other women and how their career path went and the challenges that they had. As Emily said, I am an astronaut. I'm also a doctor. You can see the white coat right behind my head there, hanging up on the door. So I see patients and in the hospital and in the clinics, and I love it. More recently, I spent almost 197 days on board the International Space Station as part of Expedition 56 and 57. It was quite an honor to be up there. Emily told you about Storytime from Space, and I remember reading books from space. And let me tell you, there's nothing cooler than being able to float and read a story to everyone from space. It was one of the neatest things I did up there. But for a lot of you watching, you look at me and what I've done and where I am, and it almost seems like an impossible journey. And it's not. I started just like each of you as a student, as a learner, as a young woman, maybe not knowing what her career path was and how to head and what direction. I will tell you, I was thrilled and just loved to learn about space as an 8-year-old girl. And I grew up in a family of 4 girls. So it was in my family, my father was a professor in engineering and excellence was expected from the beginning. So for me, it was really neat when my father and my mother saw me watching NASA space shuttles launch over and over. They sat down and said, "Do you want to work for NASA?" I said, "Absolutely. I have no idea how to get there, but I think that's what I want to do." And so they supported me from the very beginning. That led to some interesting situations. So my father, being an engineer, put me in engineering camp, and I was the only girl. So I cannot tell you how it was a little uncomfortable being the only girl, amongst 12 other boys sitting in engineering camp. But after a while, that really became the norm for me. And so I got used to it. I worked my way through school, always with the goal of working for NASA, perhaps becoming an astronaut. I'll be very honest, early on, I didn't think I wanted to be a doctor and wear that white coat that you see behind me. I had no idea that was in my future. I started off as an engineering student in college, and then I changed my mind halfway through. I went pre-med. And so I say that because for those of you in your undergraduate education or whatever level of education, it is okay to stop and change your mind if something else feels right. And for me at the time, I loved my engineering degree. I completed that degree, but I wanted to go to medical school after that and learn how to be a doctor. Medical school seems like a lot of years of training. It almost seems impossible and it will take forever. I will tell you those years fly by, and I will tell you that you have plenty of time. There's no rushing. You do what you do and do what you love. And I loved learning about medicine. Somewhere towards the end of medical school, I learned that there was actually medicine in space. I learned about a field called aerospace medicine and where the training programs were. And I remember the day I stood there and called those programs and I said, hey, how many people do you accept every year? And they said, we take one. And I could have put a limitation on myself. I could have said, there's no way. One person they take a year. But, an old boss once told me, you have to throw your hat in the ring. You have to try. And so I tried and I got in. And that sort of started my journey in the field of medicine and aerospace medicine. And I began working for NASA as something called a flight surgeon. A flight surgeon is a physician who looks after astronauts and their families. And I spent a lot of time in Russia, all over the world. I mean, it was an amazing journey. And then I thought, I need to go for it. I'm going to apply for the astronaut corps. And I can't tell you, besides my family, who was very supportive, and my close friends who always knew that I would accomplish whatever I set my mind out to do, there are a lot of people who like to tell you how hard things are and how difficult it will be and what the odds are and the percentages that you will achieve or not achieve. And you really have to shut those people out, almost put on earmuffs, because you know your own truth. You know what you're capable of. And yes, the odds are difficult when you apply to the corps, but if you don't believe up front that you can do it, then you never will make it. It has to be true up here in your mind first. You have to believe it. So I came into the astronaut corps. I was really honored to join the 20th class of NASA astronauts in 2009 and spent many, many years training before my first flight to the International Space Station. And I will tell you that journey along the way almost is better than the actual mission when you get to fly, because of the people you meet, the things you learn about yourself, how you develop as a person. And so I actually really appreciate Emily telling that story when she was pregnant, because I think a lot of young women believe that in order to have it all or to accomplish these great things, that they can't do other things that might be important to them. And I will tell you that you can have it all. You can be an astronaut, you can be a scientist, you can be a researcher, you can have a relationship, you can be a mother. And these are all very important things. So don't place any limitations on yourself as you proceed with your career or whatever you choose to do. And so a lot of people ask, what were the biggest lessons you learned and what would you like to share about your career path with students listening? And the first thing is, don't place limitations on yourself and don't let others do it for you, because they will. And expect greatness. Expect greatness from yourself from the beginning, because if you don't, you won't be able to achieve what you want to achieve. Your parents, your friends, those who love you, expect greatness from you all the time. And you just have to walk around like you're the best thing out there you ever dreamed of. So thank you for letting me do that introduction, even with my IT flub at the beginning. I'd love being able to connect with everybody out here, and really happy to take part in this panel today.
Thank you so much. That was just like a book of really good life advice. Expect greatness from yourself. Serena, thank you so much. That was so good. Okay, so next up, we are going to hear from Gitanjali Rao. She was Time Magazine's first ever Kid of the Year. I'm sure you have seen her face. I'm so excited to hear her story. She was recognized with this amazing award because of her achievements as a scientist and innovator. Gitanjali, welcome to the floor.
Hi, thank you for having me. I appreciate it. So I'm going to keep this fairly short. However, my journey started at the ripe old age of 4 or 5, which I really discovered my passion for not only science and technology, but making the world a better place using science and tech. And so I would say day in and day out at the dinner table, our family was always talking about problems we saw in the community, right? But every single piece of news affected me in a way that it didn't everyone else. I wanted to look at the world in a perspective in which I could make a difference as someone who was 4 or 5 years old. And I put my mind to it, and I started to look at the world in a way that a lot of other kids did it. And that's what I do to this date. I use science and technology as a catalyst for social change to help solve global problems. So since then, I created a device to help detect for lead in drinking water, another one to help diagnose for prescription opioid addiction, and a tool to help detect and prevent cyberbullying at an early stage. And the list goes on and on and on. But that's really where my journey of innovation started, looking at simple problems around me and trying to take simple solutions and make them into reality as well. So beyond that as well, I started to recognize that our society saw science and research separate from bringing awareness and advocating for solving them. But I saw a need to combine the two. And I'm a strong believer of saying that there's no use of a solution without consumers knowing why it's needed. And there's no use in raising your voice for a problem when you're not a part of the solution. And I started to put out the message that no matter your age and no matter your talent, we can't complain of a situation at hand if we're not a part of the solution. So I started to take action because while I tried different solutions to the best of my ability and the resources that I had, I recognized that one person can't do this alone. I shared my process with students across the world to start their own journey in the form of innovation workshops, which I run to date. There are many problem-based learning resources, but I wanted to introduce students in schools to simple tools and step-by-step processes that we can use to solve global problems. We deserve an education system where we're not just judged by our ability to memorize concepts and give an exam that shows our knowledge. We'd like to apply what we've learned and use our talents and creativity to influence society. So this led me to organizing my thoughts and documenting a step-by-step process that all students can use. To date, I've worked with about 50,000 students across 26 countries, 5 continents, and I've conducted about 325 workshops. And the numbers are only going up from here, which is very exciting. And beyond that too, what I was provided the opportunity to do was write a book. And for the other thousands and even millions of kids that I might not be able to reach out to firsthand, I wrote a book called A Young Innovator's Guide to STEM, which outlines my process as well as gives students more than just inspiration. It gives youth real world ways to, put their ideas out there and tackle global problems, even farther than what a science fair does. It takes your ideas and brings them to reality. So I guess looking back at my journey, it's been a fun ride and opened my eyes to many new truths as well. And I think a very long-lasting message that stuck with me is that recognitions come with responsibility. And that's something I look back every single day. So I hope by being here, I'm representing everyone from every walk of life to share that we can do it too, right? We see people around us and decide that a job isn't for us or we can't do it. But you make that choice for yourself and be what you want to succeed and help others. And the blood, sweat, and tears are real and are needed to make a difference, even if they can never be seen. But we all come out of it stronger. And if we have a goal to use the resources around us and our talents to alleviate problems in society, that is success. And to me, success is making a difference in one other person's life by our actions as well. And when we think about it, I personally am proud to say that I've failed more times than I've succeeded. Because no matter how much good happens, every change maker, every innovator, and no matter how pretty, quite literally the magazine cover is, everyone has their own ups and downs. And it's a natural part of the process. And it's something that shouldn't be stigmatized. So I'm going to end this off with a story and then hand it back over. A few years ago, a kind lady sent me pieces from her Monopoly game in the 1950s. And she wrote me this letter that reminded her of the time when she was young and she couldn't take a class beyond Algebra 2 just because she was a girl. And she worked as a cleaner in a biolab for years and years in order to acquire knowledge and eventually become a scientist. So the reason I always love to share that story is because it shows us that we've come a long way, but we still have so much more to do when we look ahead. So I hope that with my work, I'm putting together a future of innovators and change makers who can allow us to walk into a better tomorrow together. So thank you so much for your time, and I'll hand it back over.
Oh my gosh, Gitanjali, I feel like all of our jaws are on the floor right now just by how incredibly impressive you are as a human being. Thank you so much for that. There were so many good nuggets of insight. With recognition comes responsibility. I mean, the fact that you acknowledge that and you take that so thoughtfully, that is so incredibly impressive. The thought about failure and how failure is so important, I absolutely agree. I feel like if we're not failing, we're not trying hard enough. Thank you so much for that. You are absolutely amazing. So next up, we are going to hear from Rihanna Munjan, a mechanical engineer who's passionate about all things STEAM, space, and slime. And I suspect we're going to hear a little bit more about our resident slime and space expert, a little bit more about the slime. So go ahead, Rihanna.
Thank you. Wow, this is a pretty incredible group of women that I am surrounded by. And I think what has been really heartening is everyone's story that I've heard so far, I have seen myself in all of them. And I think that is true for many young people, women, and BIPOC folks who are trying to enter into STEM. I'll just give a little bit about my history because I've had kind of maybe, I don't know, it feels a little bit like an unusual journey, but maybe it's more like what most people go through. So I had teachers and my parents really pushed me into going into science and technology. They just saw something in me that I had the brain that could work on these problems and to solve problems. And, I went into mechanical engineering not because I had anybody telling me, or I didn't have anyone around me that was an engineer. I knew no engineers growing up. My parents didn't go to college. And it was this whole thing where I had a teacher who looked at me and said, you should be a mechanical engineer. So I, honestly, I looked up what the salary was and I said, great, that sounds good. I'll just see what it's all about. And I just fell in love with the problem solving. My challenge was, I was a first-time college student. I struggled in that different setting. There were some aspects that weren't my learning style. And, one thing that you don't really prepare for is how intense your life can be with, living on your own and having your relationships and having all the responsibilities and studies. And I ended up dropping out during my first go at college, so I felt that failure early on and I felt like I didn't belong. And, after working for a couple of years, I felt the ceiling of where I could go without a degree. And I missed being in that space where I could study engineering. And it took me a couple years, but I ended up going back in my later 20s to finish my mechanical. Thought was, I'd go into something really practical, go into green building design. I've always thought about NASA and, but I just didn't feel like it was a space for me. I didn't know, I knew very few engineers. The engineers that I worked with at my university, they were predominantly men, they were mostly white. So I just didn't see myself in these spaces and I really struggled to grasp with those concepts. But I ended up getting involved with this project in 2017. I'm sure you could all remember the eclipse that was happening. I'm based in Oregon, so we got a front row center view of the eclipse that was happening. And my advisor, my graduate school, who ended up being my graduate school advisor, invited me to join this program to send weather balloons into the stratosphere to take photos of the eclipse. That was the beginning of my NASA journey. This was a program that was sponsored by the organization. And I really, during that project, I was able to be a leader. I was able to use every aspect of my education. And we had the most successful, beautiful photo of the eclipse happening in the stratosphere. And that moment was like, oh, this is where I belong. This is where I can be there. I can make a difference here. And so I decided to pursue my master's, which was all funded through NASA projects. Emily mentioned slime, but I, started with how can we better water plants in space? There's a lot of challenge, trying to figure out how do you move liquid in a zero gravity environment? So I studied, my focus of my study for my graduate degree was microgravity, capillary fluidics. How do we get the water from point A to point B and using as little energy, using as little work as possible. So I started by how do we water plants? And then that led to, okay, well, we need to move other liquids. How do we better process urine in space? What are the fundamentals of evaporation in space? There are all of these different questions that I was trying to answer during my master's degree, which then led to the most exciting, childhood dream fulfilling project where what happens when you send Nickelodeon slime into space? So our lab partnered with Nickelodeon and we sent 6 liters of that, very viscous green slime to the space station. And we developed these demonstrations for the astronauts to, just to see what happens. We had no idea. So not only did the astronauts make a very big mess and had quite a bit of fun, we got a lot of scientific insight as to how do these free-flowing, highly viscous liquids work. And, the astronauts did experiments like they created these giant bubbles and filled them with air and popped them. They filled water balloons filled with slime, so slime balloons, and popped them to see what would happen. They shot slime at each other through syringes. They tried using ping pong paddles to knock it back and forth. It was this incredible scientific discovery. We were watching it real time. We were watching the astronauts learn how this liquid moved in space. And we were learning all of these new properties. It was just the fundamental of scientific discovery, which was just incredible to be a part of. And that wasn't the end for me, because then we took all that material, we took all of this great fun footage, and I was able to host a children's program for Nickelodeon, walking through the science of slime in space. So here I was, 5 years before, not feeling like I had a place in this environment, and now I have
Well, it looks like we lost Rihanna there for a second. Oh, I think she might be back. Okay, let's go back to her.
Sorry about that. It seems like my internet, I'm also having technical difficulties, Serena. You and I are, we're kindred spirits today, I guess we could say. But anyway, as we keep moving forward, as I move forward through this journey, I realized how important it was, how important representation was. So not only did, I get to be a part of these projects, I made it a priority to put myself in these spaces so people could see what an engineer could look like. Because I think it's really important for young folks, maybe not even young folks, maybe folks who are just wanting to return or do something different, they can see what an engineer can look like, and it looks like them. So that's why I'm so excited to be a part of this panel of women who are showing who it is, who's doing the work and who's making it happen. And the fact that we need more of y'all in these spaces. So hopefully you heard the end of that. I'm really excited to talk more about it and learn more about our panelists.
Rihanna, thank you so much. That's such a powerful story of fighting your way into these spaces where, people have been historically excluded, and now providing that same representation that hopefully other people will see themselves in one day. It's really wonderful. And also the slime in space is such a great SciComm example, because it seems at first like really silly and fun and eye-catching, but as you mentioned, there's hardcore science and fluid dynamics and microgravity research that goes behind it, and it's rooted in real science and research, which I absolutely love. So thank you so much for sharing your story. Next up, please welcome Sayaka Umemura, an engineer at the Japan Aerospace Exploration Agency, also known as JAXA. Please welcome Sayaka.
Thank you very much for your introduction, and it is a great honor to be in this great, amazing panel. I'm a coordinator of the Space Life Science Experiment. Now I am in Norfolk, Virginia, for preparing the cell biology experiments to be launched on Energy 16. You can see in my back that there are some labs. So after this panel, I will go back and start preparing for them. Actually, the space and biology are my favorite interests since I was a very small child. So I'm very happy to be working in this STEM job. And a lot of women play active roles in the life science experiment in space. Actually, contributions by many women are indispensable for the success. 70% of my team is women. It's amazing. And actually, I love space experiments. So to share my pleasure about the space experiment, I've made a lot of leaflets to explain about the results of space experiment and held workshops for Japanese communities. And actually, I've been involved in the collaboration with Asian countries, and we learned a lot from the collaboration with the international cooperation worldwide. Not only myself, I'd like to introduce about JAXA STEM project. So I have some front side. Yeah, thank you very much for showing that. So next, please. Today, I'd like to introduce the 3 JAXA projects. The first one is Kibo Robot Programming Challenge. It is held with JAXA and NASA cooperation, and it's an annual programming competition for Asia Pacific students. This program uses onboard robots, NASA's Astrobee and JAXA Innovo. In 2020, more than 1,300 students from 7 countries and regions participated in the competition. The finalists experienced robot control on the ISS with their own programs. This year, a second competition is underway with the final round being held in September. The advantage of this project is that everyone can join this project with just a PC and the internet connection. So no need for experience or knowledge. So that's why there are a lot of participants from Asian Pacific region. The second project is Asian Health in Space, AHIS. Recently, we launched Asian Health to the ISS with SpaceX 21 and 22, and that includes 2 missions. The first mission is for scientists and students. They will analyze Bezoar's clone on the ISS. And mission 2, that is for students in many countries. 12 countries and regions have participated in this project, and they will grow the seeds returned from the ISS. Plant cultivation experiment is very good for learning the difference between the difference of the gravity between the space and on the ground. So it will fit and it will show the difference and the space to the Asia Pacific region students. The third project is small satellite deployment. And that's where JAXA has released 33 satellites from 24 countries. And those satellites of 15 countries are the first. And that aroused a lot of interest in space development and utilization in those countries. We've continuously provided small-scale deployment opportunities worldwide in collaboration with the United Nations. And this year, we started Kibo Cube Academy, where to learn how to develop satellites. So it covers not only education, but also practice. So all three projects focus not only on STEM, but also sustainability, the SDGs. No need for experience, a wide range of age groups, and the coverage from education to practice. We hope that those STEM projects will support the future space generation. Thank you.
All right. Thank you so much, Sayaka. That's really wonderful. So now we're going to ask a few more questions of the panelists, and then we'll take audience questions. So think of any questions that you may want to ask the panelists. But I'm particularly interested because it sounds like a lot of us overcame a few challenges to get to where we are today, and people who may be watching may be thinking, how can I do that? And I think all of us would agree that you don't get here by yourselves. It's often you need some sort of support network. And I wanted to ask you all what specific programs or organizations or whatever it is, what do you think helped you get to where you are today? And just to give an example for myself, for me, I'm from West Virginia. I'm the first person in my family to pursue a degree in STEM. I felt like I didn't know what I was doing. And for me, my NASA space grant at my university was incredibly helpful to me in terms of helping me figure out what opportunities were out there, what internships were available, what scholarships were available to help me pay for college, what research opportunities were available to help build my resume. They were like a one-stop shop to figuring out how to stack my resume to look good for future applications for anything else that I was going to do. So check out your NASA space grant. Every state has their own. But yeah, if anybody else wanted to chime in, maybe I'd start with Dr. Serena Anna Chancellor. Is there any specific programs that you would recommend to the future generation?
So yeah, great question. I will tell you what I did just to start, and that's I really tried to find mentors and listen to people that I could identify with. Someone that I could look at and say, okay, wow, I can do that. That person kind of seems like me. And sometimes it was a woman, and sometimes it was a man, but it was also someone willing to listen to me and answer my questions and, talk to me about their research or their science. So the advice I give the advice I give to students is, hey, bother the people where you love their work, where you say, wow, I really want to own my own lab. I want to run my own science. Bother them and ask them about their research. But I really try and push experts in the field to share their time. And so for me, I love that you mentioned the NASA space grants, because that is a great way to get involved. And the one thing that the COVID pandemic from starting last year and still extending through now has enabled everybody to do is to communicate virtually. So it is pretty easy nowadays to log on to a talk like this one and listen about the opportunities that are available, and have a little notebook with you and write those down and take advantage of everything that you can almost listen to from the comfort of your home. No matter what state you are in, NASA Space Grants is available. And internships are available through the space agency as well. And I will tell you, all the commercial space agencies that are out there now are offering internships or educational 1-month rotations and opportunities. There's more out there now than there ever has been before. Use the internet, utilize it to search, make those phone calls. Don't be afraid to send off an email. There are people there who will help you get to where you want to be.
I totally agree. And just to promote another program for anyone listening who's an undergrad, the Brooke Owens Fellowship is for women and non-binary students who want to work in the aerospace field in any capacity, STEM or in policy or business or communications or marketing. The Patty Curry Fellowship is a very similar fellowship, very prestigious fellowship for Black students who want to work in the aerospace industry. And these are just incredible communities of people to help lift you up in the space industry and the aerospace industry. Does anybody else want to speak to any programs that they would recommend to the younger generation?
I can say something here. I definitely think the biggest way that I benefited was programs like STEM Scouts, which actually got me involved in science and technology at a very early age as well. And I know one of my personal favorites was the space unit. And we were talking about this earlier, but I remember being fed like all sorts of things with water mixed in. Because apparently that's what it tastes like in space. And it was like when I was in 6th or 7th grade too. So that was probably one of my biggest starting points. So it's, a smaller branch of Boy Scouts of America. It's an incredible program for anyone interested in scientific topics, but sometimes just don't know where to start with them. And so we've done everything from, magnets to light to space to robotics. And every year we just always do something different. And I'm still part of STEM Scouts to this day. So is my little brother who's 8 now. So that's definitely one of the biggest programs that got me involved in the world of science too.
Great. Sayaka?
And I have the one, yes, that when I was a university school student, I was dispatched to the ISC under the JAXA student dispatch program. It was great experience for me because I could hear a lot of presentations about space, but not only that, I could have talked with students, like-minded friends, intensively about space that led me to the space field. So the communication with the people who share the same dreams is very important. And there are a lot of programs provided by NASA and JAXA. So like as I explained about the robot programming challenge or the small satellite deployments, a lot of those programs are there. So please try to access to those programs.
The only thing that I'd like to add, because I don't know any of specific programs, it was to find cheerleaders for who for you. I had a lot of cheerleaders throughout my tenure, and every time that I would go and meet with them, they would have all of these opportunities. Those folks just knew exactly what was going on, and their advice was to just show up, because so many people self-select out of these programs, all of these great programs that have just been mentioned. A lot of people decide, no, maybe it's not for me because I'm not good enough or for any reason. And I think just taking the time to show up, maybe it's not for you because you're not interested, but listening to the people that are in your community, trying to form that community, and just trying to just take advantage of what the folks are steering you towards.
I love that message of like, don't count yourself out, because so many of these things, we have this imposter syndrome of thinking that we're not qualified to apply for the thing that we would like to apply for. But in reality, those things, the only people who win are the ones who show up. And so I think that we all have this misunderstanding of how these things are awarded, because you count yourself out before anybody else can, because that fear of rejection can be so overpowering. Now, Sayaka, you've had the opportunity to work with JAXA and NASA. Can you speak a little bit about what that's like, maybe how the two agencies differ and the importance of international collaboration when it comes to space exploration?
Well, thank you for asking. It was amazing experience. I felt the same point is that everyone in space field loves space and is proud of our jobs to be related to the ISS and the benefits for humanity. Actually, that I felt like all space people are just one team with us. And I felt the different point is in the United States, there were a lot of female managers. I was so inspired how excellent and proactive they were. Actually, actually, my current boss is a female, very great female. However, unfortunately, in Japan, there are still very few female managers. So, in the future, with the increase of the numbers of female managers, I hope that will be the more diverse discussion. Thank you.
We now have a few audience questions rolling in, and one is, how do I find a mentor to help me with my career? And this is something that I've definitely struggled with throughout my career. I didn't have that many mentors when I was younger, and I think part of it was I was always I felt like I was going to be bothering somebody to ask for advice. And what I've realized as I've gotten older and become a mentor of younger students is that it's actually pretty flattering when younger people ask for your wisdom and advice. And I thought that I was going to be annoying asking them for, advice on whatever I was doing. But in reality, most people are willing to give a few minutes of their time to offer advice. And that's something that I would let the younger generation know. But does anyone else want to speak on best practices for how to find a mentor in your career?
Yeah, I'll say a couple words. I love what you said, because I love to tell, especially young women, bother those people. Ask them questions. I think they, you brought up two things, Emily, which I thought were great. One, imposter syndrome. And for those of you who don't know what imposter syndrome is, it's just this fear that we all have, even most of us on this panel, that someone's going to find out we're not as smart as they think we are. And it's just a fear that maybe you're not good enough and you won't be able to achieve the things you want. And it can be pervasive and something that maybe holds you back from doing the things you want to do. And you have to fight it constantly. And so, especially young women, I feel this is something we struggle with, and we won't go for those opportunities. And so when you're looking for a mentor, your mentor doesn't have to be in the field that you want to go into. Sometimes a mentor is just someone who keeps encouraging you and tells you that you're good enough and tells you to go for that opportunity. If I were to look at the mentors that I still use today and have for the past 25 years, they're not astronauts, they're not scientists, but they're people I trust. And they're people who believe in me and that I still go to when I'm not sure what to do. And so look for someone who believes in you and is happy to help you work through problems or help you decide what to do or what path to go on. That's what makes a good mentor. And they are in high schools and in colleges and in industry and all over the place. And it could be your next door neighbor. You just don't know. But you'll know it when you find it because it feels right.
I love that. Does anyone else want to speak on mentors?
I think starting with, who is in your community, actually finding a person who should be your mentor. For me, it started with teachers. There were certain teachers that I vibed with, certain teachers that were my biggest cheerleaders. And that's where I started. I had teachers that said, this is what you should be doing. I believe in you. But then they had a larger network. So when I would be interested in something, so I started becoming interested in green buildings at one point in my studies. So my teacher connected me with another person who was in industry. And, then I got to a point where no, I'm not as interested.
Looks like we lost Rihanna for a second there. But yeah, does anybody else want to speak on mentorship?
Well, I will talk about the mentorship. In JAXA, we have established the women mentoring system, actually, and it is very good. Not only mentoring, but also we have the online meetings with the people about the child rearing. And it is now we can have the online communication, so it is easier to get mentors. And the important thing, I think, is to show your interest to everyone, your mother, your teacher, everyone, then they will connect you to the other person. So I think at least I welcome to be a mentor, because with mentoring, we can learn from them too. So please don't be awkward. That's my message.
I love that. And also, like the main takeaways here are don't be afraid to bother somebody because generally they're totally fine with it. And make your passions known because the network that Rihanna and others mentioned is that's the best part of mentorship is that mentor probably has friends throughout the industry that they can introduce you to. So yeah, not being afraid to bother people is really great. Now, this is not something that not any of us on this panel have to be convinced of, but I'm curious to hear what your answers are when you're asked. What is the purpose or the benefit of diversity and inclusion when it comes to science and technology? Does anybody want to tackle that answer or that question?
Yeah, I can say something here. I guess more of like from a youth perspective too, middle school see the largest drop of girls in STEM fields, right? And I went through that experience just especially because when it comes to girls in science and technology, one, it looks or almost we are putting science and tech out in a way where it's almost scary. When I was introduced to, girls in STEM, I'd never seen a girls in STEM camp without, coding and robotics involved. And science was portrayed in a very, very terrifying way to me. And so really how I think it needs to be put out there is in the format of how can it be used to solve global problems? And right now we're not taking into consideration what? That's like half the world's population, which is all women, right? And right now, more than ever, we need to maximize innovation and creativity, which means every woman, every person of color, every, youth out there, and everybody can make a difference in our daily lives. It's really just putting that message out there for people to want to do that. And the first step to do that is one, putting out science in a manner that everyone can start to love it. And secondly, showing other girls role models in the field and putting out more more diverse examples out there, right? Even like on the media, we've all kind of grown accustomed to the specific example of what a scientist is. And again, we've been talking about Emily's story about, her show, which my brother loves, by the way, but is her show of doing it pregnant too, and how a lot of other girls across the world would put pillows under their shirts and things like that. And similarly, that's the idea that we need to get across, right? Is the fact that not every scientist out there has, frizzy hair, wears sunglasses and has, or not sunglasses, glasses and has pocket protectors, right? That scientists can be anyone. Anyone can be an innovator. Anyone can be a change maker. It's really just how we put that message out there.
I have a pretty funny anecdote. Hopefully my internet holds out. So my part of my project, so not slime and space-based, but when I was working on plants, plant watering in space, because we were so early in our designs for our hydroponic plant watering systems, we couldn't use real plants. We had to make some kind of simulated roots. And my advisor came to me, he's a white man, and said, plant roots at this level of growth act a lot like hair, and I don't know what to do. I don't know how we can simulate hair. And, as a Black woman with natural hair, I've used different kind of hair products like weaves to change my style. So I said, well, why don't we just use a weave and make roots out of that? And this man, he didn't know anything about weaves. So this was during the pandemic. So I guided him through a Google search about what weaves were and how they worked for hairstyles. And I had some in my nightstand, and I did all of these experiments at home about how they work and if it could simulate plant roots well enough. Turns out they did. So I created these simulated plants braiding into these intricate designs, and those plants are in space. So I sent weave to space, and they've already been experimented on with the astronauts. So the astronauts have held my weave in space. And it's like he would have never come to that idea. I mean, I had to explain to him what a weave was. And if he didn't have a Black woman on his team, I have no idea what they would have done. It would have been not nearly as good and not nearly as funny as me sending weave to space.
This is my favorite story I have ever heard. This is This is exactly it. I mean, and like when you step back from it, it's the purpose of having people with different backgrounds and different experiences at the table solving a problem is that you're all looking at the problem from different angles and you're coming to it with different solutions and ideas from your own lived experiences. And that improves innovation. That makes science and technology better. And so when you exclude people with different types of experiences, you're hurting innovation. You're making that technology worse. If you are designing science and technology that's meant to be used by everyone, you need people with different experiences at the table influencing its design. And I think that is just the best, most perfect, memorable story to drive that point home. Does anybody else want to speak on that topic? I know we only have a few more minutes left of this panel, unfortunately, but that's a really, really wonderful one. Rihanna, I was really hoping to hear more from you about, so the slime in space example, as I mentioned before, I think that's just the perfect SciComm example of something that is so fun and eye-catching and especially really great for younger kids, but is rooted in real science. Do you have any advice for how scientists and engineers in the field can help make their research more accessible to the general public, perhaps even more accessible to kids, to the younger generation?
I think the biggest takeaway that I learned from that project, and so part of the program is I had a group of scientists, of younger kids working with me. And I would ask them, okay, so what do you think is going to happen to the slime when the astronauts do X, Y, and Z? And they understood the concepts. Like I was amazed at these third and fourth graders who, might not have had the language. They might not have known the words hydrophobic or viscous, but they had the scientific inquiry and the scientific mindset that they just got it. They got it as a young kid. So, I think a big part of it is not being afraid to introduce these topics. They may be complicated, but folks get it. A lot of people get it, especially at those younger ages. So first of all, it's not being afraid to introduce those topics, and then working with people who can help you distill that information in a really friendly way so that it's digestible for kids. Because a lot of the stuff that we're all doing is very interesting and people are really excited about it. But if you can't talk about it in a way that everyone can access it, you're just going to create those barriers and make it seem like, oh, maybe I'm not smart enough to understand because I don't know these big words. But at a fundamental level, everybody kind of gets it.
Yes, absolutely. And I think making sure you're meeting people where they're at, especially when it comes to the language that you choose to use to describe something, is so key. Well, that's all the time that we have today. Thank you so much, ladies, for this incredible panel. I am so proud to be on the same screen with all of you. And now we are going to bring back Jennifer Scott Williams to close us out.
Oh my goodness. That panel was fantastic. A big thanks to Ms. Calandrelli and all of the panelists, Uma Murasan, Dr. Anand Chancellor, Ms. Zhao, Ms. Mungin. I think we're all a lot more hopeful about the future. And since this is the final panel of the conference and we're all powerful women in STEM and space, I think it deserves a special finisher. If you have your glasses handy, I propose a toast. Hey, folks online, hey, you can join us too, okay? Let's see, whatever's in your glass, coffee, tea, water, vodka, no judgments, just lift it high, okay? Come on with us. I would like to honor all of you ladies for all you have done to promote STEM in women and girls, and for all of your contributions to science and space exploration with NASA and the ISS National Lab. I also honor all of the women and men too that put in the hard work and long hours to create and prepare experiments in labs around the world, propose the research, and even get the research from Earth to space and back. Thank you and cheers to you. Cheers. All right. That was tasty sip. Tasty sip. Speaking of the future, The ISS National Lab has an exciting new STEM education opportunity they will be announcing this fall. Here's a short video to tell us more.
Hi, I'm Michael Roberts, Chief Scientist of the International Space Station National Laboratory. Dedication, service, leadership. Many words describe Lieutenant General James A. Abramson, U.S. Air Force retired. From his days as a student at the Massachusetts Institute of Technology to his distinguished service in the United States Air Force, Lieutenant General Abramson grew in renown and respect, rising to key positions within the Air Force and NASA. In 1984, upon the request of President Reagan, Lieutenant General Abramson served as the first director of the Strategic Defense Initiative until his retirement from active service in 1989. Since his retirement, Abramson has kept very active, maintaining leadership positions within a variety of aviation industry companies and serving on the board of directors for GOI Corporation and Global Relief Technologies. NASA awarded Lieutenant General James A. Abramson an Exceptional Public Achievement Medal for his contributions to NASA and the nation during his time as chair of the board of directors and interim executive director of the International Space Station U.S. National Laboratory. Lieutenant General Abramson continues to serve our nation to inspire us today. In this spirit, it is our pleasure to announce the creation of the James A. Abramson Space Leader Fellowship at the ISS National Laboratory. In tribute to him, we acknowledge the excellent example he provides, and we honor the continuing legacy of Lieutenant General James Abramson. Through this fellowship, we seek to provide opportunities for tomorrow's leaders in the aerospace industry. The fellowship, to be announced this fall, will promote the communication of scientific discovery and technological innovation, provide insight into U.S. leadership in commercial space, and help to inspire the next generation of explorers and innovators.
An extraordinary opportunity named in honor of an extraordinary man. Thank you, General Abramson, for all you have done for our nation. To find out more information about the fellowship, check out the ISS National Lab website at www.issnationallab.org. Well, as you can see, I have my trusty co-host from last year, the one and only JPW, aka Mini-Me #1. He will help me introduce the next segment. Take it away, son. Let's see. Go ahead.
The last 2 days, we've been honoring the individuals and organizations doing innovative research on the ISS. And we just heard how the same assets that make the ISS a powerful laboratory for scientists also make it an invaluable platform for student research, investigations, and educational outreach. Join me as we honor STEM pioneers from 2020 and 2021.
Welcome back. I'm Kirk Costello, the ISS Program Chief Scientist. So far, we've heard about 12 of our awardees for the ISS RDC conference. Today, we'll focus specifically on those STEM awardees in ISS research results and innovation. So help me welcome the last two award recipients.
Our first award today for innovation in STEM education goes to Patricia Tribe for Storytime from Space. Storytime from Space was one of the first STEM projects sponsored by the ISS National Lab. It is a program in which astronauts video record themselves reading to the children of Earth. The videos are then edited and shared through a website where millions of children have watched and been inspired. Storytime from Space is a project of the Global Space Education Foundation, a 501c3 nonprofit education foundation. The founder, Patricia Tribe, is a true innovator who identified early on the lack of early childhood and elementary programs that could help inspire the next generation of the space science workforce. Patricia has selected dozens of books that meet strict scientific accuracy criteria in order to create authentic learning experiences for children without propagating misconceptions. She has taken the program from basic book readings to science video demonstrations by the astronauts and science curriculum for educators. Through this program, Patricia has made a global impact, reaching and inspiring millions of children. Our final award today for innovation in STEM education goes to JAXA's Kibo Utilization Office for Asia for their conduct of the Kibo Robotic Programming Challenge, Kibo RPC. The Kibo Robotic Programming Challenge is an education competition to solve various given problems by using real robots in the ISS Kibo module. This program is made possible through the NASA-JAXA collaboration under Japan-US Open Platform Partnership Program, JP-US-OP3. The program's goal is to foster the next generation of scientists by making space more accessible to young students. Also, by creating programs to control the space robots, STEM knowledge is increased and new engineers are nurtured. The first Kibo RPC was held from October 2019 to October 2020. A total of 1,168 students participated on 313 teams from 7 countries and regions, increasing cooperation between developing spacefaring countries in the Asia-Pacific region, as stated in the JP-US OP3. The second Kibo RPC is planned for 2021, and a call for participants has started. The competition will be held annually until 2024.
Congratulations to this year's award winners, all very inspirational. Okay, we're now coming to the end of the conference, but we have one major announcement to make. I hope after all that encouragement, you were able to visit the virtual vendor booths because that was your entry into the drawing for fabulous prizes. So, who's ready to win an Oculus Quest 2 VR headset and ISS Above device? I can't wait to see who won. So, let's do this.
The winner of this year's giveaway is Omar Hamway from the University of Georgia. Congratulations, Omar. The ISS National Lab will be in touch to get your prizes to you.
Man, I'm not going to say anything about it, but we know who the real team is, right? All right. Okay, thank you, Joshua. And thank you again to our platinum sponsor, Boeing, and all our silver sponsors and exhibitors. We couldn't do this conference without you. Finally, a quick reminder that our virtual technical sessions with live Q&A will run from Monday, August 16th through Wednesday, August 18th. Over 60 presentations and posters are slated in a variety of subject areas, so there's something for everybody. You can register to attend the technical sessions at the American Astronautical Society website at www.astronautical.org or www.issconference.org. Just scroll to the bottom of the event website for the registration link. Most of all, many, many thanks to each of you for attending this year's 2021 ISS R&D Conference. We hope to see you in person next year in Washington, D.C., July 25th through the 28th, 2022. On that note, mask up, take care, and be well.
The moon to stay, and this is how.
Hey, you're watching NASA TV, on the air and online every day, on this planet and beyond.
human progress that mark recorded history. In my judgment, this nation's orbital pioneering in space is of such historic stature, representing as it does a vast advancement that will profoundly influence the progress of all mankind. It signals also a call for alertness to our national opportunities and responsibilities. It requires physical and moral stamina to equal the stresses of these times and a willingness to meet the dangers and the challenges of the future. John Glenn, throughout his life, has eloquently portrayed these great qualities and is an inspiration to all Americans. This film, in paying tribute to John Glenn, also pays tribute to the best in American life.
New Concord, Ohio wasn't on many maps until February 20th, 1962. It came to fame in a single day with an American adventure that history will call the John Glenn story. Fashioned in the American image, this pleasant little city typifies a nation's ideal way of life. A man might make a good life here in the circle of family and friends. And a boy might let his imagination soar. He might explore the wonders of the wide world all about him, life's simple mysteries. With bright discovery, daily opening doors to knowledge. He can look away to distant places, to exciting adventures, hidden only by the horizon and the future. Like this boy, like boys everywhere, young John Glenn dreamed of the future as he looked to faraway new frontiers. Why, he might even learn to fly. This town and these people, they knew John Glenn as a schoolboy, as a teenager, and as a neighbor. Like Mayor Taylor, they followed his career as he blazed a trail across the high sky.
I watched John Glenn grow up from a freckled-faced, red-headed lad into the man you all know today. John's youth and his life today are an example for all Americans to follow.
New Concord High. Like these youngsters, John attended school here. His principal and teacher was Harford Steele.
He was an excellent student, and he graduated with honors from our high school. I taught Johnny and hundreds of others that our democracy is a priceless heritage, and that we should preserve, protect, and if at all possible, make some contributions to it. He has made a significant contribution in his mission in space.
And this fine new school in New Concord, it's the John Glenn High School, with its first graduating class receiving diplomas. Young John helped his father about this shop when he wasn't in school, or acting as lifeguard in the summer at High Y Camp or at college. John went on to college at Muskingum, right in New Concord. The high regard of the college is expressed by its president, Dr. Glenn McConaughey.
John's conquest of space has captured the hearts and the imagination of all Americans. So have his superb qualities of leadership, moral and physical strength, and emotional stability.
John found time for athletics, winning 4 high school letters. Kingdom coach, Ed Sherman, recalls John Glenn's athletic record.
John played football right here on this field. He was captain of his high school team and played center for the college. He has proven the value of teamwork both as an athlete and later as an astronaut. Just like these boys, John took an active part in our physical fitness program. He proved that a good mind and a good body always go together.
Campus discussions are inspired by the first orbital flight of an American.
I think that John Glenn, by his flight, has given us an opportunity to see that while we have a chance to do something for our nation, too, maybe I'll even go somewhere sometime.
We had the same opportunities that he had. Glenn proved by his flight that there are still many frontiers to be explored and conquered.
And that just shows how very vital our education is if our future is to be go.
Glenn always had a strong spiritual side, as Dr. Charles Moorhead recalls.
John Glenn attended Sunday school and services at this church when he was a boy like Randy Bradley here.
Let's attend services for a moment at John Glenn's church. John and Annie were married at this church by Dr. Henry Evans.
They made a most handsome couple. John in his Marine uniform, Annie a beautiful, happy bride. They both recognized the importance of the spiritual things of life as well as the mental and physical.
The trial is also great for those who wait, as recalled by Annie's parents, Homer and Margaret Castor.
Johnny's orbital flight was a real test of courage for Annie, too.
She was a very brave girl.
Annie had complete faith in the space program, just as she had confidence in everything Johnny set out to do.
This house was home for John Glenn. John Glenn Sr. and Mrs. Clara Glenn are gratefully proud of their son's accomplishments.
John was fully prepared for his orbital flight, as were the other astronauts and the entire team.
In a way, John has been preparing all his life for his venture into space. As a small boy, his idea of a holiday was a visit to the airport. And when he grew up, it was no surprise to us when he decided to learn to fly.
Flight commanded young John's major interest. He had to learn to fly. World War II interrupted college. He received his first flying lessons from pilot Harry Clever.
This is John's flight record with my comment after his first flight, which was eager to learn, relaxed, alert, and good coordination. He certainly has retained these flight qualities right into outer space.
Flight training at Pensacola and Corpus Christi. Many aviators have won their wings here. Like these cadets, John went on to Corpus Christi, Texas to learn about airplanes and navigation, with time also for physical conditioning and sports, and for religious inspiration. Like these naval aviators, to win his wings. The Navy's thorough training prepared Lieutenant John Glenn for wartime action in the South Pacific. Flying 59 missions in Corsairs like these, he joined in blasting enemy targets. Until there was peace, and Glenn returned to Corpus Christi as advanced flying instructor until Korea. Major John Glenn came back to combat to fly 90 missions to shoot down 3 MiGs. Following Korea, John Glenn came home to flight test the supersonic F-8U Crusader, to flash across the nation, California to New York, setting a supersonic speed record of 3 hours and 23 minutes. With with experimental thrusts toward speed and altitude. The limitations of time and distance were being brushed aside as experimental planes like the X-15 launched from its Air Force mothership rocket to record-breaking altitudes and speeds. Unmanned experimental flights and orbits pressed onward until it was time for man to orbit, until the word was go. Chosen from many Americans who answered the president's call, these astronauts dedicated themselves to study, training, and physical conditioning. With Alan Shepard learning about weightlessness as it will be encountered in outer space, and Gus Grissom becoming acquainted with the stress of greatly increased gravity, as Wally Schirra masters manual spacecraft control. 3 years of engineering skill and scientific experimentation have gone into this historic Atlas launching. Its component parts have come from countless sources, devised and fabricated by many thousands of technicians in hundreds of United States cities. And this, the motive power, carefully raised to position on its gantry. This, the Atlas, with power to develop 360,000 pounds of thrust, with capability to swiftly lift the spacecraft and its passenger as high as 160 miles, to inject the spacecraft into orbit at 17,500 miles an hour. And now the word is go, as the spacecraft is lifted into its position atop the Atlas. This spacecraft, 6 feet across at its widest heat shield end, 10 feet tall, built to withstand heat shield temperatures of 3,000 degrees Fahrenheit as the wind rushes by at more than 15,000 miles an hour. As the astronaut prepares for space flight, for adventure into outer space. Mercury control waits and watches, with the Atlas standing ready to throb into life. Ready. Friendship 7 is ready. And so is John Glenn. Gantry, elevators lift Glenn to the 11th level, the spacecraft level. Glenn takes his place in Friendship 7, looking towards the unknown. Ready. Mercury Atlas is ready, and so is the astronaut. The countdown is underway at Cape Canaveral, as all the world holds its breath, and all the world is witness.
Godspeed, John Glenn. 5, 4, 3, 2, 1.
John Glenn is go, and with him go all of mankind's dreams of someday touching the unattainable stars. Under a tropic sun, the tracking ship Rosenaught waits and follows his course as he flashes towards the coast of Africa. To John Glenn belongs an awesome panorama of the earth below. Beyond human sight, Friendship 7 makes a slow boat out of the sun as the spacecraft girdles the earth every 90 minutes. Like a shooting star at 5 miles a second, 17,500 miles an hour, John Glenn streaks away from today into the night of tomorrow, racing towards the dawn of yesterday. As Glenn sights the lights of Perth and Rockingham, as he flashes over Australia, across the Pacific, to contact waiting ground stations at Guaymas, Mexico. And California waits as Friendship 7 streaks home to the land of its origin. An unseen comet lining across the United States in 8 lightning minutes of flight. Completing 3 history-making circuits of the globe, John Glenn fires retro rockets to slow the spacecraft, to direct it back to Earth. 5, 4, 3, 2, 1, fire.
Roger. Retros are firing.
Good, indeed.
Are they ever? It feels like I'm going back toward Hawaii.
Then the first ominous note, the first warning of possible disaster. A chilling signal flashes an indication that the capsule's heat shield may be loose. The astronaut might perish like an earthbound meteor in 3,000 degrees of re-entry heat without the heat shield. Strapped over it, the retro pack might hold it in place. Cape Canaveral makes the decision.
This is Texas Capcom Friendship 7. We are recommending that you leave the retro package on through the entire re-entry.
As all the world listens and stands still and helplessly hopes, Cape Control shows the way. Using fly-by-wire control for re-entry, John Glenn rides his craft through the vastness of space towards the curving globe beneath. As science in its amazing exactness selects the Caribbean from all the oceans of the Earth to receive Friendship 7 as it blazes into the Earth's atmosphere.
This is Friendship 7, a real fireball outside.
A fireball. The fiberglass surface of the heat shield is starting to oblate, to melt and vaporize as a glowing electrically charged wake streams back to block off communication as the Earth's atmosphere slows the capsule's descent.
Friendship 7. Stroke is out. Coming down on 10, snorkels are open. Main chute is on green. Chute is out in reef condition at 10,800 feet and beautiful chute. Chute looks good. Rate of descent has gone to about 42 feet per second. The chute looks very good. Hello, Mercury Recovery. This is Friendship 7. Do you receive? Friendship 7, this is Steelhead. Be advised, I have you visually. Roger. What is your estimate on recovery time? Over. Estimating pickup now at 20 minutes. Over. Landing bag is on green. Friendship 7, ready for impact. Almost down. Here we go. Friendship 7, this is Steelhead. Hold you in the water. What is your condition? Over. Roger. My condition okay. Does the capsule look like it's okay? Over. The capsule looks good from here. Over.
Home to Earth comes the Voyager. Transported now to the aircraft carrier Randolph. In 4 hours and 56 minutes, John Glenn has streaked through 3 days and 3 nights and over 81,000 miles. Never a journey so far. Never a traveler so welcomed by the world. brief a journey in time. So far the way, so long the hours for those who wait, as Annie Glenn has waited. As all the world has waited. To salute the Glens with Vice President Lyndon Johnson. As the President of the United States arrives at Cape Canaveral to be greeted with John and Annie Glenn by the cheers of thrilled lines of proud Americans. In ceremonies at Mercury Control Center, President John F. Kennedy presents the NASA Distinguished Service Medal to astronaut John Glenn. As Annie and Lynn and David Glenn proudly share applause with the other astronauts and with the world. As John's parents learn firsthand about Friendship 7. As does Marine Corps Commandant General David M. Shoup and the President of the United States. And this rainy day in Washington is a happy day as the President and the astronaut arrive to drive through rain-washed, crowd-flooded streets to the White House for a reception as John and Annie Glenn with Vice President Lyndon Johnson greet distinguished guests, including astronaut Alan Shepard. Godspeed, John Glenn. Godspeed into the future, into even greater accomplishment, into the hearts of all Americans. Welcome to Washington. Welcome back to this planet. From the nation's capital to the towers of Manhattan to the ticker tape parade of New York, cheering crowds roar a mighty welcome, shared by all Americans, by free people everywhere. And across the land, the scene is the same, and the heart is the same, as John Glenn comes home to New Concord, Ohio. At the Capitol, there's an introduction by the Speaker of the House, the Honorable John McCormick.
Members of the Congress, it is a privilege, and I deem it a high honor, to present to you a brave and courageous American, a hero in World War II and in the Korean conflict, who recently, in a most notable manner, added glory and prestige to our country, the first United States astronaut to have achieved orbital flight, Lieutenant Colonel John Herschel Glenn, United States Marine Corps. Colonel Glenn.
Mr. Speaker, Mr. President, members of the Congress, I am only too aware of the tremendous honor that's being shown us at this joint meeting of the Congress today. This has been a great experience for all of us on the program and for all Americans, I guess, too. And I'm certainly glad to see that pride in our country and its accomplishments are not a thing of the past. I know I still get a real hard-to-define feeling down inside when the flag goes by, and I know all of you do too. The launch itself was conducted openly and with the news media representatives from around the world in attendance. This is certainly in sharp contrast with similar programs conducted elsewhere in the world and elevates the peaceful intent of our program. Today, I know that I seem to be standing alone on this great platform, just as I seem to be alone in the cockpit of the Friendship 7 spacecraft. But I'm not. There were with me then and with me now thousands of Americans and many hundreds of citizens of many countries around the world who contributed to this truly international undertaking voluntarily and in a spirit of cooperation and understanding. We are all proud to have been privileged to be part of this effort, to represent our country as we have. As our knowledge of this universe in which we live increases, may God grant us the wisdom and guidance to use it wisely. Thank you.
And crown thy good with brotherhood, from sea to shining sea. In the pattern of all our free American traditions, John Glenn's trailblazing venture into space has shown the way for human progress, for brotherhood around the world. His story speaks of people and places and industry, of the greatness that is America. It sings of the unselfish aims of a nation striving constantly for peace, directing all its power and persuasion toward the preservation of freedom. In its majesty and magnificence, this is the land. In all their historic greatness, these are the people. And the John Glenn story is their story. It throbs with a nation's restless energy. It soars with the adventurous spirit of Americans everywhere. Across this vast spread land, in all its towns and cities, on all its far-flung farms and ranches, deep in its reaches of forest and plains, of winding roads and rivers, majestic mountains and lakes and sea-lashed shores, people turned their eyes and hearts toward the high sky, sending their hopes and prayers, riding through space, with John Glenn in Friendship 7, as all the world watched and hoped, with mankind's wonderment about the universe, finding an approach at last toward fulfillment. In the John Glenn story.
It's all about flames, fluids, and materials research aboard the International Space Station. Hi, I'm NASA astronaut Tracy Dyson. Welcome to Station Life.
Station 2 for velocity calculation station assembly, steps 4, 5, and 4, 6. We're moving on to step 5.
You will go right now for that activity.
Copy. Thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
Welcome back. This month on Station Life, we're going to look at how the unique environment on board the International Space Station enables physical science research. Our space station is a laboratory unlike any on Earth. As we orbit in free fall around the planet, we have the opportunity to control gravity as a variable in our research. The pristine microgravity environment allows us to observe aspects of fundamental physics that aren't possible here on Earth. You see, gravity often masks or distorts subtle effects such as surface tension and diffusion. On ISS, these forces can be harnessed for a wide variety of physical science applications. So on today's program, we're going to look at how the lack of gravity affects the physical sciences of flames, fluids, and materials.
International Space Station is the largest, most complex object ever assembled in space, and is clearly visible from Earth with nothing more than the naked eye. From end to end, the station is slightly longer than an American football field.
The biggest shock, I would say, the biggest impact that I had during my flight is the first time I looked out the window of the orbiter and saw the space station. It was huge. It was huge and shiny and beautiful. Looking at it and knowing that a man-made structure that big is actually up there.
The interior of this incredible structure is larger than a 5-bedroom house, with 2 baths, a gym, and a 360-degree bay window. The station's mass is almost 1 million pounds, and it contains about 32,000 cubic feet of living space. The space station functions as a microgravity and life sciences laboratory, a testbed for new technologies, and as a platform for both Earth and celestial observations. The complex is made up of multiple interconnected modules, grouped together at the center point of a 357-foot-long integrated truss structure. Power is generated through 4 giant solar arrays attached to the ends of the truss. The pressurized components include 3 laboratories: the U.S. laboratory module Destiny, the European Research Laboratory Columbus, and the Japanese experiment module Kibo. The Russian service module is the structural and functional center of the Russian segment of the station. It provides living quarters, communication systems, an exercise facility, and flight propulsion systems. Other Russian segments include the functional cargo block, 2 mini research modules, and a docking compartment. The Italian Space Agency provided a permanent multi-purpose module, which can host up to 16 additional racks containing equipment, experiments, and supplies. There are 3 modules called nodes that connect the elements of the station and provide berthing ports. The primary residential areas include the Russian service module and Node 3 Tranquility, which contains a bathroom for crew hygiene and exercise equipment, a treadmill, and a zero-G weightlifting device. The Quest airlock provides the capability for extravehicular activity, or EVAs. This is the module that provides the exit for spacewalking astronauts to go outside the station to work. The cupola is a small module designed for the observation of operations outside the space station. Similar to a bay window in a home on Earth, but with a 360-degree view, the cupola allows crew members to observe the approach of vehicles, as well as all robotic arm operations and spacewalks. The Canadian-built space station robotic arm is a larger version of the arm on the space shuttle and is used to move equipment and hardware around outside the station. The space station is the home of 6 full-time crew members and is made up of astronauts and cosmonauts from nations around the world. More than 200 people have visited so far, and at least another 120 will live there over the next decade.
When you're up there for 6 months, or in Scott Kelly's case, an entire year, it's really the working in space part that becomes kind of the thing you love the most. It's the thing that gets you through the days. You're working with these professionals on the ground, and a lot of them have spent their entire lives working on these science experiments, and here we are up there and we get to operate them, and it's really an honor to get to do that. And in many ways, those are some of my fondest memories of being in space. You get to work these experiments, and they're usually watching over your shoulder from the ground. And there was a lot of times where I would do something, whether it was fluids or with flame research, it really didn't matter. The investigator would just say, "Whoa, whoa, whoa! Wait, do that again. That was incredible and totally unexpected." And that was what just made you smile big up there. When hey, we've been flying in space a long, long time, but we are still doing research that has unexpected results every single day on the space station, and I really love that about being up there.
In microgravity, something as simple as a candle flame looks and behaves completely different than here on Earth. Scientists are studying combustion on the space station with the hopes to improve efficiency of fuels and reduce pollution. Isn't that cool?
Fire, it is often said, is mankind's oldest chemistry experiment. For thousands of years, people have been mixing the oxygen-rich air of the Earth with an almost endless variety of fuels to produce a hot, luminous flame. There's an arc of learning about combustion that stretches from the earliest campfires of primitive humans to the most advanced automobiles racing down the superhighways of the 21st century. Engineers studying burning to produce better internal combustion engines. Chemists peer into flames looking for exotic reactions. Chefs experiment with fire to cook better food. You would think there's not much more to learn. When it comes to fire, flames are hard to understand because they're complicated. In an ordinary candle flame, thousands of chemical reactions take place. Hydrocarbon molecules from the wick are vaporized and cracked apart by heat. They combine with oxygen to produce light, heat, carbon dioxide, and water. Some of the hydrocarbon fragments form ring-shaped molecules called polycyclic aromatic hydrocarbons, and eventually soot. Soot particles can themselves burn or simply drift away as smoke. The familiar teardrop shape of the flame is an effect caused by gravity. Hot air rises and draws fresh, cool air behind it. This is called buoyancy and is what makes the flame shoot up and flicker. But what happens when you light a candle, say on the International Space Station? In microgravity, flames burn differently. They form little spheres. Space station flame balls turn out to be wonderful mini labs for combustion research. Unlike flames on Earth, which expand greedily when they need more fuel, flame balls let the oxygen come to them. Oxygen and fuel combine in a narrow zone at the surface of the sphere, not here and there throughout the flame. It's a much simpler system. Recently, on a space station experiment called FLEX, where scientists learned how to put out fires in microgravity, they noticed small droplets of heptane were burning inside the FLEX combustion chamber. As planned, the flames went out, but unexpectedly, the droplets of fuel continued burning. The flames are there, just too faint to see. These are cool flames. Ordinarily, visible fires burn at a high temperature between 2200 and 3100 degrees Fahrenheit. Heptane flame balls on the space station started out in this hot fire regime. But as the flame balls cooled and began to go out, a different kind of burning took over. Cool flames burn at the relatively low temperature of 400 to 1000 degrees Fahrenheit, and their chemistry is completely different. Normal flames produce soot, carbon dioxide, and water. Cool flames produce carbon monoxide and formaldehyde. Similar cool flames have been produced on Earth, but they flicker out almost immediately. On the space station, however, cool flames can burn for nearly a minute. There are practical implications of these results. For instance, they could lead to cleaner auto ignitions. One of the ideas that auto companies have worked on for years is HCCI, short for Homogeneous Charge Compression Ignition. In the automobile cylinder, instead of a spark, there would be a gentler, less polluting combustion process throughout the entire chamber. The chemistry of HCCI involves cool flame chemistry. The extra control we get from the steady state burning on the space station will give us more accurate chemistry values for this type of research.
I'm just getting my safety cutter on the other side of my IDA back here.
Copy, Terry.
A lot easier without the pool stanchion.
Absolutely, yeah. It's just like in the pool instead of that, with the exception of that big blue planet down there.
Exactly.
As the International Space Station flies 257 statute miles over the coast of Chile, Terry Virts, in the initial moments of his first spacewalk.
As you can see, combustion research on ISS can have tremendous benefits back here on Earth. We also want to better understand the behavior of flames in spacecraft to guide strategies for extinguishing accidental fires. The new SAPPHIRE experiment is going to be hot.
Sapphire is contained inside a 2-foot by 3-foot by 4-foot box that consists of an avionics bay containing the computer and instrumentation and a flow duct which holds the material to be burned. This will be carried aboard Orbital's Cygnus spacecraft during a scheduled cargo resupply mission to the International Space Station. Once at the station, Sapphire will remain on Cygnus until all the supplies are offloaded by the crew of astronauts. Once supplies are offloaded and replaced with trash from the ISS, Cygnus will depart. Once reaching a safe distance from the station, NASA Glenn engineers working from Orbital's Mission Control Center in Dulles, Virginia, will remotely turn on the experiment. Cygnus will then be put into free drift, while the Sapphire experiment is conducted up to 2.5 hours. The experiment's sensors and video cameras are designed to capture valuable data and imagery, documenting large-scale flame spread and material flammability limits. At the conclusion of the Sapphire experiment, the Cygnus vehicle will remain in orbit, while the data captured is downlinked to several ground stations around the globe and transferred to NASA Glenn's scientists and engineers in Cleveland. When downlink is complete, Cygnus will then begin its re-entry through the Earth's atmosphere, where it will burn up over the Pacific Ocean.
Serious. What are we going to do today?
Well, today, first I have to start off by saying that today I'm with someone who needs no introduction, because you've all seen him before. He's the guy we love, Dr. Don Pettit. Welcome to Station Life.
It's good to be back on station. I guess we're really not back on station, but it's good to be here on Station Life.
Thank you, yes. And I am just beyond excited today because Don is not only one of the most fantastic astronauts ever, he's like one of my favorite people. So this is a landmark event in Station Life history that we have with us.
And we both studied chemistry in college.
And look at what he's wearing.
See, I've got my periodic table shirt on.
Yes.
Okay.
Coffee cup.
Coffee cups. So,
Space cup.
So we have the first generation, the second generation, and both of these have been on station. This is a food-grade plastic, so it meets flight safety and all of that. Here is a variant of the second generation.
What's that for?
Well, this is for Earth, because this is slip cast out of porcelain, and it has this really cool, smooth look that shows off the form and the beauty of the design of this. Yeah, but porcelain is breakable. You can make these sharp shards, and in a weightless environment, they could float around. They could get in your eye, or even worse, you could inhale one of these shades and get them in your lungs. So we can't take the porcelain ones on orbit, but they're really cool looking, and we can use them here on Earth.
Awesome. Shall we?
Shall we? Notice your nose goes right in the cup, and you get this burst of
Java.
Java.
Yes.
Yeah. Yeah, that's a good mix of cream.
You like that?
Yeah. And let me read what it says. It says Space Cup, and that's the official name of this. That's the op-nom for the space station, the official sanctioned space station experiment. It's the name of the experiment is Capillary Beverage.
Capillary Beverage.
And the name of the cup is Space Cup. And then there are the words on it. It says Capillary Experiments International Space Station.
That is so
skeletonized
awesome.
NASA meatball.
This would be a collector's item for sure.
I was thinking, Trace,
makes me want to go back up there.
that if you look at everything that I will have accomplished in my life, in 400 years, nobody even remembered that I was even walked the surface of Earth or floated around in space. However, I predicted in 400 years, people living and working in space will be drinking, sipping, and toasting out of cups based on my design.
Yes. And you'll be legend. You are legend. What am I talking about?
They won't remember anything like that. Like, do you remember who invented fire? Let's see, and who invented the wheel?
No.
You see, nobody needs to remember who did these things. The important thing is you got to know how to build a wheel, and you got to know how to control fire, and then your civilization can take off. And in space, you don't need to remember who messed with the surface chemistry to make these, but you need to know that how to make them, and that you can use them, and it will help build the civilized nature of human beings interacting with each other when you're in a weightless environment.
Well, Don, I've just had so much fun having you on Station Life and sharing your invention and your passion for science and coffee and bringing people together. And I think you've done that in a number of ways, but none so illustrative as the space comet.
I call this a wrap. Huh?
Me too.
A normal coffee cup or a normal open container just simply won't work in a weightless environment, because the liquid will be in the bottom of the cup, and you tip it up and it still stays in the bottom of the cup. If you move it around too violently, it'll all splash out and make a big mess. So we end up having to drink our beverages through a straw from a bag. Makes you feel like you're a big insect sucking the juices from another insect. I wanted to see if I could figure out a way to have an open container cup in a weightless environment, which would allow you to drink your tea and your coffee in a manner that's commensurate with how people drink their beverages on Earth. Taking some of my surface chemistry that I learned in college, I devised a cup with a special shape. The cross-section looks kind of like an airplane wing, where it has a cusp, and the cusp will allow channel flow, so the liquid from the bottom of the cup will float up and just park itself right next to the rim, and then you can drink it. And it allows a crew to share a communal beverage. You could share tea. Maybe you just come in from doing a spacewalk or something and you want to celebrate a little bit. If you have a real cup, an open container, it's so ingrained in human beings, it's so ingrained in culture, it adds back the dimension of what it's like to be a human being in a civilized way.
Okay, flames and fluids are acting a little differently. But that's not all. Take a look at how microgravity affects colloids, magnetic fluids, and smart materials.
If you have a smartphone, take it out and run your fingers along the glass surface. It's cool to the touch, incredibly thin and strong, and almost impervious to scratching. You're now in contact with a smart material. Smart materials don't occur naturally. Instead, they're designed by engineers working at the molecular level to produce substances made to order for futuristic applications. The Corning Gorilla Glass that overlays the displays of many smartphones is a great example. It gets its toughness in part from fat potassium ions stuffed into the empty spaces between old-fashioned glass molecules. When the molten glass cools during manufacturing, dense packed molecules solidify into a transparent armor that gives Gorilla Glass its extraordinary properties. Around the world, designers are working on other smart materials, such as alloys that can change shape on demand, plastics that heal themselves when ruptured, and fluids that obey magnetic commands to flow or stiffen under computer control. One of the greatest challenges in creating a smart material is arranging the molecules. They're so small. We want to create a new class of materials beyond smart. We need genius materials, materials that arrange themselves. The research to accomplish this is already underway on the International Space Station. Dr. First is the principal investigator of an experiment called InSpace 3. In the microgravity of Earth orbit, Vials of fluid mixed with very small colloidal particles, about 1/millionth of a meter in diameter, are exposed to magnetic fields. Magnetism can be switched on and off again very rapidly. This jostles the particles, causing them to bump together and self-assemble into microscopic structures. These structures can be very difficult to predict, even using cutting-edge models running on supercomputers. Astronauts enjoy watching this process in action through microscopes. Because the samples are backlit by a green lamp, they sometimes call it the green blob experiment. FIRST recently won an award from the American Astronautical Society for his work on InSpace 3. Just by toggling a magnetic field, we're learning how to take many kinds of microscopic building blocks and get them to spontaneously form interesting structures. Recently, observers have seen the colloidal particles forming long fibrous chains. FIRST speculates that these could lead to materials that conduct heat or electricity in only one direction. The experiment has also yielded crystalline structures that the team is just beginning to investigate. The fluids underlying these tests are themselves very smart. They're called magnetorheological, or MR fluids, because they harden or change shape when they feel a magnetic field. If you own a sports or luxury car, you might have MR fluids in your shock absorbers. The stiffness of magnetic shocks can be electronically adjusted thousands of times per second, providing a remarkably smooth ride. Similar but more powerful devices have been installed at Japan's National Museum of Emerging Science and China's Dongting Lake Bridge. They're there to counteract vibrations caused by earthquakes and gusts of wind. Some researchers have speculated that MR fluids might one day flow through the actuators and hydraulic dampers of robots, moving artificial joints and limbs in lifelike fashion. Scientists and researchers are using these fluids as a laboratory for studying self-assembly. MR fluids are, by definition, responsive to the magnetic nudging that sets self-assembly in motion. Furthermore, in space, the particles don't sediment out due to gravity. We can study the full 3D evolution of the material. Varying the shape of the colloidal particles, the cadence of magnetic toggling, the temperature of the fluid, and other factors will allow researchers and astronauts to further explore the frontiers of self-assembly. Touch the surface of your smartphone again. That's just the beginning.
As you can see, our International Space Station is an unprecedented research platform in space, allowing researchers and scientists to conduct experiments that can't be done anywhere else. This work off the Earth will lead to a better understanding of the fundamentals of combustion, surface tension, and colloids in the absence of gravity, benefiting us by helping us to make more efficient combustion engines, better portable medical diagnostics, stronger, lighter alloys, medicines with a longer shelf life, and buildings that are more resistant to earthquakes. Research on the International Space Station continues to improve life here on the Earth. Be sure to stay in touch and follow us on Facebook and Twitter for the latest research news, and don't forget to download our app on your mobile device. Until next time, we're working off the Earth for the Earth.
Hi everybody, I'm Bill Nelson, and it's the National Intern Day. Thank you for all your hard work as a NASA intern. And this summer we are lucky to have 2,000 interns helping to advance NASA goals and missions in every state in the United States and Puerto Rico. And I can't wait until we have all the NASA interns back at our centers in person But the virtual internships have enabled NASA and other agencies to make opportunities available to more students that otherwise would not have been there. And it ensures for us to continue to get the best of the best. NASA is working to solve some of the biggest challenges facing our country: climate change, American leadership in space, to name two. And the way we're going to do it is by working together, bringing people together, listening instead of just talking. And we'll do it by making sure that our NASA family is made up of folks with diverse backgrounds and fresh perspectives. And so thank you for all your hard work and your innovative ideas. You're the future of our country. And we hope to equip you with the tools and the knowledge to begin your careers. So many of our leaders at NASA got their start as interns. An example, the STEM education lead, Mike Kincaid, our head of human spaceflight, Kathy Leaders. And I can't wait to see what the future holds for you. And I look forward to your continued success. Thank you for being a NASA intern.
Hi, everyone, and happy National Intern Day. I'm NASA Deputy Administrator Pam Melroy, and I want to give you a warm welcome and a thank you to all the interns working across the country to help advance NASA's goals. NASA takes on the hardest technology problems to accomplish the boldest and most inspiring missions, pushing the limits of what we know to be possible. That's why we're so appreciative that you're here and contributing. For NASA to be successful, we need a diverse and incredibly dedicated workforce to put their heads together to solve the most difficult problems facing our nation. You'll meet many amazing people in the course of your internship who will help you learn and grow. I'm reminded of the inspiration I drew from my heroes and mentors to ultimately pursue a career to become an astronaut. Some of those early internship opportunities in my career were my most formative, and I hope that we can provide an experience that is as impactful for you all here at NASA and across the federal government. While NASA and the federal government is committed to providing opportunities for students to gain valuable experience, your contributions have been invaluable as well, to get your insight, to get new ideas, and to foster relationships you'll carry for the rest of your lives. Your generation, the Artemis generation, gives me hope for the future, knowing one day this will be in your hands, and perhaps one of you will be the first person to set foot on Mars. The journey starts here. I know it can be overwhelming sometimes, but I encourage you to persevere and to seize future opportunities, not just to further your own career, but also to create a better world for the generations to come. So thank you, and I can't wait to see all that you will accomplish.
Hello, everyone. I'm Mike Kincaid. I'm the Associate Administrator for NASA's Office of STEM Engagement. But 34 years ago, I was an intern just like you, just starting at the Johnson Space Center. And in those 34 years since I started as an intern, wow, we have done some amazing things as an agency, whether that's landing rovers on Mars or spending 20 years of continuous human presence on board the International Space Station. It's exciting. Imagine 34 years from now, it's the year 2055, and perhaps you'll be standing on the surface of the Martian planet talking to interns just like you across the country. You know, behind every NASA mission, there's people making it possible, including interns like you. Here's a few words from some of our past and present former NASA interns.
Hello, my name is Katia Chacereta.
I'm Lisa Stewart.
My name is David McBride.
Hi, my name is Sarah Adenomi.
I'm Yana Sharon Benzivat.
Hi, I'm Mike Kincaid.
Hola, I'm Dr. Jade Salona Cruz.
I'm NASA astronaut Jessica Watkins.
I'm Brad Neal.
Hi everyone, my name is Paris Garrett and I am a current 2021 computer vision intern at NASA Langley Research Center located in Hampton, Virginia.
I interned at NASA headquarters,
Ames Dryden Flight Research Facility.
I was a 4-time NASA intern at a few different NASA centers.
I interned at Johnson Space Center in the Goddard Space Flight Research Center,
Ames Research Center,
NASA Jet Propulsion Lab,
for the Dryden Flight Research Center in 1982.
I had the privilege of participating in NASA internships both as an undergraduate student as well as a graduate student. Today, I'm a support scientist at the NASA Earth Science Data System Program.
The Senior Technical Advisor for Airworthiness and Flight Safety.
I'm the Executive Officer in NASA's Office of STEM Engagement at NASA headquarters.
Today, I am the Center Director for the Armstrong Flight Research Center.
I am currently working at NASA's Goddard Space Flight Center in project management and in cybersecurity.
I'm the Associate Administrator for the Office of STEM Engagement.
Today, I am still a Pathways intern with Johnson Space Center, where I'm working on developing the ascent abort model for CST-100.
Something I took away from my internship is that people really wanted to help me learn. They wanted to help me understand what was going on at the agency, and they were great at answering questions.
Learning the interpersonal skills that it takes to work in an office environment.
First off, NASA is a really exciting place to work. There are lots of opportunities and lots of different projects and work to be done.
We were working on real things. That was one of the coolest things to me as a student.
Learning to be tenacious, like ridiculously tenacious.
This euphoric feeling and rush of adrenaline that comes from being able to combine my skills and my passions to do things that I didn't think I was capable of.
And to see that the big things that NASA accomplishes really are a collection of small things from many, many contributors, and that me as an intern and a young engineer could make a big difference working as part of that team.
I would say that my NASA internships were really what laid the groundwork, laid the foundation for me to continue to explore in STEM and pursue this career.
So my advice to any of you that are thinking about applying for a NASA internship is, first and foremost, apply.
Go for it.
Do it. Just do it.
My biggest advice is just do it.
Just do it. Go for it.
Nothing is impossible, it is only a challenge. So don't be afraid to apply and believe in yourself.
You give it all and you pursue it, you will be where you want to be. So always believe in yourself.
Thanks for all you do. We're so excited to celebrate National Intern Day with you, and we look forward to hearing from you guys as you ask questions and we hear from our International Space Station astronauts. Our astronauts are standing by, and the downlink will start soon.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. We are ready for the event.
Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
Houston ACR, this is Station. We hear you loud and clear.
Please stand by for opening remarks.
Hello, welcome to today's event featuring interns across the United States federal agencies and astronauts aboard the International Space Station in observance of National Intern Day. My name is Laura Paulino and I am a NASA intern. Artemis Generation. As the architects of the future, it takes all of us to explore the extraordinary. We're counting on you to innovate, inspire, and serve for the betterment of humankind. To spark your interest, here's what interns from federal agencies have to ask.
Hi, my name is Alyssa Huey and I'm from USGS. My question is, one of the USGS mission areas is natural hazards. Given your unique perspective on the Earth from the space station, have you observed any natural hazards during Expedition 65, such as forest fires, volcanic eruptions, coastal changes, drought, etc.?
Thanks for that fantastic question. Yes, we get the opportunity to see a lot of things from space that everybody else doesn't get the vantage point we have. I have seen, in fact, just this last Friday, I was surprised to see how many fires were over Montana. I've also seen on this flight volcanic eruption in Central America, and I got a picture of Mount Kilimanjaro recently over a very much longer-term situation, and it didn't have as much snow on top of it as I expected to see.
Hi, my name is Clara Chang and I'm from NOAA. My question is, since you work closely with people from all over the world, what advice do you have to transcend obstacles and differences in training, language, and culture as you conduct research?
That's a great question. You know, Mark's from the U.S., I'm from Japan. We got Thomas Pesquet from France, and we got Oleg and Pyotr from Russia. So even on board, we're from 4 different countries. And on the ground, we have so many people working for the space station program from many, many different countries. And it's kind of rewarding for me to get to know these people and get to know all the cultures. And I think it's great to respect each other's ideas and thoughts and work together towards a common goal. And that makes things, happen. And it's amazing to be in that team.
Hi, my name is Kelvin, and I'm from the Army Educational Outreach Program. My question is, what have you learned about cooperation and culture while being on the International Space Station, where you're living in a microcosm of the diverse world?
What I've learned is that you've got to be able to talk about issues as they come up. You don't want to let anything this works in all relationships. If there's something that's bothering you, you need to find a way, whatever way works best for you and the other people you're dealing with, to communicate that in a way that doesn't put them on the defensive, and where you're able to communicate that before you are really angry about it, where it's just a minor issue. So don't let things build up.
Hi, my name is Matthew Stang, and I'm from NASA. As we celebrate all interns tomorrow on National Intern Day, what impact do you see interns having across the federal agency? Thank you.
You know, we've been with the agency for a long time. I won't say how many years, but so we know, how like NASA or JAXA, the Japanese Space Agency, works and how to promote and work in this program. But you interns, all the interns are fairly new. You have new ideas, new thoughts, and different perspective. So we really appreciate those new ideas and new perspective, because you can see things differently, and we might be taking things for granted. And you might say, why are we doing it this way? And that would make us think, maybe we should rethink, and that would make things improve. So please bring it on.
Hi, my name is Hayden Morgan from AFRL. My question is, people often look up to astronauts as role models as they demonstrate the magnificent achievements we can obtain. As an astronaut, who do you look up to as a role model?
Quite honestly, the person I look up to the most as a role model is my dad. I regret to say I don't think I've been as good a dad as my dad was to me. He is one of the most kind, level-headed people. He's very, very other-centered. I just can't say enough positive about the guy. I think the strongest reaction I would get out of him if he felt really angry was he would blink his eyes really quickly, and then he knew that he was puzzled by that strange behavior. That was about as bad as it got.
Hi, my name is Anthony Pedraza. I attended Texas Tech University, and I am an intern with the Forest Service. My question is, what type of role does NASA see itself in for the preservation of our planet, and how do the resources in space factor in that thought process? Thank you.
Thank you. Up on International Space Station and also all the satellites, Earth observation satellites, we're at a very unique location, position, altitude at this vantage point to see what's going on Earth. And then also going over, in a certain interval and looking through the changes. So all that data combined, I think we can see the changes over the years. And researchers and people like you can help us protect the environment and think about how to do that. And what we're seeing should provide that information for you.
My name is Austin Tran, and I'm from the U.S. Naval Research Laboratory. My question is, how do you determine when you go to sleep in space, and do you take shifts with other astronauts?
So I'm happy to say, unlike what the Navy has to do sometimes, is we don't have to hot bunk up here. I have my own bed. No one else gets to use it. But we did have to define a time period that is determined to be nighttime for us because we could pick any time, and what we've chosen is Greenwich Mean Time. So we typically, after our latest evening meeting, we will sometimes turn the lights to a dimmer color to help our bodies recognize that it's getting closer to the evening, and then we just go to bed around 9:30 or 10 Greenwich Mean Time.
Hi, my name is Mei Feng, and I'm from NOAA. My question is, when I conduct research on the water, weather is the ruling factor as to the success of my day. In space, what weather elements are most dangerous to an astronaut conducting a spacewalk?
That's a very good question. So we don't have, storms like on the ground. We don't have, lightning, but we do have radiation. And when the solar wind is strong, we can detect that. And so we plan ahead so that we try to avoid that as much as possible. Now, sometimes you do have to go out the door, but we try to time it just right so the radiation hit is less than what the maximum would be.
Hi, my name is Carrie, and I'm from the USGS Office of Youth and Education and Science. And my question is, humans will walk on the surface of Mars within my lifetime. What engineering and geoscience skills do you think will be most important for them to understand?
I think that one of the biggest challenges of being on the surface of Mars is that we're going to stay on the surface of Mars for long periods of time just because of the nature of orbital mechanics and literally getting the planets to align again. So you've got to be really good at maintaining your habitat. That's going to be a primary.
Station, this is Houston ACR. We're back with you on the other side of an LOS. Repeating the end of Carrie's question, humans will walk on the surface of Mars within my lifetime. What engineering and geoscience skills do you think will be the most important for them to understand?
I think that being on the surface of Mars, because of orbital mechanics and the vast distances involved, we will be putting people on that surface for a long period of time. So the primary skills are going to be understanding how to maintain the environmental control and life support system, how to maintain the habitat. And unlike that up here, where we're maintaining a habitat in space, on the surface of Mars, because you're dealing with soils and things like that, when you do a spacewalk there, you're going to have to make sure you can keep things clean on the way back. So I think those are going to be very important skills to have on Mars.
Hello, my name is Rasha, and I'm from NASA. And my question is, out of all the experiments being done on this mission, which results are you most curious and most looking forward to?
Wow. We, during our daily work, I guess we do maybe participate in maybe 2 to 5 science experiments a day. And so we have a lot. But one thing that I got interested was having water bear up here. And apparently, they stay here for a couple of generations before they go back. So the researchers can take a look at them when they go back. So that's something that I'm looking forward to seeing the results on.
Hi, I'm David Gonzalez, and I'm currently working on methods to provide better thermal support
to divers in cold waters at NSWC, Panama City. I've read that astronaut suits require both heating and cooling garments, and my question is, how does a astronaut maintain thermal regulation during a spacewalk in dynamic temperatures? Thank you.
So our spacesuits do such a fantastic job of insulating us from the outside environment that what we really have to do is reject the heat that our bodies generate, because the body heat will not translate through that spacesuit. So we've got a liquid cooling and ventilation garment that allows fluid water to travel through the hosing around our body, and then it will pass by an ice pack. Now, me personally, on a spacewalk, I have too many other things to worry about, so I basically sweat in the sunshine and I'm a little chilly in the cold, but I do have the ability to adjust that if I wanted to. It just takes effort, and I'd rather focus on the other things that are occupying my attention.
Hi, my name is Kai Stargel, and I'm from the Air Force Research Laboratory, and my question is, as an astronaut on the space station, part of your job is often as a research scientist. Do you get paired with science projects that align with your background, or are you expected to adapt and learn to maintain new science projects?
Oh, that's a great question. Mark's from the Army, and my background is engineering. So science is something alien to me.
One of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather.
Welcome to NASA Edge.
An inside and outside look at all things NASA.
I tell you what, Blair, we have a great and exciting show today. We're talking about navigation Doppler LiDAR.
And joining us later on the show is our good friend Franklin, who's been busy shooting footage of the test being done with NDL.
But first up, we have my former boss. So we have to make sure we're in good standings. Yes. We have Walt England, who is now the Deputy Associate Administrator for Programs in the Space Technology Mission Directorate. How you doing, Walt?
I'm doing great, Chris. Good to be back.
Now, in case for some of the people who don't know, we have this really cool new program at NASA called Artemis. Can you kind of share what that's all about?
Yeah, we're really excited about Artemis. Artemis is the program that's going to take us back to the moon, the first woman and the next American man to set foot on the moon in 2024. We've been investing in capabilities, the SLS rocket, the Orion spacecraft, standing up the Gateway, which will truly be the gateway to the moon and points beyond. And the next step is to develop the human landing system, which will take astronauts down to the surface of the moon. And part of that landing system requires technologies to include precision landing and navigation Doppler LiDAR.
So being in the Space Technology Mission Director, what are some of the suites of technologies that you're working on?
Well, we're developing in a whole host of technologies, both robotic technologies for robotic landers and for the human landers that will follow. Solar electric power, nuclear power systems, cryogenic fluid management, precision landing and hazard avoidance technologies, which will enable the human landing systems to get to very precise locations where we're aggregating assets, both robotic and for human exploration.
How challenging is it to develop not only the new technology or develop the landers themselves, but concurrently test all these new technologies that have to work in a complementary fashion with Artemis?
That's a great question. And we're doing that with a very deliberate plan. We're using both robotic systems, small robotic landers, medium-class robotic landers, and eventually the big full-scale human landers. And we need to do those in parallel so that by 2024, all the technologies, all the capabilities will be available and ready to fly astronauts to the surface of the moon.
EDL, entry, descent, and landing, has always been an integral part, I mean, an important part of discovering another world or learning more about other worlds. Is that just as important as landing on the lunar surface? Because it really doesn't have an atmosphere compared to the Martian surface?
Well, the Martian surface is actually harder to get to because it does have an atmosphere, right. But we are using the moon as a proving ground, essentially. The Doppler LiDAR, the precision landing technologies that we need to get astronauts to the surface of Mars, which is the end game. We want to demonstrate on the moon and then understand how they perform and what we need to do to extend those to the Mars surface.
And so that means, for example, when this technology matures as it's actually deployed, it'll probably fly on missions prior to that, and we'll see test data and verify all that functionality even ahead of the astronauts arriving.
Absolutely. There are things we can do with Doppler LiDAR on the ground here on Earth to develop it and prove its capabilities, and we are doing that as we speak. We can do it on the ground or with aircraft or suborbital launch vehicles. We're going to fly the Doppler LiDAR on a Blue Origin New Shepard next year, and then we're going to take the Doppler LiDAR on 2 small robotic landers and demonstrate it at the moon in a fully autonomous sense before we put it on the system that's going to carry the astronauts down to the surface.
I understand there's a project called SPLICE, and that's where you have the hazard avoidance, the navigation Doppler LiDAR, and all the sensors that are part of this program?
Right. SPLICE has a number of different precision landing technologies, including terrain relative navigation, which we actually use on Earth here, but you use cameras to define waypoints and understand visually where you are. We don't have a GPS network at the moon, so we need other ways of navigating down to the surface. We've got a hazard detection capability, so when you get close to the surface, you want to be able to look and see where the rocks and slopes and even craters are and avoid those. You may remember Neil Armstrong and Apollo 11. He was literally within about 30 seconds of running out of fuel because they flew over a big crater and he didn't want to set the lander down in the crater. So we want to do that. We want to be able to do that autonomously with the hazard avoidance technologies, and then obviously the Doppler LiDAR. And the Doppler LiDAR is really about precision guidance, velocimetry, and position. So with radar systems, we get position, and you have to derive the velocity and rates of the spacecraft. But the Doppler LiDAR gives us a much more precise laser-based capability to pinpoint the landing site and understand your velocity and rates and your position as you get near the surface. And I'll tell you, the beauty of the NDL technology is it has tremendous potential for Earth applications as well. So we're developing it for this very specific spacecraft, human landing system, but it has applications here on Earth, potentially to drive autonomous cars with aircraft, marine applications. It has a really broad-based spin-off capability that people are looking at very seriously.
Now, I know that doesn't drive what we do, but that's got to be really a good feeling, especially on the engineering and science standpoint, to make these breakthroughs meet your objectives, but then at the same time actually open up opportunity for a whole host of different applications.
And that's actually always been part of NASA's mission, not necessarily explicitly, but if you look at all the spin-off technologies that we've developed that we use here in our daily lives at Earth. It's a tremendous investment, and this is probably one more in that long list of things that you'll see in in our daily lives.
Well, speaking of NDL, you had a chance to learn more about it.
Absolutely. I had a chance to sit down with Farzin, the principal investigator for Navigation Doppler LiDAR, and talk to him about the specifics of how it works. Farzin, Navigation Doppler LiDAR. When I hear the word Doppler, I think of like weather radar. How is that different for Navigation Doppler LiDAR?
Well, it actually uses the same principles that are used in weather radars. They call them Doppler, right? Because it uses the Doppler effect. And the Doppler effect is essentially when an object is moving, it causes a shift in the frequency or change in the frequency of the radiation. In our case, we have a laser radiation. And on the vehicle, when we're traveling, we are shining the laser beam to the ground. And as we are moving, it causes a Doppler shift. And from that, we can get the velocity of the vehicle. This sensor also uses the same laser beam to get the position or the distance to the ground. And by transmitting multiple beams, in our case, we do 3 beams, we can actually figure out what the direction the vehicle is traveling.
But of course, in this case, you're using LiDAR. So how does the NDL actually work?
Okay, the NDL in general provides position, speed, and direction of motion. These are the parameters you need for navigating. You use that when you drive your car, right? You use your GPS and your speedometer in the car. So it is the same type of things. Now, of course, when we go to other planets or we go to the moon, there are no GPS. So we have to have an onboard sensor to give us position and velocity information. And that's what this system does.
I understand that most of the time we do this using radar, but this offers some advantages.
That's true. You mentioned weather radars. The radars are also used on vehicles, space vehicles in particular, to measure the same type of parameters, position, velocity, your speed, and the direction you are traveling. However, laser provides significant advantage over radar. Being a much higher frequency means that it's more precise. The radar diverges, and the laser beams are pencil beams. That mitigates a lot of issues that inherent with radar system. So it's both precision and data quality that this provides.
And this makes a lot of sense with spacecraft, because as you said, we're going to be going to other moons, planets, types of surfaces that we're not already very familiar with. Was that part of the thinking when you started developing this technology?
Well, when we started, actually, the reason was that when we were talking to the engineers who are building these vehicles to go to Mars and other places, we hear a lot of complaints about the performance of the radars. So that triggers for us to start looking at alternatives, and using laser was an obvious choice. So that's how we got started. And so throughout this development, of course, we are working with those engineers in order to come up with the best optimum design that we could. And that's kind of the process that we went through.
When it comes to the moon and perhaps Mars, do you have to do anything different with the system to handle different atmospheres or anything, or is this a one-size-fits-all kind of system?
Well, as we are developing these for space, we try to envelope all the applications, so we don't have to make design changes from going from Moon to Mars. So we try to design it such that the same sensor system that can be used for both application or other places in the solar system.
So as we prepare with Artemis to go to the moon, where are you guys in the development timeline? I mean, do you have a working model? What's the status?
Yes, we are working on the working model right now. It's almost done. So the first engineering units are going to be demonstrated on 2 commercial landing missions in 2021. So throughout this, we are going to be keep improving it, making it more robust. So for the Artemis, we'll be hold out more reliable to ensure that the mission is successful.
And that's really interesting too, because by flying on these commercial missions, you're actually getting flight performance and actual real data to help iterate the system.
Absolutely. This is quite a luxury for us, because normally when NASA develops systems, they go through a bunch of tests, in the laboratories, doing vibrations, they put them in the vacuum, they run them over different temperature, they radiate them. You go through all of those, and you still have a little bit of a discomfort when you go to the space. Having this demonstration is extremely helpful to us as a developer, and it's also helpful to the engineers that they will have more confidence in these sensors. They will have all this data, they know exactly how it's going to perform. So it's a quite valuable experiment.
And joining us back now in the studio is Franklin Fitzgerald. And Franklin, you actually had a chance to spend time with Farzin and the team over the past several months shooting B-roll and covering a lot of the tests. Tell us about that experience.
Yeah, Chris, several months ago we got a call and they started talking about, hey, we're going to be putting this together, and we actually went over to the laboratory where they were assembling the NDL, the box that we keep talking about, the small suitcase box.
That's the engineering unit that they're building right now.
Absolutely. And after it was assembled, they said, hey, we're going to be putting together several more boxes. But the one that they completed, they started to do testing on it, like vacuum testing and thermal testing. And I documented that at some of the laboratories here at Langley. But the third test that they called me for was the test that they did at the Langley Air Force Base, where they used the lasers that we have here, models on our table, to shoot a target down the runway in the back of an open cargo van. Yeah, I know.
They improvise, right?
They improvise. But the van was so far away, I couldn't even see the cargo van with my naked eye, but when I looked through my telephoto lens of my camera, you could see it, and you could see what they call atmospheric turbulence, or what looks like heat coming off the surface.
Like a mirage.
Exactly. And Farzin told me that as the lander approaches the surface, you have atmospheric turbulence, but the lasers can work through that to get an accurate location and land like it's supposed to.
And with all these tests, Franklin, I mean, you guys would call them up and they seem to be working constantly on this project.
Man, it felt like it was around the clock. And in one test in particular, the vacuum test, I called Farzin. I say, Farzin, are you going to be available at 10 o'clock this morning? He said, I'll be available at 10 o'clock this morning, 10 o'clock tonight. You can come at 3 o'clock in the morning. We're going to be doing a round-the-clock test for the next couple of days in the vacuum chamber. So there were technicians working around the clock.
We know it's important because this NDL unit is going to be going on 2 CLPS landers, in a year or so. So they have to be ready. So they have to be working around the clock to get it ready.
Around the clock.
And I think that's interesting too, because a lot of times we hear about the technology, we see it demonstrated, and you forget about the actual hours that it takes by not just 1 and 2 people, but a whole team to get this testing done so it's ready to fly.
They haven't been working on NDL just for a couple of years. This has been a long process. I mean, they've been going back to the pre-2008 working on this. And I had a chance to sit down with Glenn Hines, who is the chief engineer for NDL, and he talked about that history. Hey, Glenn, thank you for being on the show today to talk about NDL. We've been trying to get you on the show for the past 13 plus years. Glad to have you.
Well, thank you so much for having me.
You know, Farzin did a great job talking about NDL. What I want to do is kind of look at the timeline. Let's take us back to the beginning. And to do that, I got a little cheat sheet here. Of course, I had to have on my little board here. Starting back, in 2008, when you started this project, tell us.
Yeah.
How did it get started?
So actually, the project started a little bit before 2008.
Okay.
Farzin's ideas and vision of this particular instrument. But our first helicopter flight of it was in 2008. And that was out in the desert. We worked that project with JPL. It was a huge system at the time. It was, like, say, the size of a refrigerator.
Okay.
And then we eventually flew it on the Erickson Sky Crane in 2010.
That's huge. That's a big box.
Yeah, and it was a very difficult environment to fly in. There was a lot of vibration on the Erickson Sky Crane. And it was still big. It was around 60 kilograms at the time, the size of about a half a refrigerator.
Okay.
But then we started miniaturizing it, and we built what we call our Gen 2 system, and dropped the weight down from 60 kilograms down to about 28 kilograms, and made it the size of a rack mount unit.
Okay.
We flew that on some helicopter tests and did some successful flights. And then eventually we flew that same box on the Morpheus vehicle in 2014.
Okay.
And we flew that at the Kennedy Space Flight Center. And it was working in closed loop at the time with the other systems on board. What that means is the vehicle took off by itself autonomously, picked out a safe spot to land, and found that, and then autonomously flew down to a hazard field that we had built down at the end of the runway, and the vehicle landed there all by itself.
So this was the first test of the system.
Yes.
In a sort of a simulated lunar landing environment.
Exactly. This was a progression of moving the instrument from being huge to being small enough to be able to fly to support these landing systems. And these tests proved out not only its capability, but it proved that we could also do the engineering to make it small enough to fit on vehicles. And we made it one more incremental step after the Morpheus flight. Okay. We made it into the size of a toaster. Effectively, that's what we called our Gen 3 unit. And we flew that on the Maston vehicle back in 2017. And that's leading us up to what we're building now, what we call the engineering test unit. We're going to make it robust and resilient enough to work in space.
So what would you say, if you take us back to 2008 and beyond, what was probably the biggest engineering challenge that you had to face during that time?
The biggest engineering challenge was the size of the box, getting it small. And the forcing function for that was the computing system. There's a lot of high-speed computing that goes inside the box to make this thing work. You've got lasers, you've got optics, you've got other components in there, but you need to get all the data processed in real time to get your answers out in real time so that the vehicle can react to it, can use the instrument data to fly. That normally takes a lot of computing power, and we were able to put that onto a board we built here at Langley, to fit inside the box and enable it to shrink. That is pretty much defining the footprint of the box now. So from an engineering perspective, that's probably been our biggest challenge. There are other subsystems in there that we've put a lot of time and effort into making them better, but that's the biggest one from a size perspective.
NASA, as an agency, we develop a lot of cool technology that we use in space, but then a lot of that technology can be used back here on Earth. How could NDL be possibly used in terrestrial applications?
Oh, that's an excellent question. There are a lot of different ways that it has usage right back here. One of them is for autonomous cars. You see that as a up-and-coming, emerging technology. A small version of NDL can be used to track the speed of vehicles very precisely. In theory, you can also track objects around the vehicle also, so you can use it to some degree for hazard avoidance for the vehicle there too. But giving it a very precise vehicle speed is of utmost importance to any autonomous vehicle. It needs to know precisely how fast it's going.
Let's kind of fast forward to next year. Where are you going to be when your NDL system is in the descent stage of those two landers, and they're about to land on the lunar surface, and NDL starts working, and it's working beautifully?
The state we'll be in is a state of happiness. That's the state we'll be in. We will be extremely excited, extremely elated that this has worked successfully.
Well, Glenn, thank you so much for taking the time out today to kind of give us the brief history of NDL and the technology. I'm hoping, I know you're gonna do a spot landing on the moon.
Yep.
And I know you're gonna do one on Mars one day.
Yep.
But what I want to see is I want to be able to drive in a car autonomously without driving, knowing that Glenn and Farzin and the team have an instrument on board that's getting me from A to B.
Yeah, excellent. I hope to see that day soon. All right.
Thank you, sir.
Thank you so much, Chris.
Thank you.
I'm very excited about the NDL technology for sure, but this autonomous driving stuff is awesome. And if these guys don't deliver, I'm going to call them personally, see if they'll set up a carpool with me, because I'm ready to avoid the traffic situation, get some productivity on the road.
Hey, one of the bigger challenges that they're dealing with is getting it down from that suitcase-sized box to even smaller to work inside of vehicles. The technology has already been transferred, and they're working on it actually close to here at Langley where we were.
Well, don't forget, Walt said at the beginning of the show, he talked about SPLICE, because remember, NDL is part of a bigger suite of instruments. So you imagine not only having NDL, but then you have the terrain relative navigation built in, and then you have the hazard avoidance and detection. One day you're going to be driving, and you get some type of obstacle in front of you, it's just going to drive around it, and you don't have to worry about touching the steering wheel.
Perfect.
Let it go on its own.
And it's interesting because that size reduction, they're talking about getting the basic box down to the size of a can of soda. So just think of, there's the lander for Artemis and things like that, but how many other landers that are going to be involved in space exploration that can use that same technology?
Now, we do have some of that same technology in our cars today. We have the side view, the lights that let you know that people are next to you. But that's using cameras. But this is more precise. This is better technology, and hopefully that will be incorporated in other things besides cars and jets and things like that.
Absolutely, absolutely. Now, Chris, what do you think about the long-term prospects? We've seen a technology like this, and it's being developed and deployed. What's the future look like using this technology?
Yeah, I can't wait till we have those 2 CLPS missions where the NDL will be flying on the landers. Hopefully we'll get successful data, and eventually if we send humans in 2024, they'll be on the human landers. And then eventually as we get onto Mars, this will be a staple for all the technology and all the landers that will be sent out.
So right now we're doing a show on technology that'll be part of that first return to the moon that we'll have in 2024, and then eventually landing on Mars.
Where are you guys going to be in 2024?
You know what? I'll probably be at the Kennedy Space Center. doing some programming, doing some live shows with you and you probably. And
Hopefully.
Hopefully, yeah.
That's right.
Yeah, and I think we're just going to get those goosebumps that we had for the many milestones that we've witnessed over the years here at NASA. You know, I was alive when man stepped on the moon, but I was very, very young, so I didn't remember it like I remember the shuttle mission. So this is going to be very interesting, and I'm looking forward to it.
You know the difference is going to be?
What's that?
For 2024, he'll have his AARP card.
You know what? That is absolutely right.
But you know, look, it won't matter. What's really interesting is all this technology that we see in development now is going to be riding on the lander, on our part of Artemis.
That's right.
Taking the first major step in this process, and we're all going to get to witness it. That is one of the most exciting things that I can think of in terms of NASA in a long, long time, and I'm excited about it, so I really don't care where I'll be.
And knowing this technology right here is a part of Artemis. So,
Artemis. Artemis of Artemis.
Artemis of Artemis.
You're watching NASA Edge.
An inside and outside look
at all things NASA.
By the time the Hubble Space Telescope was nearing its 10th anniversary in space, it had already become the gold standard for modern-day astronomy. Hubble had grown into an indispensable tool used by scientists all around the globe to take an inside look into the universe around us. Everything was great, flawless even, until something unexpected started to creep its way into the picture.
In the last month, namely in November 13th, the fourth of 6 gyros that are on board Hubble failed, and that left only 2 operational gyros.
Lights out. Hubble's gyros, which are needed to accurately point the telescope, were failing. What was NASA supposed to do? Cue Servicing Mission 3A.
And on Christmas, Discovery Houston, go inside the cockpit. Next to you.
I'm proposing no change, and then you tell us you go up there. Okay.
By 1999, Hubble was about to make its mark in the 21st century.
Discovery, go for Hubble release.
And as that turn of the century neared, Hubble was also due for another servicing mission.
I mean, you can just take it in, KT.
Just like the previous 2 missions to Hubble, Servicing Mission 3, planned for the year 2000, was going to upgrade and refurbish the telescope.
Hey, Store, what do you think about you putting your tether on?
However, without warning, Hubble's gyroscopes began to fail over a year before Servicing Mission astronauts were scheduled to launch.
The gyros, of course, are required for the science mission. They're required for the extremely accurate pointing. We've homed in onto a wire there that is broken, and we think that is the reason why the gyros have failed.
So, Hubble needed 3 gyroscopes to continue to do science, and by April 20th, 1999, that's all Hubble had. Swiftly, NASA declared a Hubble emergency and split the upcoming servicing mission into 2 parts. Servicing Mission 3A would mainly tackle the gyroscope failures, and Servicing Mission 3B would encompass the rest of the maintenance that Hubble didn't need right away. It was now crunch time. Not only did NASA have to prepare an extra shuttle mission, but the astronauts now had to go into overdrive to prepare for the upcoming mission, now scheduled for October. And then, when everything seemed to be more under control, news broke. The 4th gyro failed.
Today, it's sitting up there with its self in safe mode. And that again shows how important the serviceability is to this facility.
Hubble was now in safe mode, which meant that the telescope's eyes were temporarily closed to science. The servicing mission was more critical than ever before. And after multiple maintenance and wiring checks delayed the shuttle launch, on December 19th, 1999, the team of Servicing Mission 3A was finally able to make their mark on history.
And liftoff of the Space Shuttle Discovery on a mission to repair the Hubble Space Telescope as we venture into the 21st century.
Houston Discovery, roll program.
Roger, roll, Discovery.
Houston is now controlling. The roll maneuver is complete. Discovery is now in a heads down position, on course for a 28.5 degree, 310 nautical mile orbit.
Right away, the team of 7 astronauts went to work. This 8-day mission included 3 spacewalks to Hubble. The first of which replaced all of the gyroscopes. Now Hubble was able to be accurately positioned and stay locked on to its celestial targets. Not only that, the team behind Servicing Mission 3A refurbished Hubble's Fine Guidance Sensor for even greater precision in pointing the telescope, fixed damaged thermal blankets that protect the electronics housed inside of Hubble, installed a new computer 20 times faster than Hubble's original computer, replaced old tape recorders with a new solid-state recorder for greater efficiency in Hubble's data management, and fixed the spacecraft's S-band transmitter to continue to relay data to the scientists on the ground. And on Christmas Day, 1999, Hubble was released back into the stars, ready to uncover new discoveries that lie ahead. Servicing Mission 3A proved that NASA could not only be quick on its feet in dire circumstances, but perform as a team that is united around keeping our eyes open to the universe for many years to come.
Get an inside look at NASA Glenn Research Center. From wind tunnels to drop towers and vacuum chambers, our virtual tours offer you a 360-degree view behind the scenes of our world-class facilities and labs. It's where we simulate aircraft flight conditions on Earth and the harshest conditions found in our solar system. Tap or click the arrows or use the menu on the left to navigate to each area within the facility. Tap or click the icons within the tour to view videos, images, and see testing in action. So go ahead, explore NASA Glenn, and learn how we develop and test innovative technology for aeronautics and spaceflight.
NASA, the agency that landed on the moon, launched the Hubble Space Telescope, and took the first rover selfie? Yeah, that NASA. We also chase fires. This team is in the middle of a recovery operation. The California Department of Forestry and Fire Protection is using NASA satellite data to map the path of destruction after the 2018 Camp Fire.
NASA has the tallest fire towers, with our satellites looking down from space, catching images every day and every night. We're often the first to detect and then share information about fires, especially fires that are burning in remote locations.
That's where we can come in and provide a much better picture. And so I have NASA MODIS and VIIRS stuff, which we always use on Google Earth. You can kind of see the streets here. This is a neighborhood totally burned down.
A NASA Rapid Response grant allowed the team to study the impact of the Camp Fire just 4 months after it was contained. NASA provides crucial tools for both first responders and fire recovery managers, but there are even bigger implications for understanding the future of fire.
The information we collect from satellites helps us understand not just where and when fires are burning, but what kind of changes they're making to the ecosystems on the ground and our atmosphere up above. I'm Doug Morton, and I'm an Earth System Scientist here at NASA's Goddard Space Flight Center.
Doug is one of NASA's go-to scientists when it comes to making sense of how fires affect people and ecosystems.
You need 3 things to make a fire. You need something to burn. You need climate conditions that allow that fire to start and grow large. And you need a source of ignition. Today, the source of ignition is almost always humans. we can use information about rainfall and climate to anticipate landscapes that might become flammable in the future. That kind of predictive power, how we harness our understanding of the Earth system, has really helped us move forward in terms of anticipating and minimizing the risk to landscapes that might be flammable next week or even next season.
But the real work of science may be something that many people don't have a lot of visibility into. When we talk about taking a team of scientists and putting them into the field, that could mean weeks, months, or even years of collecting data.
The first time I spent in the Amazon was in the early parts of the 2000s, just at the peak of deforestation rates in Brazil. And I don't think anyone could make it to the end of that frontier landscape, standing at the edge of a road and looking in all directions and seeing towering columns of black smoke and not feel like there was an opportunity to be careful with our planet. Fires have been burning across the southern Amazon, an area where I've been working for the last 20 years. And so people have looked to me to explain, is this normal? One of the things I can do as a NASA scientist is I can go back in time. Our data record allows us to literally compare activities that are happening every day with these same days and the same kinds of conditions in previous years. From space, we're mapping fires across the entire planet, and that often takes us to remote locations. And the best way to partner and understand those remote locations is with people who live and work in those communities.
So that's what we did. This year, NASA is sending a blitz of missions into the field, and you're coming with us. Climate change is shepherding in a new era of fires that burn hotter and longer. And our pilots, our partners, our scientists and engineers, they've come prepared to meet that challenge.
Some of my days have been 14, 16, and 18 hours.
We don't hesitate to meet challenging conditions. You know, you can tolerate a lot for a day or two.
This mobile laboratory has been deployed for a very specific reason. The Shady Fire is burning nearby, and this team is gathering data that you can only get at night. Over the next several weeks, NASA and NOAA are teaming up in the field to study smoke from wildfires and agricultural burning. Here's what 24 hours looks like in the life of these fire chasers. The team's been keeping a close eye on the Shady Fire, burning just 4 hours northeast of the base of operations. After several days of watching the fire grow, the forecasting team decides to deploy the mobile laboratory and the NASA and NOAA planes. The ground crew and pilots are already preparing the plane by the time the forecasters give their daily briefing.
The more we learn about smoke, the better we'll understand health. My name is Amber Soya, and my role here is to determine what fires we should target. Smoke is related to respiratory illnesses, heart attacks, and even death.
For some of our scientists, understanding pollution has defined the course of their life's work.
I'm a physical chemist, but I'm also from what 60 Minutes called the most polluted city in America, Anniston, Alabama. When the opportunity came along to do this type of work, I really resonated with it.
Dr. Bruce Anderson is the Langley Aerosol Research Group lead and a seasoned veteran when it comes to doing field work in remote places. By 3 p.m., the NASA DC-8 and the mobile laboratory are about ready to go. Bruce and his team begin with a 5-hour drive to reach the fire. We'll catch up with them later. While the ground crew, pilots, and safety techs prepare for what will likely be 6 hours of flying through smoke plume after smoke plume, the scientists ready their instruments to capture data from the notorious Shady Fire. 30 minutes into the flight and the team has already reached the fire. Here's where the work begins. These flights are rare opportunities for scientists, so not a moment is wasted.
I think that studying fire and chemistry, it only comes together when you have a diverse team of scientists.
As the sun starts to set, the plume is harder for the pilots to see, and around 10 p.m., the plane heads home after a successful flight. Smoke sinks lower to the ground at night, and sometimes accumulates in valleys, which is exactly where Bruce and his team are waiting for it.
We'll set out, drive up there, find a place to position the van, then start cranking up instruments. It takes about a half an hour to an hour to get everything running and calibrated. It's a guaranteed bad night's sleep, but you know, you can tolerate a lot for a day or two.
This team of 5 scientists will be up almost every half hour checking measurements, replacing filters, and at one point repositioning the van to capture emissions more effectively. It's a long, cold night, but eventually it's dawn, and time to head back to town. By 7:30, the forecasters have already been awake for at least 2 hours selecting which fires the science team should target that day, including a scheduled return to the Shady Fire. In about 2 hours, the plane will be bustling with scientists preparing their instruments for the day's flight. And the whole cycle will start all over again.
I feel like the work that I do, the knowledge that I'm trying to pull together is important for the human race, you know, for our country.
This seems like an unlikely place for fires. In the winter, the landscape is still, but the warmer months can bring conditions that, combined with fire, can release dangerous amounts of carbon into the atmosphere, and in more ways than one.
What happens in the Arctic does not stay in the Arctic anymore.
I see that you're wearing a hat with a logo on it. Can you describe what that is? You don't have to take your hat off.
Well, that's good.
Kevin, in the orange jacket, is a close NASA collaborator. He and his team are used to getting their hands dirty to collect crucial fire data.
I'm wearing a hat right now from the Above Field campaign, and what you see is a big A, and it stands for, you know, the trees tilting over with thawing permafrost.
Trees aren't the only thing getting warped by thawing permafrost. Buildings and even roads begin to buckle when the ground beneath them literally begins to liquefy. NASA's Above campaign is currently in the Northwest Territories to understand large-scale changes to permafrost.
Permafrost is basically, you know, picture in your mind frozen dirt. Now, if you thaw the permafrost out, it changes from solid like rock or concrete to mud.
If you watched season 1 of NASA Explorers, then you know that permafrost stores huge amounts of carbon. As a matter of fact, twice as much as what's currently in the atmosphere today. Now, thankfully, permafrost thaws really slowly, and therefore releases carbon really slowly. But here's where it gets complicated.
Fires in the high northern latitudes, permafrost regions, are getting larger, they're getting more frequent, getting more intense.
In the past, permafrost has had a reliable layer of insulation, mostly moss.
But if you have a fire, it burns off the vegetation. The insulation is essentially removed.
To summarize, changing climate means more fires, more thawing, more carbon in the atmosphere, and that accelerates warming. Permafrost is one of those important factors that affects life on Earth, yet it isn't really in the public eye, unless you live on it. But for Kevin, understanding this phenomenon is the best way to make the biggest difference.
So way back in the 80s when I was in college, my mom got cancer and was dying. And I remember the last time I saw her, we were sitting down and she was in bed very sick. and she asked me what did I want to do. And until then, of course, I was a typical teenager in college. I had no clue. But then it crystallized in my mind that I wanted to save the planet, and that was the words that I used. And so I decided that my path for doing that was to go into spaceflight, save the planet by leaving it, I suppose. But then, circumstances changed, and then I started working on Earth observation. And it opened my eyes to what you can do with remote sensing and satellites, and what you could see and learn about the Earth from looking at it from space. And so I decided to go back to school, and I rethought of what I talked to my mom about, and I decided to go back to school, and I had become a scientist.
The hours are long and the work is hard, but these explorers wouldn't have it any other way.
This is really, tough country. You're really rugged, but it's also a very beautiful country. I think I can speak for nearly every scientist that I've worked with. They do this because they want to help. They want to provide the information and tools to solve problems.
NASA is a big and capable organization, but Earth science is a subject far too big for one country, one agency to tackle all by itself.
After nearly a decade of planning, this field campaign happened to be here just as an unusually dry season led to some of the most intense and large fires the region had experienced in the last 5 years.
We came here to look at the transport of smoke and what smoke does in the environment, particularly as it impacts clouds. And we had an amazingly intense smoke event that carried very high concentrations of smoke into a place called the Sulu Sea.
You might be surprised to learn that fires affect cloud formation, and NASA is studying that dynamic relationship.
NASA is a big and capable organization, but Earth science is a subject far too big for one country, one agency to tackle all by itself.
And when you can't do it by yourself, you call up your colleagues halfway across the globe. We're in the Philippines to better understand how tiny particles from smoke and pollution affect cloud formation. The campaign is called the Cloud Aerosol and Monsoon Processes Philippines Experiment, CAMP-X. The 2 is silent. That's just a joke, but the acronym, that's serious. This project has implications for millions of people.
I'm the program scientist for CAMP-X, and while I'm here, I'm sort of the decision maker of last resort if something comes up.
We caught up with Hal between meetings in the hangar. Along with Jeffrey Reed from the Naval Research Laboratory, he's responsible for overseeing this large collaborative effort in real time, making sure the team is meeting their scientific goals while also keeping researchers from institutions around the US and the Philippines working together smoothly.
A critical part of the process was the relationship built through time. That relationship enabled us to really work together and think about what would be the questions that would be relevant to us in the Philippines and in general to the region. I'm Gemma Teresa Narisma, and I'm the Executive Director of the Manila Observatory.
The Manila Observatory, along with NASA, the Naval Research Laboratory, and a handful of university partners are using 2 research planes and measurements from a ship to look at the properties of clouds to improve satellite measurements in the region.
Satellites find it difficult to see, quote-unquote, this region, and regional climate models are having a hard time capturing these processes.
That basically means planes, ships, and teams on the ground need to fill in the missing details. Which brings us back to the most intense fire season in 5 years.
We were able to get the P3 into that smoke and make absolutely unique and important measurements.
It's important because if we cannot get the historical observations in our model, then we're not so certain whether our climate projections are correct.
When the planes aren't flying, the science teams and flight crews take turns visiting local schools, from elementary up through university.
Elementary school students can understand remarkably complicated concepts. And so it's kind of fun to introduce them to things they may not have known or thought about before. And it's remarkable how quickly they pick up on it.
At these schools, the scientists are treated like rock stars.
We've had just an amazing response from the Philippine students. Many autographs and more selfies than I can count.
Some even said that they want to become meteorologists themselves to help carry on the study of our home planet and how it's changing.
I feel hopeful. We're not getting any younger, and the number of atmospheric scientists in the Philippines, in the world, particularly in the Philippines, is quite small, and the kind of work that needs to be done to understand the different atmospheric processes in the region is quite a lot.
We are so dependent on this earth because we live here, we have to breathe here and find things to eat here. It's important that we understand it so that we don't inadvertently cause damage that could affect us all.
What we're seeing is that areas that have been flammable are becoming more flammable, pushing those systems into either extreme conditions or a year-round fire season where fires are literally possible at any time. I think the choice to study fire generally is a bit of an occupational hazard. It's true. We're not necessarily looking at the verdant green parts of our planet. We're headed to the end of the road. We're looking at areas of rainforest that have been cleared and burned. We're capturing scorched landscapes.
In this series, we've been following the fire season around the world. First in the American West, in the early part of summer, the start of the fire season. Then in high northern latitudes, Canada and Alaska. Then finally in the Philippines, as the summer became fall. In the past, you could count on the fire season eventually coming to an end. But we're now learning that that's not really the case anymore.
What we're seeing is that areas that have been flammable are becoming more flammable, pushing those systems into either extreme conditions or a year-round fire season where fires are literally possible at any time.
We caught up with Dr. Doug Morton to find out the extent of the damage.
Hotter and drier conditions, adding wind, you end up with fires that are moving faster and burning hotter than what we've seen before. Can we better understand, anticipate, and characterize the changes in our planet that come from those extreme fires?
Actually, yes, we can.
Myself and my staff at the GIS Center worked closely with colleagues at Goddard Space Flight Center to make this thing happen.
This is Keith Weber, the wildfire rehabilitation expert that pioneered a new groundbreaking tool. The Rehabilitation Capability Convergence for Ecosystem Recovery includes a function that allows fire responders to triangulate their wildfire response. The tool can geolocate everything from burned areas to potential landslides to impacts on endangered species. But Recover really gained momentum after one fire in particular.
I remember looking at our whiteboard that shows all the real high priority things we need to be doing. And that whiteboard was clear. And I was walking out, I talked to some of my students and I said, I think the wildfire year is done. We got it wrapped up. Well, shouldn't have said that. Because the next day, one of our users in California, Woolsey Fire started going. It became much larger than I think they thought it would because of those big winds, and it really grew very rapidly. Well, at that point, we were working with that team on a daily basis, doing refreshes, as we call it, as the fire grew and grew and grew every day until we had that thing out.
Keith's team is making a tangible difference by saving property, resources, and lives. Innovations like these represent a promising future.
As we move from today's cutting-edge science into tomorrow's prediction, response, and understanding, the work we do today opens up an opportunity to do that so much better going forward. There are so many science topics that today are on the cutting edge of our understanding, and what get me and my science colleagues motivated to go out into the field and keep working on these problems. Can we improve the way that we can forecast, for example, fire risk, not just for tomorrow, but for 10 days from now, that might help managers, communities prepare and respond to changing fire weather conditions?
Like all of us, our NASA explorers and partners in exploration face the daily decision to either choose apathy or get to work. The future is uncertain, but we choose to meet the challenges of this new normal head on.
Are we used to test up on here?
Yes.
You gonna be?
Alright, guys, I need you to be quiet though in the other room.
Okay.
Okay, got it.
Alright. Okay, we're doing it.
Pretty much anything that you can observe on the land and coast, and sometimes even in the ocean, NISAR will have an application. Very exciting mission, generating an enormous amount of data that will keep the science community and the applications community busy for a long time.
NISAR is a partnership mission between NASA and ISRO, the Indian Space Research Organization. It's a collaborative project.
And we'll be collecting data for all around the whole Earth for all of the land masses.
Looking at volcanoes, earthquakes, landslides, other natural hazards that occur in the crust of the Earth.
A movement of sea ice, movement of glaciers, how much forest land is growing or being reduced.
Because it can image at night and through clouds, it can allow us to see through storms.
It's really going to allow us to see things changing in areas where we can't with other satellites.
So NISAR is going to open our eyes to the potential of this technique for seeing the ground in places that otherwise has been obscured.
So every 12 days we will map the land masses, and then we can take those mappings and we can compare them. We can do what we call interferometry,
where we can take an image acquired on one day and combine it with an image acquired 12 days later from that same vantage point, looking at the same point on the ground. And when we do that, we can see the motion of the ground down to a fraction of the radar wavelength, which in this case is on the order of a few millimeters.
NISAR has two radars on it, two synthetic aperture radars. One is an L-band and the other is an S-band.
So it's kind of the Tesla or the Maserati of radars, whichever you think is cooler, I guess.
This here is the radar payload. That is the spacecraft bus. Large 12-meter reflector, common antenna system for both L-band and S-band to send out the RF signal and capture the return signal.
Good morning, Dr. Paul. Antanu, how are you today?
Yeah, I'm fine.
And the pandemic is something that we were not counting on when we developed this project.
The NISAR project was actually pretty well versed with this remote operations because of that Indian engagement.
There was a little bit of WebEx fatigue, but I think we're learning how to do it better now.
But yeah, we're all in great spirits, and we will take a little hit to the schedule, but we've been waiting a long time for this mission, and we want to do it right. We want the hardware to work, and we want the science to be done.
One of the best things we can do to increase diversity in the sciences is to make it easier for people to enter the sciences.
The data is going to be freely available to everybody. We aren't going to have to pay for it like we do with some satellites.
So making the data free, having it easy to download to your own machine, all of that stuff is critical if we want to remove those barriers to entry to the field.
I'm looking forward to the sense of discovery that I think we're going to have when NISAR data start coming down.
Earth science is incredibly important to understand what's going on in the name of what our children and grandchildren are going to have to face in the future. And all the information we collect now is only going to help them understand that better and hopefully make their lives better.
Digital electronic subsystem, cognizant.
There goes my son.
You know, the radar will...
I can't recall. There we go.
That's our real life here in 2020.
We all want to go back to the moon. Getting us back to the moon in this generation sparks a whole new generation of explorers. Hi, my name is Dr. Kay Renee Horton, and I am boots on the ground for SLS. We actually weld our liquid hydrogen tanks and our liquid oxygen tanks on this. It is the largest weld tool in the world. It's the only one of its kind. It stands 170 feet tall and it has a diameter of about 27.6 feet. So as a quality engineer, we make sure that they're actually meeting the requirements they're supposed to meet. They do a phased array ultrasound, which goes in and checks to make sure we don't have any defects in the weld. To get up and to pull up the news article and they're talking about what you do at work is amazing for me. I really love detective novels, and so I'm an avid reader, and I actually write children's books in my spare time. My children's books are about Dr. H exploring the universe. Each day I walk into the factory, I know that I'm putting my footprints in history, and that's a pretty big deal for me.
The Rescue Coordination Center started receiving distress signals.
The bridge was starting to fill up with water. The ship was sinking and got them out on top of the rescue boat.
Winds up to 60, 70 knots.
We started to separate one by one.
Wave height 50 to 60 feet.
Finally, I was alone and no rescue boat or nothing. The rescue boat drifted away.
It's freezing out there.
All I had to do was just wait and hope some kind of miracle would happen.
There is almost no chance to survive in conditions like that.
AIS, the automatic identification system. All ships out on the open oceans are obliged to transmit their position and their identity and their direction of speed, heading and speed, etc. It's kind of like air traffic control for the sea.
It's very useful to help provide assistance to ships in distress.
First of all, to see, do we have assets in the area that could help somebody in distress? In the days before AIS, we didn't even know if there were any vessels in a particular area where we have an incident.
They were more or less invisible to the Coastal Traffic Administration.
But as of today, if we have an incident out in open water, we have the chance to see what vessels are in the area and could contact them directly to route them to the position or the distress. And in that way, in a more effective way, rescue more people within a shorter time frame than we ever have before.
AIS receiving stations along the coast, they can only look a certain distance out into the sea.
Ships that go out beyond 75 kilometers outside the coast were over the horizon and invisible to us. But if you think about these signals going straight, they go maybe several hundred kilometers out into space. And you know what circles around the Earth about 400 kilometers above us? The International Space Station.
The European Space Agency contacted the Norwegian Defence Research Establishment and gave them the opportunity to mount an AIS receiver on board the space station to test out this technology from space. All our calculations indicated that this should work, but we really did not know before we switched on the receiver on the space station. 1st of June 2010, the system was turned on.
The switch was flipped and the light came on, and we were actually able to get the first data in. Yes, the instrument works.
We all got very excited.
And suddenly we could see a whole world full of ship data. It was I would say, a quantum leap really in our ability to look at global ship traffic.
It's like a blind man starting to see.
Yeah, it was a huge relief and great satisfaction to see.
So this brought a whole new dimension to the monitoring of ship traffic on the open oceans.
Nobody knew how many ships really are out there at any given time, and suddenly we had, if not the complete picture, then almost a complete picture.
On a typical day, the space station is observing about 30,000 ships out on the open ocean.
I was kind of overwhelmed, I guess, by the response that's got. The space station really is an excellent lab for testing this type of technology.
This project demonstrates that the International Space Station is not just for science and astronauts, but it really benefits the whole mankind with down-to-earth applications.
Based on the AIS, we had another vessels in the area that we contacted who continued to the area, and they searched together with others. Nobody expected to find anybody surviving in that conditions. They actually spotted one man in the sea.
After floating in the North Atlantic Ocean for 4 hours, I was finally rescued.
Thanks to AIS data and AIS data from the space station, this lone survivor was rescued. An absolutely happy ending for him.
And luckily for technology that made something that was basically impossible to survive possible.
What happens if you wake up in the morning and you understand the state of the world as it is right now?
What could that data enable? How could people make smarter decisions? How could, for example, a farmer get better yield on his or her crops? How could somebody help disaster response? How can we use satellites to help humanity? That, in many ways, was the underlying thesis of doing Planet Labs, was to get data into the hands of people that could enable us to make smarter responses to that.
Planet Labs set out with the mission to photograph the entire Earth every day. And they thought, how are we going to do this? They said, let's build our own satellite.
Commercial imaging satellites, they're very large. They are very expensive. We took a different approach.
By making them really small, we can launch lots of them, and by launching lots of them, we can cover this, to get to this mission of imaging the whole Earth every day.
If we can do that, then we can literally change the way that we see the world.
And they called it the Dove. It's about the size of a loaf of bread.
Our doves are basically mainly a big camera with a telescope looking down to take pictures of the Earth. We initially developed the first Dove satellite in our garage. So we kept on iterating the Dove design, we made it better and better, and eventually we put our first one into space. We had no idea what the quality would be like.
I mean, we didn't know if it was going to work.
But we got an image down and it was so beautiful that we knew at that point we could make this technology work.
Wow, we can really do this, and we can achieve this mission, which is something that is really needed for us to understand global change.
So we had done a couple of demonstration satellites, but the next steps we wanted to do was to scale it up to test the first fleets of satellites.
But what made that possible was actually access to space.
So here's the problem, that in order to take pictures of the entire Earth every day, you're gonna need more than 1 or 2 satellites. You're gonna need a whole lot of satellites, and you're gonna need to be able to deploy them really fast. And really, there's only one obvious choice on how to deploy that, and that's the International Space Station.
There was no other platform in the world in order to get access to space of that fashion in that time period than the International Space Station.
NanoRacks is our key partner with NASA.
At NanoRacks, we understood Planet Labs' vision, and we knew that we could help. We worked together to figure out what was going to be the best way to get as many satellites as possible, and we basically developed a new platform. It goes out of the GEM airlock. It's picked up by a robotic arm, pointed out into space, and it fires these little satellites off of the space station.
They were able to secure 28 of our satellites to be launched from the International Space Station, and that was known as Flock 1, our first constellation.
This opened up the whole world to satellite developers, people that could put things into orbit fast.
We now deploy these on a regular basis from the International Space Station. And now today, we're able to operate the largest fleet of Earth imaging satellites in human history.
And none of that would have been possible without the International Space Station.
The International Space Station does enable young, small companies like ourselves to get going in space.
The ISS provides a lot of opportunities for commercial companies to test and find where the market in space is going to be.
And so what we're seeing today is a proliferation of new ideas and new concepts. It's almost like it's a renaissance of what's happening in space. Buckle up and strap down, because this is going to be a rocket for all of us in the global community to be part of.
The first pictures now coming in from Puerto Rico after taking a direct hit. Hurricane Maria slamming into the island. One official saying the island is destroyed.
Hours with winds and rain, and didn't stop.
Power lines are down. Streets are impassable. Many roads are flooded.
High winds uprooting trees, overturning cars, and turning buildings into piles of twisted metal.
It is something that will change Puerto Rico forever.
We had no water, no food, no gasoline, no communication at all.
Not knowing where my next meal will come from, it hasn't been easy.
After Hurricane Maria, everything was gray, all the plants were dead. Hurricane Maria took the color away from us.
I am sure that these children will not be the same. They will not be the same. They are still struggling and trying to recover from this.
My name is Joe Acaba. I'm a NASA astronaut of Puerto Rican descent. I was about a week into my mission on the International Space Station. Hurricane Maria was forming up, and from there, if you looked out the window, Maria took up a big chunk of what we could see. It was gonna cover the entire island. After the hurricane, their power grid was pretty much taken out. You just couldn't see the island anymore. The hurricane, I think, had a huge impact on, the island as a whole, but especially the kids.
Joe Acaba was our hero, and we need something positive. The students need something positive.
We wanted to pull through, forget all that happened, and lift up our spirits and lift off the island.
So I knew I couldn't do much from up on the International Space Station, but I did want to connect with the students to show them that there is hope and that there are people out there that care about them.
NASA has the STEM station, which allows the students and teachers to talk to the astronaut in the space station.
It's making that connection so that maybe, you know, they become more interested and we can inspire them more to study the STEM fields.
So we were able to establish and coordinate with NASA one of these video conferences. Thousands of students from different parts of the island watching the video conference with the space station, talking to Joe.
This is Joe aboard the International Space Station. I have you loud and clear.
How do you compare?
What is the most impressive view? How did Puerto Rico look after
astronauts allowed to visit? How often?
What is the minimum number of
It was awesome because, you know, as soon as it came up, you could hear people clapping, people were excited. So even though I couldn't see them, you know, I could feel them, and that was pretty neat.
It was amazing. He called from the International Space Station to see how Puerto Rico was doing, and that means a lot for us, a lot.
In May of 2018, I was able to go back to the island, my first time since the hurricane. It was a great opportunity to get out and kind of come full circle with those students, to go and see them in person and, you know, kind of reiterate how important they are, and just to give them a little bit more hope, because there's still a long way to go on the island.
He's a hero for us. Kids love him, and everybody loves him here. Joe Acaba is the role model that we need at this time.
I want to be like him. I want to go far, and I want to be an example for little kids when I'm older.
Not only is the International Space Station a great tool for scientific research and exploration, but for students from Puerto Rico in particular, I think that having that video conference with them, it did provide some hope. It did provide some inspiration. And so it's just one of the benefits that we get from the International Space Station.
In order to support International Space Station, we're constantly having to build new hardware to send to space, but as well, we need to make training hardware on the ground. So we ask ourselves, what if we got high school students to build us some training hardware and get them out of the textbook, get them some hands-on lessons to work with, and by doing that, we'll be inspiring the next generation of students. So that's when we decided to create Hunch. Hunch goes to the local high schools, partners with the high schools, and gives these students opportunities to design, build hardware that will fly in space or be used for training hardware on the ground. Students did the design and engineering, the CAD drafting, the 3D print prototyping, the machining, the procurement of the hardware. All this done by high school students to get this article to fly in space. From the quality perspective, the students have exceeded all of our expectations. The hardware we're getting in is top-notch.
This program actually helps them focus into the engineering and the STEM fields.
I've been teaching for 23 years. I've never seen anything that even remotely compares to having the type of impact on students that Hunch has had. Absolutely phenomenal.
Working with the Hunch program, we fabricated training hardware for the ISS.
I created and designed interactive simulations.
We're making a Mexican paella and hopefully gets chosen to go to the International Space Station.
From the Hunch program, I've learned how to use AutoCAD.
We learned a lot of teamwork.
I've definitely gained some communication skills.
We're learning more about food science, technology, but everything basically doing this.
It gives them a confidence that I don't think they would have had to that level before this.
Maybe I would actually be able to be an engineer. So it was never something that I'd thought that much about. And then I was working on this stuff that went to space, And I couldn't think of anything more exciting. And I still can't.
It's a pretty cool thing to be able to tell other people or family when you go visit that I work with NASA programs.
I mean, I told everybody, like literally everybody.
We have an opportunity here for them that is unbelievable.
It's kind of like getting a master's at age 16.
They truly have moved on to a level they wouldn't have approached or wouldn't reach, I believe, without this program and without the International Space Station.
Before the Hunch program, I really was just a C student with no direction in my life. And since then, I've been on the Dean's List for the past 4 years and will be transferring to pursue mechanical engineering.
It really helped me find my passion for aerospace. The Hunch program gave me my career.
The impact on their lives has been amazing. They're more successful, they're more driven, they're more determined. They know they can achieve, and that's all, I think, through this program, through the Hunch program and interaction with the International Space Station.
The next commercial crew test flight to the space station, a new space station module, and another astronomical discovery by Hubble. A few of the stories to tell you about this week at NASA. NASA's Boeing Orbital Flight Test 2 mission to the International Space Station is the second uncrewed flight test of the company's CST-100 Starliner spacecraft as part of our commercial crew program. The mission aims to demonstrate the end-to-end capabilities of the Starliner and the Atlas V launch vehicle and provide valuable data towards certifying Boeing's crew transportation system for regular flights with astronauts to and from the space station. A few hours after the Nauka Multipurpose Laboratory module docked to the International Space Station on July 29th, flight controllers noticed the unplanned firing of the module's thrusters, which caused the station to move out of orientation. Ground teams worked to regain attitude control and stabilize the space station, and the crew was never in any danger. Nauka is the new science facility, docking port, and spacewalk airlock for the Russian segment of the station. Meanwhile, the Pirs module left the orbital outpost with a Progress spacecraft on July 26th. Pirs had been the previous docking port for Russian spacecraft and airlock for Russian spacewalks since September 2001. New and archival data from NASA's Hubble Space Telescope have helped astronomers uncover evidence of water vapor in the atmosphere of Jupiter's moon Ganymede for the first time. This water vapor forms when ice from the surface of this extremely frigid moon turns from solid to gas. Researchers believe there is an ocean about 100 miles below Ganymede's crust that contains more water than all of the oceans on Earth. Scientists from our Jet Propulsion Laboratory joined international researchers to create an index that tracks how the world's rainforests are responding to threats like our planet's warming climate and human land use. These diverse ecosystems are home to more than half of the planet's life forms and act as a natural slowing mechanism to the increasing levels of carbon dioxide in the atmosphere. The index could help policymakers plan for conservation and forest restoration activities. NASA has named 9 winners in the Futurescaping Our Skies Challenge. The competition, conducted through our Aeronautics Research Mission Directorate, asked the public to help envision the future of flight, taking into account how societal, technological, regulatory, environmental, economic, and political changes over the next 30 years might impact aviation and vice versa. Input from the challenge could help us better anticipate aviation needs in the future and make better decisions about technology development today.
3, 1.
July 26th was the 50th anniversary of the launch of astronauts David Scott, Al Worden, and Jim Irwin on Apollo 15, the 4th NASA mission to land humans on the moon. The mission was also the first to use the lunar roving vehicle which Scott and Irwin used during their more than 18 hours of lunar surface exploration, while Worden orbited overhead in the command module. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
Hi, I'm NASA
NASA Kennedy's Notori Thompson, and I'm taking you inside KSC. NASA and Boeing are targeting Tuesday, August 3rd, for the company's Orbital Flight Test 2, Boeing's second uncrewed flight test for the agency commercial crew program. The United Launch Alliance, or ULA, Atlas V rocket with Boeing's CST-100 Starliner spacecraft atop will lift off from Space Launch Complex 41 at Cape Canaveral Space Force Station. Earlier this month, Starliner was hoisted on top of the Atlas V rocket in ULA's Vertical Integration Facility. As part of the pre-launch activities, NASA Administrator Bill Nelson joined other NASA, Boeing, and ULA leaders to answer questions from reporters in social media. Also participating were the 3 NASA astronauts set to fly on Boeing's crew flight test, which will be the first flight for Starliner with astronauts aboard. Orbital Flight Test 2 will demonstrate the end-to-end capabilities of the Starliner spacecraft and Atlas V rocket, from launch to docking at the International Space Station to a return to Earth with a landing in the western United States. The mission will provide valuable data towards NASA certifying Boeing's transportation system for crew flights to and from the space station. For more Inside KSC, please check us out on social media and at nasa.gov/.
Hi, I'm Lori. I study the planets, our solar system, and I especially love volcanoes. And this is Ask NASA. The thing I love the most about our solar system is that it's an incredible natural laboratory. We have so many different types of objects in the solar system, from planets and moons and asteroids and comets. We can study each one of those, and they all have something they can tell us about how the solar system formed or how Earth ended up in its special place. And understanding why the other planets are different from Earth actually helps us better understand how we ended up the way we are today. So this is a globe of Mars right here, and many of the reasons why we're so interested in Mars, there's a lot of different processes going on Mars that help us better understand Earth. A lot of the surface of Mars has been preserved for almost 4 billion years, and so we can study a lot of things on Mars that you can't even find on Earth.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
So Perseverance rover is going to drive around and find some of the best rocks it can, drill down into the rock and soil and collect those samples so that on our next mission, Mars Sample Return, we'll be able to bring those back and study them in our laboratories here on Earth. There is volcano on Mars. In fact, there's lots of volcanoes on Mars. The largest volcano we know of in our whole solar system is on Mars. It's called Olympus Mons, and it is so giant that the entire chain of Hawaiian Islands could fit inside the crater at the top of that volcano. We see volcanoes really across the solar system on all of our rocky bodies. So on Mercury, we see evidence of lava flows on the surface of Mercury. Even on the moon, we have lava flows that we can see. On Venus, we see the entire surface of Venus is covered with lots of volcanoes and volcanic deposits. So this is a globe of the moon Io. Io is the moon of Jupiter. That's the most volcanically active body in our solar system. And that's because the pull of Jupiter's gravity on Io as it goes around Jupiter tugs and pulls at Io, and that heats up the inside, and that drives volcanoes. The heat needs to be released. This is the volcano Pele. And there's lava flows down here in the middle, but then there's also this big red-orange deposit, which is actually from explosive eruption of the gases that are falling down onto the surface of Io around the volcano. And it has no atmosphere, so if you were to turn it like this and look at this volcano, from the side you see a big umbrella of gas. The particles just come out, and then they drop back down. And I started studying volcanoes on Earth about 35 years ago, and then started studying volcanoes on other planets, and that grew into my love of our solar system. So the asteroid belt really contains a lot of leftover material from solar system formation. You can imagine that when the solar system first formed, the particles kind of came together and made bigger particles. Some of those came together and created the planets. We actually find asteroids in lots of different parts of our solar system. We have asteroids that are near Jupiter, the Lucy mission, which is going to launch this year in 2021, and it's going to go study those special asteroids that are trapped in Jupiter's orbit. And then next year we have another mission called Psyche that's going to a particular asteroid called Psyche that looks to be made mostly of metal, of iron. It may actually be the exposed core of a small planet that may have had its crust blown off by an impact and left that metal core that we can see. There is definitely water on the moon. We know this because we've observed with some of our orbiters being able to identify that there's water molecules on the moon. And in fact, some of these we believe are preserved as water ice, perhaps in these permanently shadowed regions that are very, very cold near the poles. And what we need to do next is to actually go down to the surface of the moon and actually look at that ice up close. And so that's what we're doing with the Artemis mission. We'll be focused on looking for some of that water in the soil of the moon. We have explored really the far reaches of our solar system. We have sent missions to Mercury near the sun and visited all of the planets in our solar system, all the way out even to Pluto. And then one of our missions, called Voyager, actually has 2 spacecraft that have now even gone beyond the edges of our solar system. So we have really explored the whole expanse of our solar system.
Cool. Io and Mars are great.
Let's try it again. Oh, that's too high.
That was a fastball. She had a fastball.
Do you have a question for NASA? Send your questions to our experts using hashtag AskNASA.
I call it the 10% rule. You got to be 10% smarter than the thing you're trying to operate. My name is Greg Cormouche, and I'm here to test rockets. We supply helium, air, nitrogen, and hydrogen so that they can use them while they're testing the rocket engines on the big stands. We have 4 compressors. Each compressor puts out 400 standard cubic feet per minute, and we send that to the test site. I'm a mechanical engineer. I did a lot of mechanical things besides go to college. I mean, I worked on my own cars, heating and air conditioning work. I was familiar with electricity. The first time I walked out on the engine deck and looked at a space shuttle main engine, I said, man, it was overwhelming, you know. Eventually, you know, you stick to it, and I was able to pick it up. The folks that work here are awesome. There's a wonderful group of men and women who keep this place up and running. When you're here as much time as we are, this place is like family. Being a part of the SLS program it's a life event, you know. This is going to be the culmination of all that hard work that everybody put in years ago.
Our planet is a living example of a delicate balance. A complex system that is constantly changing, constantly evolving, constantly adapting. How do these changes affect life on Earth? How does everyday life affect our planet? We have a great capability to absorb, interpret, and comprehend, and an urge to understand the world we live in. This is what defines us as human beings, what makes us who we are. With our technological advancements, we are now capable of exploring new worlds, new frontiers. We're searching for answers that may lie in front of us. Better yet, above us. field phase of the experiment is about to begin. All the planning, sleepless nights, meetings, and hard work the team has invested in the mission are at stake. My name is Yasna Pittman, and I'm one of the many scientists working on the airborne tropical tropopause experiment.
It's very natural for humans to want to understand how the world around us works.
Why the atmosphere does what it does, it's like solving a puzzle. You just want to understand how it works.
We're trying to understand how we're affecting, how humans are affecting the atmosphere.
Understanding how the stratosphere changes very much reflects how our climate is changing.
I think that the work that is done in atmospheric science is very important, but it's also a lot of fun. It's like the best job possible.
Well, NASA has been doing airborne science investigations for quite some time. Some of the earliest investigations we were doing was related to the early days of the Antarctic ozone hole.
In 2009, we started a new kind of program. It's called the Earth Venture Program. It's got 3 parts, and the first of those parts is what we call suborbital science. This is science done not using or not including a new satellite.
With some of these newer missions, we have let the community come up with their own ideas, their own way of implementing the mission, what their own science requirements are, and they bring their measurements to the table.
And ATREX had very good science, was very relevant to the kinds of questions we wanted answered, and its budget was reasonable and appropriate.
ATREX is an airborne campaign to try to understand how stratospheric water vapor affects climate.
It causes perhaps maybe 15 to 20% of the warming that we've had in the past 15 or 20 years.
So it turns out that small changes in the humidity of the stratosphere are very important for climate and important for surface temperature. They're actually comparable to the importance of greenhouse gases that everybody knows about.
So for example, we know that if you go back 30 years, carbon dioxide was quite a bit less 30 years ago. Methane was less 30 years ago. Nitrous oxide was less 30 years ago. So we know these gases are increasing with time.
Gases that affect the chemistry of the stratosphere, which is where the ozone layer exists that protects us from ultraviolet radiation.
So understanding the rate at which this stuff gets into the stratosphere and how it changes is extremely important to looking at the climate of the stratosphere and how the stratosphere climate affects the lower atmosphere.
So we really need to understand what controls the humidity of the stratosphere and actually be able to predict that in the future in order to improve the accuracy of our predictions of future climate change. Turns out the most important place to go sample to understand that is the tropical upper troposphere, the top of the troposphere in the tropics. It's called the tropopause, which is actually at very high altitude, which is why we need a high altitude aircraft to study it.
So the tropical tropopause is at about 55,000 feet in the tropics. So if you go down to the equator, you have to go up quite high, above 50,000 feet.
And the tropical tropopause is really important to the global atmosphere because most of the gases that get into the stratosphere, all the air that's circulating upward into the stratosphere, goes through this tropical tropopause region.
So that's basically a gateway to the stratosphere. The general circulation transports air upward in the tropics, goes into the stratosphere, and then is spread throughout the stratosphere and comes down at the higher latitudes in the polar region.
And this is what ATREX is focused on, to look at that motion of air into the stratosphere and how the water is removed from that air as it rises upward.
We know a lot about it, but there are some puzzles about the details of how the clouds are formed and under what conditions they form. So that's probably the most important thing that we hope to gain from ATREX.
ATREX will address a number of really important issues. It'll give us a better understanding of exchange between the troposphere and the stratosphere and how that impacts atmospheric composition, how that affects the chemistry that goes on in the upper atmosphere, and in the longer term, how that will affect climate.
And that will help us to understand as we go forward trying to figure out what to do about climate change to better predict it and make better decisions.
How does the interaction between the upper troposphere and the lower stratosphere affect us down below? How are we going to find out? We have the questions. Now we'll be searching for the answers. Hawks' sense of hearing is excellent, and their eyesight the best in the entire animal world. Not only can they see greater distances than humans, but their visual acuity is 8 times that of ours. Yet we need to look even further, higher, deeper into the sky.
We live in the lowest layer of the atmosphere, which is the troposphere. The stratosphere is the next layer above us, so it's basically above altitudes of somewhere between 30 and 50,000 feet.
There are processes that take place in the stratosphere that have very direct impact on us.
So it's extremely important to understand the detailed process of water turning into clouds, those particles in clouds settling out. How does that detailed process occur, and then how will it change in the future?
What's been our big problem is getting the airplanes to the right place where they can make the measurements for long enough periods of time to do the observations.
So it turns out the Global Hawk is a perfect tool for sampling this part of the atmosphere. It's a high-altitude aircraft. It flies considerably higher than normal commercial aircraft, but it's also got this extremely long range.
So our bird here can climb to a cruise altitude of 65,000 feet and fly for up to 30 hours.
So we can basically, for example, we could fly from here to Australia in one flight.
So the basic geometry of the airplane, it has a wingspan of 116 feet, which is equivalent to the wingspan of a Boeing 737 transport aircraft, a length of about 65 feet, weighs about 27,000 pounds, fully fueled at takeoff.
In comparison, in the past, people have used manned high-altitude aircraft like the ER-2 or the WB-57. However, those have very short range.
Now that we have the Global Hawks, they have a much longer flight duration. They can get to these key areas to appropriately attack the science questions that we've been thinking about for a very long time now.
basically for this program, we searched out the best instrumentation, the best expertise in making these measurements, and invited them to be part of the program for the proposal for the ATREX mission.
Once the major science campaign, the project mission scientist, selects the instrument teams, that's really when our work gets started. We will then visit them and begin coordinating all the mechanical and electrical interfaces we need to do to get them mounted on the airplane.
You have to determine everything from the size of the instrument, so you know how much space it's going to occupy or needs to occupy in the aircraft, how much the instrument weighs, so you can be sure that what you design mechanically for installing the instrument on the aircraft is of sufficient strength to be able to hold the instrument in the aircraft.
In some cases, you'll see probes sticking out of the airplane, so all that has to go through aerodynamic analysis, etc. Structural mounts inside have to be properly stress analyzed, so we make sure all that happens. So we coordinate with all the proper technical fields to get ready for the instrument to arrive here.
From the time we first start communicating with the instruments teams until we're ready to actually start performing science with all the instruments on the aircraft, it takes about a year and a half of really hard work, close coordination, and a lot of good communication between everybody.
We're using state-of-the-art instruments, or cutting-edge instruments, to measure things like water vapor, clouds, and temperature, and a whole bunch of trace gases.
We have a very sophisticated instrument called the Cloud Physics LiDAR. It's a laser, shoots out the bottom of the nose of the plane, and as the laser goes down, some of the light gets scattered back, and there's a telescope that collects that light. And because you know how long it takes the light to go down and then come back up, you can tell what kind of cloud structure there is below the plane. So if we see very thin clouds, this laser can detect those very thin clouds. We have a meteorological system on board the plane that measures winds, temperatures, and pressure. And it's the best meteorological instrument in the world for measuring these. Imagine how hard it is to measure from a plane that is going a few hundred miles per hour. So it's a really hard measurement to make, and they do it. We have water vapor measurements, 2 water vapor measurements on board the plane. Water vapor is important to look at how air that's going into the stratosphere gets freeze-dried, so you have to have a really high-quality water vapor measurement, and we have 2 instruments to do that. We measure ozone on board this plane. Ozone, as I mentioned, the ozone layer screens ultraviolet radiation, so we have to know what the ozone looks like. There's actually very little ozone in the lower atmosphere, and there's a lot as you get into the stratosphere. So we use ozone actually to tell us the difference between stratospheric air and tropospheric air. We have another instrument that actually sucks little gas samples, has little cans, so it'll suck in a little air, and then you bring those cans back, take them to a lab, and you could literally measure 100 different gases from these little gas sample cans. And that's really important because you can look at all sorts of natural and human-produced gases to look at things like ozone depletion and climate change.
So all of these will tell us how air is transported through the tropical tropopause region and how it's dried to the very dry conditions of the stratosphere.
ATREX is sort of a pathfinder in terms of investigating some of these processes, and when I say pathfinder, it's utilizing a brand new tool, and that is the Global Hawk.
This is a hybrid. It's like a satellite that you control from a control room, like a mission control, but it has nobody in it, like a satellite. So it's really a new and revolutionary way of doing science.
With the science that we do at NASA, we need to combine the satellite data with aircraft data, with modeling data, and even some measurements from the ground all together to answer the science questions the right way.
In 50 years, we'll look back on this plane, and it'll be very common. It'll be used all over the world. I really believe that planes like the Global Hawk are going to change atmospheric science in a very profound way, and for the betterment of everybody who lives here on the Earth.
Everything is ready. We should be airborne soon.
A new era of exploration is beginning. NASA is building on its experience in low Earth orbit and preparing to go farther, setting up a base camp in orbit around the Moon, known as the Gateway, exploring the surface of the Moon like never before, and preparing to one day go to Mars. To accomplish all this, NASA will need a new spacesuit for its astronauts, one that's more flexible, versatile, and durable than any made before. Engineers are now hard at work designing, building, and testing the new suit, making sure it's up to the task for future exploration. Some of the greatest moments in exploration have taken place with a human in a spacesuit. Whether it was a first journey outside the spacecraft or traversing mountainous moonscapes, the spacesuit made it possible. The act of sending a suited human outside the spacecraft is called EVA.
What is an EVA? EVA is an acronym that stands for extravehicular activity, which is what most people know as a spacewalk. It's whenever we take astronauts and we let them go outside to do useful work in the vacuum of space.
The spacesuits currently in use for NASA EVAs were designed in the 1970s for space shuttle missions. They have been upgraded over the years for work on the International Space Station and have served NASA well.
In the past 20 years, there are a handful of types of spacewalks that we've done. We've done planned spacewalks for maintenance. As hardware breaks, we can do contingency spacewalks. As technology improves, we can upgrade hardware. Or like with the Hubble Space Telescope, we're actually repairing very sensitive scientific experiments in order to enable science.
Those EVAs took place in microgravity, where astronauts float and need to use their hands to move from place to place. But moonwalkers, working in 1/6 Earth's gravity, will need spacesuits that let them use their hands and feet, walking to destinations and bending and reaching as they explore. For this new type of work, NASA has been testing prototype planetary suits, culminating in a new suit design, the XEMU.
The XEMU is Exploration Extravehicular Activity Mobility Unit. So it's an exploration spacesuit. So it's a spacesuit that you're going to use as we move forward on Gateway missions and on the lunar missions with Artemis. And then we're using all that to test the suits you would want to use to go to Mars in. So eventually you're going to have to be very independent and very confident in your hardware when you go and do a mission that far away from Earth.
One of the most obvious changes in the new spacesuit is the way astronauts get in and out of it. Donning the current suit is a multi-step process of wriggling into the upper torso and then getting help attaching a pair of space pants. The new generation spacesuit features a hatchback, where astronauts simply slide in and out of the one-piece body of the suit. Another big feature of the suit is the way the astronauts are able to move while wearing it. Apollo astronauts learned they had to hop to get around on the moon. The suit design sometimes made it difficult for the astronauts to work.
Up. Okay. We see that one went all the way in. Not quite.
Engineers learned valuable lessons from those Apollo suits. The improved design for the next generation spacesuit will allow astronauts to walk on the moon, not hop. Additionally, astronauts will experience an improved range of motion.
The new suits, the planetary walking suits we're working on now, we really hope to provide improved mobility and comfort along with reduced injury potential. And really, like I said, provide the best tool to the crew member that we can provide. Then we want to be able to provide them the ability to kneel down and pick up a rock, like they're going to want to do in their geology science that they're working on. We want this to be a very reliable and durable suit so they can use it day after day in a dusty environment and not have to do a lot of maintenance with it while they're needing to do their mission. So there's a lot of those kinds of aspects that go into improving the suit that we're going to provide for the lunar missions.
Improved mobility is not the only feature engineers have been working on. The astronauts will also be carrying a special backpack known as the PLIS.
So the PLIS is the Portable Life Support System. It's the backpack on the spacesuit, and it has all of the interesting parts to keep the crew member alive while they're on their spacewalk. So it has oxygen stored as pressurized gas for breathing, pressure regulators that regulate the oxygen pressure inside the spacesuit, and then a ventilation loop and a water loop that we call the thermal loop that provide trace contaminant and carbon dioxide removal from the breathing environment, and also cooling for the crew member and the suit on board avionics and electronic systems.
While the PLIS has been on previous spacesuits, this improved version will offer new technology, greater control of its systems for the astronaut, and longer life for each EVA, allowing more exploration.
The PLIS labs are awesome, super fun places, and we physically assemble the parts to build the life support system, and then we test it. It's our opportunity to find things and fix things before we get it on orbit. We love what we do. We really want to see this system fly and be useful and help a person explore the moon in a more capable manner than they were able to do during Apollo. So it's a great job.
So I want you to perform some isolated joint movement to understand how the suit moves and then be out.
Testing for the new spacesuit continues underwater in the Neutral Buoyancy Lab. Here, the weightless environment of space can be simulated to put the suit through its paces.
So being able to test the suit in the pool and microgravity environments allows us to iterate on our design and make it better and get feedback from astronauts and from other instructors and trainers.
Could you reach all the way across and do the cross switches with your opposite arm?
Oh yeah, it's really easy to get all the switches with my opposite arm. I would rate this as excellent.
Come on. I know, I guess gotta get lower and flatter.
Yeah.
Hold on. Oh my God.
You did it! Very good.
So if this could happen in real life, this is a spectacular translation. Rex and I are very lucky. It is like a, brand new spacecraft.
Even has the new smell and everything.
It does. New car smell.
Spacesuits are also tested in the Active Response Gravity Offload System, or ARGOS.
Yeah, so the ARGOS electronically is able to tune an astronaut exactly to whatever gravity it is that we're practicing that day, whether that's microgravity, lunar gravity, or Martian gravity. The other nice thing about ARGOS is you're able to get the instructors and the engineers right next to the astronauts as they're working, helping the astronaut figure out a problem as they work through the development of that test for the suit or for a piece of hardware and get that real-time feedback.
Spacesuit hardware is not the only thing being tested on Earth. NASA is looking at human performance as an important factor in designing EVAs and spacesuits.
So related to a spacesuit, a lot of times people think about the actual engineering, the hardware, the different pieces, but I want to look at the EVA scenario from the human really inside the suit and make sure that their performance, both physically, cognitively, is going well. So we want to look at things like physical exertion, cognitive workload, injury risk, and really just trying to make sure that they're not impaired by the EVA system any more than they have to be.
The NASA team uses virtual reality technology, motion capture, and other tools to study what it takes for a human to conduct an EVA.
And what we're able to do is bring actual, no kidding data to the table that really removes the opinions. That's probably our primary benefit for how we kind of enhance the EVA community is we take a look at this not from a hardware, not from an operations standpoint first. We look first at the human and then kind of say, what do they need to be able to do to be ready for the job?
All the work on the spacesuit here on Earth is building up to the ultimate test, to fly it in space.
So we're actually building a flight unit of that XEMU, and we're going to launch it to the International Space Station. And we will do an EVA with a current spacesuit, an EMU that we use today, and the XEMU with it. We'll go out in pairs and we'll have the astronauts working together, one in the old suit and one in the new suit, and we'll test its functionality in a microgravity or a low gravity environment out in the vacuum of space. That will help us test a lot of its systems.
The EVA on the space station will set the stage for the future, when the suit will need to perform a variety of missions beyond low Earth orbit.
Yeah, so a great example is NASA's Gateway. So even though it is in lunar orbit, it's still a microgravity platform, so astronauts would still be floating in space. And so we can use a lot of the lessons we learned from the International Space Station to do spacewalks on the Gateway. It's actually really advantageous to use one spacesuit both at Gateway and on the lunar surface. So the exploration spacesuit can do both of those things.
For EVAs on the moon, the new spacesuit will give astronauts unprecedented abilities as they explore the lunar surface.
Really, this is the first time we're trying to bring a suit that's optimized for human performance and optimized for lunar exploration so that you can actually bend down, interact with the ground, so that you're going to have the visibility that you need, the mobility that you need to accomplish these tasks.
This new suit will allow us the flexibility to really do exploration. Get down on the surface and send geologists to the surface and really let them act like geologists in a spacesuit. This is the first time in history that a suit like that will have been created, and it's really exciting to be part of that. To do what NASA was meant to do, and that is to do exploration. And this suit will really help enable the agency go do exploration.
Well, everyone in my generation wasn't alive the first time we went to the moon, and we want to do it again, and we want to do it better. We want to go do more science, we want to stay longer, we want to get more out of it, and we have the technology to do it now. So we're really excited about it.
With its new technology, new design, greater mobility, and greater versatility in how it can be used, NASA's new spacewalking suit is truly tailored for the next generation of space explorers.
Venus, a lost frontier. Humanity hasn't visited the atmosphere of Earth's sister planet in over 40 years. Da Vinci is ready to take us back to Venus. Its massive atmosphere holds the clues to how our neighboring planet went from an ocean world to the runaway greenhouse that it is today. Da Vinci carries a descent probe designed to study the Venus atmosphere from within and from top to bottom, as well as a descent camera that will capture images of the enigmatic mountains of Alpha Reggio. In this massive atmosphere is a chemical laboratory just waiting to be discovered. The spherical probe protects the suite of state-of-the-art instruments from extreme temperatures, high pressures, and acidic clouds. The probe will sniff the atmosphere throughout its descent, and the analytical instruments will work together to definitively measure the composition of Venus's atmosphere. The camera peers down through a small viewing port, and once the probe passes below the cloud deck, it will start to collect a series of three-dimensional views that will also help us understand whether the rocks of Alpha Reggio reveal a story of an ancient continent shaped by water. The Da Vinci probe will take the first ever close-up images of rugged mountains on Venus that may preserve an earlier time. These discoveries will be woven together to help the science community answer big questions about Venus's past oceans, the possibility of ongoing volcanic activity, and why Venus is so different from Earth. This incredible scientific data will be sent back to Earth by communication with the Da Vinci Relay spacecraft above. And the science community will interpret these results for years to come to understand better how habitability evolved on Venus, how climate change may play out on our home planet, and how best to search for habitable planets among the billions of exoplanets throughout the universe.
Ten, 9, 8, ignition sequence start. Engines on. 5, 4, 3, 2, 1. All engines running. Launch commit.
When you think of NASA, you probably think of space exploration, which is a huge part of what NASA does. But what you might not know is that aeronautics, the science of flight, is also an important piece of NASA's directive. It's even in our name, National Aeronautics and Space Administration. In fact, NASA was conducting flight research long before we put a man on the moon. NASA has flown some of the world's most advanced research technologies, leading to innovations in safety, speed, and efficiency. We here at NASA's Armstrong Flight Research Center have been on the cutting edge of aeronautical development in pursuit of our goal to advance technology and science through flight. Our story began in the 1940s when the National Advisory Committee for Aeronautics, NASA's predecessor agency, teamed up with the U.S. Air Force to fly the X-1 rocket plane in pursuit of one question: could an aircraft and its pilot